We welcome you, sir. Professor V.K. Sharma is currently Senior Professor, Disaster Management and Consultant at Indian Institute of Public Administration. He is also the Vice Chairman of Sikkim State Disaster Management Authority. He is a member of Science, Technology and Innovation Policy of Government of India, STEP 2020. Professor Sharma is a member of several committees that includes the High-Powered Committee on Disaster Management, Committee on Alaknanda Floods, National Committee on Disaster Management. I would request Dr. Sangeeta Bakshi to please welcome Professor Sharma with a green token of appreciation. Thank you, sir. Thank you for being with us. Start. It's up to you, sir, to start the session. Yes, sir. Here. अच्छा, fine.
उसने लॉग इन लॉग आउट कर दिया था सर को यहाँ से करना है उनको प्रेजेंटेशन चाहिए
मेरे से मत करो कैसे कर रहे हो लॉग आउट कर दिया ईमेल से लॉग इन किसने करा
सर वो वहाँ पे हो रहा है वहाँ से हम प्रेजेंट करेंगे वाले
सर वहाँ से present
So good morning friends and
At the outset, I will say that thank you very much, for inviting me in this very important conference. And as this topic uh, is of great relevance, to all of us, we are all talking about climate change, its impact. But I think now we should think about the resilience. And you might be knowing that our Honorable Prime Minister, he announced, a coalition of disaster resilient infrastructure. So on infrastructure side, we are taking care. India and Britain, they started this CDRI program, which is which is taking off, I should say. And many countries, they have joined that. But we will talk on agriculture, water, natural resources, which is again very important, and how climate change resilience will be important for agriculture sector and water sector. And this half an hour, I'm sorry that we have already spent 20 minutes, but in 20, 30 minutes, I would like to sensitize you that what are the issues. And in the international forum like this, I would like to tell that what India is doing actually. So what are our initiatives which we have taken in this country? This I would like to focus. This is known that in last 2 decades, in case you see the losses because of natural disasters, definitely climate change is having impact on climate-related hazards, and that's why the impact is obvious and huge loss, economic loss, I should say, 2,900 or 3,000 $1 billion loss, in case there is, and it is increasing, consistently. In last 4 decades, 68%, and now, out of this, the contribution of climate-related hazards or impact is much more, which is about 77%. In fact, the more than 90% is climate-related, which is mainly flood and drought in this country, but storm, heat wave, and now some other things, are also related like forest fire. And so I think 90% or 91% is contribution of climate-related hazards. And this is the issue actually. Why we are concerned, why we are talking today on agriculture, why we are talking water, because the whole governance now, I'm having a program which is supported by Department of Science and Technology, which is talking about climate smart governance. So in climate smart governance, we are sensitizing officers that there are different sectors, and each sector is affected. But our priority, for example, any district, district magistrate will have to see agriculture, water availability. So this food security, water security, they are the major issues. And this, we, in IIAPA, we are having this program. Climate change is important for us and for other countries of South Asia, and because of 2 reasons. Because of our population and because of poverty. Third aspect is that people are based on agriculture, more than 50% population is still getting employment in agriculture. So in case this, we will not see this impact and will not do something now, then it will be too late. Then this dependency on agriculture, as I told you, that 51% population of this country is still depending on agriculture, and they are getting. Then we are having more than 7,000 kilometer long coastal line, and this is again the sea level rise. And there was a team of NDMA in Odisha last week, and they were saying that the not only Satbhaya region or one or two districts, but the impact is visible, in the whole, all the coastal districts, and this is there. Then we have a large area which is rain-fed still, more than 50% is still, it is rain-fed, and the organizers may connect it, with the electricity, I think. Yeah, I think it's okay. Then the extreme heat. Okay. Then because agriculture and rainfall pattern is changing, that's why the whole agriculture impact is visible. Start with seed germination up to the growth and the entire phenology is affected by climate change. Then soil health, soil erosion, I think these are the issues which we will discuss in these another 10, 15 minutes. I think we all know that internationally at that level in Paris Agreement, what we have decided. Important is not that what were the decisions which we have taken. Important is what we are doing. And that I would like to explain to you that there are so many commitments by different countries, but India is doing a lot in carbon, emission cut, in solar energy. Whatever targets we have given at in international forum, we are doing a lot. And that we would like to explain, to you. Agriculture, as I'm saying again and again, that more population is affected, and in case, as per Paris Agreement, in case it is 1.5 or 2 degrees Celsius, even then, the impact will be much more. And this impact will be more on productivity, on our growth, and in case, for example, wheat, people are giving different data and very scaring data that in case this temperature rise will be there, then the productivity may fall up to 30%, in case of wheat, and similarly for other crops. And so this is the concern which we are having today. This I have already told you, but important thing is that we have a small land holding, and this is our concern. It's a policy matter. Government of India, gave a policy recently. There was, 3 acts, but we couldn't convince our farmers that this is in your favor. This is small land holding in case you don't have cooperative farming, unless and until you, there is investment, in agriculture, you cannot do much. So I think we will have to convince them that these policies are for you, this is for your benefit. And in case, scientists and people like you, in case you, give evidences with the help of data, with the help of, because a lot of work is being done by agriculture universities, by different institutions. So in case you can convince that this is the right way, then I think it is possible. But issue is there that 80%, 90% of our farmers, they don't have much land holding. And science and technology, yes, we know, but how to do it, in case you have a very small piece of land. Then the impact which is visible, drought, it is already, India's main problem is flood and drought. And it was there when we become independent. In 1947, we were having only 11% land which was irrigated. Today, we have about 46, 47, and some data is saying 48% land is irrigated. But, and that's why we are producing, food or excess food, I should say. There is no, scarcity of food. But in case people, in case we see the climate change impact, in case we listen to Professor Swaminathan and other, learned people in agriculture, they are saying that this productivity will decline in coming years. And different data is available. I would like to share with you that how much will be the impact, which is then the role of agriculture. We know it that in GDP it is having substantial role. 21% our GDP is from agriculture. It is giving employment to the people. So I think agriculture is the base, for economy. And employment. So not only informal sector, but formal sector, because it is also giving, products or produce to the industries. So it is connected with both, formal sector, informal sector, and that's why agriculture become important for us. Food security, we were talking to, our UN friends, and they are also concerned that the food security means the availability, accessibility, and affordability. In this country, when we are saying that in the country 25% people is still below poverty line, and in some of these states like Bihar, where more than 50% people are below poverty line. And there, I think these extreme events, the impact will be much more. And the total production of food grain, there will be shortage of food, then there is price. So all these things are important, and that's why we are discussing these issues in these sessions. Friends, I think the challenges are known to us. I'm working in disaster risk reduction since last 30 years, and I know that drought is our major issue in India right from the beginning. Earlier we were having famines, and thank God that we have come out, from that phase. But I think another trap is coming, that is the climate impact. And that's why drought, flood, cyclone, and now the new things which are coming up, the heat wave, the cold wave. And this is all changing our, agriculture pattern. And all the agriculture universities, I mean, there is hardly any exception. They are all working on it. They are producing, local varieties. They are producing resistant varieties. But I think the dissemination of this knowledge and acceptance of that is an important challenge for us, people like who are sitting here. I mean, policy issue is one. But second issue is that whatever we have done, Pantnagar or, Gujarat or any agriculture university, IARI, they are doing a lot. But how this, product or how this information which is available to us go to the farmers. And Ministry of Agriculture, they have, a contingency plan for all the districts. We have, but this contingency plan, because agriculture is again a state subject. So a state will have to be involved in this process and, sensitize farmers that what kind of shift, is required today in agriculture. Pest attack is another issue. Heat wave, cold wave, I have already discussed. And high frequency and low intensity, I mean, these things. In drought, I think there is a bigger thing. Professor Anil Gupta is sitting here. He organized a very important webinar one day, and I attended it very, with great interest. That was on flash droughts. And flash drought become a very big issue in India. There are many countries where we are facing this, but India is one country where flash drought will be major issue because our soil, when the moisture, goes below 40 and within no time, and the impact will be there on crop. There will be short-term impact, there will be long-term impact, there will be impact on productivity, and that is again an issue of climate change. I think I don't want to confuse you, by showing this slide. I want to say that we have different climatic zone, agroclimatic zone, and in each and every agroclimatic zone, there is impact of climate change visible. And we have, prepared a very, beautiful data that which disaster or which hazard will become prominent, and what will be the impact on agriculture. Then this impact, I have already told you. Then soil, I think, it's again very important. And the soil moisture and this kind of thing. Then biological health of the soil, because this heat, this is also affecting the microorganism. And that is again a challenge, to us. Soil erosion, which is there by flash floods and the condition which we are seeing, in all Himalayan states. Today, I think almost every Himalayan state is having flooding, and this flash flooding, there is impact on soil, and the main thing is soil erosion, because that will reduce the, minerals, or I should say the, fertility of the soil, and impact on, growth of the. So I think we have to build, resilience in soil, and we have to adapt, varieties which are now evolved, locally by our scientists. And then the most important thing will be the water-saving technologies, which I will discuss little later. So because now there are 2-3 things which are important for us, which is in the platter of each and every scientist. Paris Agreement is one, but the Sendai framework, which is talking about risk and risk reduction, and third is the SDGs. So all sustainable development goals, directly, indirectly, start from poverty up to the, I think they are all, so we'll have to see it, together, and see that climate change, how it is affecting our sustainability, sustainable growth, development, and that is again an important thing. I'm coming to the resilience, and I will take just 5 minutes more and I will finish. I will say that in agriculture, I think resilience will be tolerant crops, and that I have already told you that many universities are working on it. We already have Ministry of Agriculture, you go there, you will see that there are, in case there is delay of 15 days, there is a variety which you can grow. So we have given alternative, but only thing is the dissemination of that knowledge to the farmers and the acceptability of the farmers, that they accept that. Then the water management, which is very important because agriculture, 85% of water is used by agriculture. Then the livestock, which is related with the agriculture. Then soil, health, soil organic matter, soil moisture, and food management and feed management, and then the agro advisory. I think again very important thing, sensitizing the people who really matter. Many national programs, and this is for international participants. I will say that India is very sensitive about it. We know that what is going on. The scientific data, DST, TIFAC, all these organizations, they are very sensitive about the issue, and they are, so we have a mission, because we have several missions. One mission is National Mission on Sustainable Agriculture, which is looking after this thing, the impact of climate change on agriculture, and Ministry of Agriculture is, working on it. But there are many flagship schemes which is started by government, like Pradhan Mantri Krishi Sinchai Yojana, Paramparagat Krishi Vikas Yojana, where traditional wisdom, knowledge, can be used. Green India Mission, Soil Health Card Scheme, National Project on Organic Farming, National Agroforestry, Manrega. Then there are several states, which are going for organic. Sikkim become organic state, and I am proud to say I am vice chair of Sikkim State Disaster Management Authority. And one good thing, for risk reduction is that it is an organic state. And it is one state which is having less population. So the issue can be, Then I already mentioned that ICAR has started, resilient agriculture, this program. We have contingency plan for 650 districts. About 151 districts, established as climate resilient villages. So I think we have started working, and we are working with SAARC countries and disseminating knowledge, giving them whatever we are having with us, The initiative taken by the, ICAR, by the, NDMA, NIDM, for example, the National Agriculture Disaster Management Plan, which is prepared by NIDM, and this is accepted by Ministry of Agriculture. This is having a very, very important component, on drought mitigation, short-term, long-term measures. And I think this is a very, very good, efforts done by NIDM. ICRISAT, is also doing at climate smart technologies. Then there is a National Center for under Ministry of Agriculture and Cooperation, which is talking about climate smart agriculture. The Center of Environment Science and Climate Resilient Agriculture in IARI. So I think we have, then we have the legal, this thing, because we have Disaster Management Act 2005 and the Section 37(1). This is giving the ministry that it will draw its own plan for prevention, mitigation, and under that, NIDM has prepared this plan, which is talking about preparedness and mitigation both. Then the, all these things I think we have already discussed. The available documents, for example, Agriculture Disaster Management Plan, which is, I already mentioned, Drought Management Plan, which is there in Ministry of Agriculture, Crisis Management Plan for Drought Manual. So all these things, at district level, district plans, they are available. We have different guidelines, which is prepared by NDMA, and similarly, there is a guideline for drought also. So what are the way forward actually? The way forward is that, of course, agriculture, which can reduce, greenhouse effect, then capacity building. I think training at different level and sensitization of senior officers to, grassroots level officers. Then fine tuning of gaps, what are there between the current management practice, and then the, climate resilient agriculture and this implementation of this program. Then farmer oriented programs, and these are the things, which are required. I think main thing is water. And let me tell you that in case you use modern technique, so it is not only Israel. I think many countries are now example. Even Iran, even Egypt, I think they are using these techniques. And River Nile, the water is the same. But I think the agriculture land, they have increased 4 times. Because of this, use of modern techniques, they are using, this is from Egypt, and they are using, all techniques so that evaporation can be minimized, so that the soil moisture can be contained, and not only using, variety which are adaptive, to that soil, but important thing is that use of water, efficiency of water. And in India, I think still most of the states we are for the flood irrigation. In case we minimize that, because 85%, in case we do up to 50 or 60% water, then more water will be available for drinking, more water will be for development purposes. So I think this is important, and we will have to give emphasis on this. And because otherwise, in water stress, we are ranking 13, and this is very alarming. We have data for different reasons, and I think each and every region starts with Indo-Gangetic plain up to the Himalayan region, and each and every state is affected. Friends, let me tell you that in India, as far as data is concerned, our groundwater board, they have done fantastic work. 80% of the aquifers they have already mapped. We have information that which state and how much water table is going down every year. So it is Indo-Gangetic plain, it is not only 6 to 8% centimeter, every year. In some of these states, it has gone up to the 12 centimeter or even more. So I think that is our concern, that in case this groundwater is mining will continue in agriculture, then I think the impact will be very, so this data we should use, which is available, and given by the scientists for different reasons. And then the building resilience, I think water, I think we should have, because water is one sector which is not, there is hardly any investment. Nobody is investing in water. It is low priced. It is, totally, neglected sector, I should say. Any, politician can say, free water, free this thing, no, that kind of policy issues. I think we should be very, very cautious about it when we say, because water pricing and all that, I think these are the issues which are important for us in case we want really water conservation. And demand and supply, because in 2050, the scientists are saying that the demand will be double. And by the end of this century, the demand will be much more than that. So I think how you will meet this demand. You are having, 110 centimeter rainfall, but this rainfall is mainly, in the northeast region and going to the sea. So now the extreme weather event, cloud burst, all these things become obvious, and that's why we are seeing the impact. Yesterday, I think you might have seen today's newspaper that Himachal Pradesh, Uttarakhand, all these things, are affected by this. In 1 minute, I will finish. And so adopt new technology, innovations, then promote, water system decentralization, water pricing policy. I think we see our national policy 2012 very well laid down. 2019, we have added this, concept of climate change and its impact. Now, another few things, we are adding to it, and it will be available to you for use. So I think the water crisis will be, water is a very important thing, and this I have already discussed, and it is a policy issue. It is everybody's issue, and that's why now our in the 75th year of the independence, Government of India has announced that in each and every district there should be 75 ponds, so water bodies and river systems, and so I think integrated water resource management. We are doing a lot, because we are having sewage treatment plant, effluent treatment plant, but reuse of this water, I think that is important. If it is going back to the river, then there is no use of that. It should be utilized, in agriculture, it should be. So I think that type of concept. And I will stop here by saying just last sentence, that these things are not separate actually. When we say disaster risk or risk reduction, then I think each and everything is coming in that. And because of climate change now, the risk is increasing. And this risk is not only the, for life loss of human being or animals, this is for our agriculture also. The impact of agriculture because of flood, because of flash flood, because of drought, because of flash drought, and heat and cold wave. I think this we will have to see very, clearly and work on these things. Again, I will say that policies are there. The only thing is implementation of these policies. And that is important. And our scientists, I think we should be, I'm proud of our scientists of this country. As far as data is concerned, I think we have enough data, to have modeling, to have this. But I think reaching to the last person, reaching to these farmers, telling them that what is required, how crop, rotation or shifting of this agriculture is important for you. This point is important. And once again, I thank the organizers, for inviting me in this important workshop. Thank you so much.
Thank you so much, sir, for this insightful and motivational lecture. To sum up all in such a short time, on behalf of TIFAC and IASA, I would request Dr. Sangeeta Bakshi to felicitate Dr. Sharma with a token of appreciation. Thank you so much, sir.
I think we are, I think 15 minutes late from our normal schedule. So we have to immediately quickly start our next session. So like you can join Tagore, Mirza Ghalib, or who wants to stay here for this session, like speakers can split in all the 3 rooms quickly. Yeah. Thank you so much.
Take this. Take my bag. पीपीटी लोड हो गया होगा शेयर पे प्लीज ये शुरू करना है मैं जाऊं
Agree.
Good morning, everyone. Welcome back to a third day of the International Conference on System Analysis for Enabling Integrated Policymaking. I'm Harsha Mohan, and I feel privileged to extend my warm welcome on behalf of Technology Information Forecasting and Assessment Council, TIFAC, and the National Institute of Applied System Analysis, IIASA, who have clubbed all of us for a system analysis approach in sustainable development. I extend my deepest gratitude to all my dignitaries, honorable speakers, and guests for your esteemed presence at the assemblage. So the theme of this session for today is Resilience to Climate Change in Agriculture, Water, and DRR. Just to brief, the goal of the session is to bring together discussions on strategies like climate smart agriculture, CSA, for climate resilient agriculture systems, disaster risk reduction strategies, and sustainable water management and agro-meteorology modeling for extreme weather events and climate change. Now, it's time for me to invite our keynote speaker who will formally start the session, Dr. Pradnya Petnakar. I would request you to please come up on the stage. Dr. Pradnya Petnakar is the head of program operations in United Nations World Food Program. She has a vast experience working as a program officer for United Nations World Food Program as well as National AIDS Control Organization. I welcome you, ma'am. Since we have few of our speakers joining virtually as well, and I would request Dr. Petnakar to please advance the session.
So much. Good morning, ladies and gentlemen. I think this is a great opportunity, I must say, to really talk on this important aspect of specifically the climate smart agriculture. And I'm really hopeful that we are going to have some rich discussions here. So I want to extend a warm welcome to all esteemed panelists and the participants in today's discussions. The International Conference on Systems Analysis for Enabling Integrated Policy Making is very timely, and it offers a great opportunity to share the experiences, knowledge, and learnings. I'm thankful to the organizers on behalf of WFP for inviting me for this forum, and I'm really humbled to be a speaker at this forum. Indeed, I'm on a more learning curve and really look forward to listening to some great deliberations and presentations in today's discussions from the experienced senior speakers. So as has been requested, I'm just extending some introductory remarks, and I'd like to draw your attention to some of the challenges the world is facing today. The speaker just before me, Dr. Sharma, has laid out quite a kind of scenario ranging from climate disasters, resilience building, and DRR. So when I'm talking about the global challenges, the first and foremost challenge that the world is facing today is the global challenge to food security. So food insecurity across the globe is on the rise. And the main drivers which are identified are the extreme climate events, economic shocks, and conflicts. Record high food prices have triggered the crisis that is driving millions into extreme poverty, magnifying the hunger and malnutrition, and in fact reversing the hard-earned gains of last decades. Indeed, the world is moving backwards at this point in time, specifically in the efforts to end hunger, food insecurity, and all forms of malnutrition. The second point or the second challenge which I want to draw your attention to is the population growth and the changing diet across the world. And they are really driving the demand for food and the production and is struggling to keep pace with depleting natural resources such as soil, water, and also the biodiversity. And this has a kind of huge implication on the agriculture sector specifically. The food security challenge will only become difficult as the world will need to produce more than about 70% from what we are producing today to feed the population of 9 billion people by 2050. And the third challenge that I want to really again draw your attention to is the challenge of extreme vulnerability of agriculture to various factors. The climate change has negative impacts, and those impacts are already being felt in the form of increasing temperatures, weather variability, shifting agroecosystems, and invasive crops and pests, and also more frequent extreme events, which we are experiencing. On farms, climate change is reducing crop yields, the nutritional quality of major cereal crops, and that we have seen that even the composition of the usual cereal which we eat, it is not adequate and it is changing. So the wheat which we used to eat earlier, what nutrient it used to give earlier is not same as what we are getting now. And also the same thing is visible on the livestock and their productivity. We also know that agriculture itself is a major part of climate problem. It is currently the known statistics that it generates around 19 to 29% of global greenhouse gas emissions. And without action, the percentage of this would really rise substantially as other sectors reduce their emissions. Additionally, 1/3 of food produce, as we all know, is actually globally either lost or wasted. And addressing food loss and waste is something which is very critical to helping meet the climate goals and reduce stress on the environment. It is in this context, the discussions and deliberations on climate smart agriculture become much more important and urgent to address the current and future needs of the food insecurity. The concept of climate smart agriculture was originally developed by FAO and officially presented at the conference at Hague on agriculture, food security, and climate change in way back in 2010. So the concept is not new. And this paper was entitled The Climate Smart Agriculture Policies, Practices, and Financing for Food Security, Adaptation, and Mitigation. So as the name indicates, climate smart is an approach that helps to guide the actions to transform agri-food systems towards green and climate resilient practices. So climate smart agriculture supports reaching internationally agreed goals such as Sustainable Development Goals and Paris Agreement and the national goals as well, which are developed under NDCs. The three main objectives of the climate smart agriculture, as we all know, are sustainably increasing the agriculture productivity and income. The second most important objective of climate smart agriculture is adapting and building the resilience to climate change. And the last one is reducing and or removing greenhouse gas emission where possible. So with these three objectives, the whole focus is on the adaptation, resilience building, mitigation, as well as sustainability. As I said, that despite this was actually introduced in 2010, it is well recognized that its importance is very much increasing. The dissemination and uptake of climate smart technologies and tools and practices is still largely underutilized and is facing challenges. The adaptation to climate smart or climate related knowledge, technologies, practices to local conditions, promoting and learning by farmers, researchers, extension personnel, and widely disseminating climate smart agriculture practice is extremely critical and is becoming, in fact, urgent now. Some of the important approaches from the perspective of climate smart agriculture, they include the first and foremost is, of course, creating an enabling environment, which essentially means that the coordination and integration of various sectors dealing with climate change, agriculture development, food security at various levels such as national, regional, global. And the key requirement for creating an enabling policy environment, which also includes the incentives for adopting climate smart agriculture. Because as Professor Sharma was also saying, that the policies are there, but how do you really ensure that those policies are really addressed, or how those policies are implemented? In such case, the policy environment has to be also conducive to implementation, where such incentives and all those mechanisms actually can help. So why the farmer would invest in those kinds of technologies is something which in fact has to be brought to the attention of policymakers. So supportive policies such as mainstreaming of climate smart agriculture in the core government policies, rather than looking at it as a kind of standalone experimentation, is something which is again one of the important part of the policy framework. The second important aspect is integrated approaches or integrated practices. Now, when we are talking about integrated practices, the habit of looking at various aspects in silos has to be really overcome. Integration can generally or greatly reduce the pressure on natural resources and minimize the needs for external inputs. For example, may it be energy, may it be chemical fertilizers, or may it be pesticides. And again, I draw the attention to the small land holding and the need for really investing in cooperative farming, or some kind of the technologies, for example, looking at the climate advisories and using those climate advisories to really take decision at the last mile. The climate advisories, they need to be tailored to the needs of the farmers who are really going to act on it, and not just from the purpose of pushing those for the purpose of pushing it. So the next important thing is also the crop varietal selection. And as we have said, that there are a lot of new varieties coming up which are more looking at the crops which are more climate resilient, where they are really being grown, looking at the agroclimatic suitability of the crops which are being selected, plant breeding, then cropping patterns and ecosystem management approaches, which are extremely important for resilient change. Livestock can actually be make large contribution to climate smart food supply systems, and so are the other factors such as forestry, which is again an important component. Climate change jeopardizes the whole delivery of goods and ecosystem services from forests and trees, and that are essential to livelihood and food security. So from the perspective of, again, urban and peri-urban agriculture, genetic resources, biodiversity, fisheries and aquaculture, land water management, proactive drought management, energy, food loss and waste management, and their advanced techniques in the biotechnology are some of the important aspects and components which are definitely important to be taken into consideration when we are dealing with climate smart agriculture. Similarly, one of the important thing is the improvement in investment of funding for these initiatives, because these fundings, this is a kind of deviation from what is usually happening, and so that definitely needs investment. That also means that there is a change in habits, there is change in behaviors, and so the funding is something which is an important aspect. I'm happy to state that WFP has facilitated financing to multiple countries through the climate financing such as Green Climate Fund or Adaptation Fund and others. So at the end, I'd like to actually just pose 3 questions and rather 3 points may be deliberated today or maybe actually are important for deliberation across as we go forward and want to really strengthen the climate smart agriculture systems. So the first and foremost is, do we have the plans and policies in place? What are the good practices? Do we have some examples of good practices somewhere in the world? India, of course, we are going to hear some good examples today itself. India has a climate smart agriculture kind of program as well, which is being implemented by Ministry of Agriculture. However, what are the successes? What has really facilitated to change? Are there those kinds of learnings which will further inform and refine the policy frameworks? The second important question is, are the investments adequate to meet the mammoth challenge which is forthcoming, which is ahead of us? We used to actually think climate as a kind of what is going to happen tomorrow. Slowly, in just 1 or 2 years now, we have started saying that what is happening today. So the change is required today and it is like no time there. So is the real investment and finances adequate to deal with this kind of mammoth challenge? And if not, what are the measures, what are the options, and what are the kind of plans again that we have? And the last but not the least, do we have adequate localized tools? What happens is, I mean, even if we have some stories elsewhere, we don't know how they are going to be implemented, how they will be customized, how they will be contextualized. So are there some kind of such tools which are localized and experience and evidence that supports the countries across the globe to have a cross-learning? Are there enough mechanisms to have this cross-fertilization of ideas and all? So I'm sure that I'd like to stop here and listen to the thoughts from the esteemed panelists today. And also, I'm sure listening to them and exchange of knowledge through such forums, maybe at the subnational, national, and then regional and global level, will help to create adoption of climate smart agriculture much better, much faster, and much easier. So thank you so much. So with this, we'll start the conversation with our esteemed panelists. I understand that 3 panelists are present here. So I would like to invite Professor Pennan Chinnaswamy. So Professor Pennan Chinnaswamy is the founding director of Rural Data Research and Analysis Rudra at IIT. He is also an assistant professor with Center of Technology Alternatives and Rural Areas. His interest lies in adapting open source remote sensing and government data to research on complex problems using open source modeling software and application. Thank you, Mr. Pennan Chinnaswamy. I also understand that Dr. S. Bandyopadhyay is here. So I would like to invite him as well on the table so that our panel is here. So Dr. Bandyopadhyay is presently an associate director at ISRO headquarters. His research work encompasses satellite data application on inventory and management and natural resources, particularly in the domain of land, water resource, and environment. He has published 30 research papers in national and international peer-reviewed journals. The third panelist we have today is Dr. Chandrasekhar Bahinipati. I would like to invite you, sir, as well. So Dr. Bahinipati is Assistant Professor, Humanities and Social Sciences, IIT Tirupati in Andhra Pradesh. Dr. Chandrasekhar is presently working as assistant professor in economics in Department of Humanities and Social Sciences at IITT Tirupati. His major research interests include climate change, economics, environmental economics, behavioral economics, natural resource management and development economics. He has published several research papers and has been acting as a review editor for Frontiers in Climate Journal. We have some of the panelists who are joining us online, and they include Dr. Suruchi Badwal, who is Director Earth Science and Climate Change at TERI, New Delhi, Professor Ebizner Florano, National College of Public Administration and Governance, University of Philippines. We also have Dr. K.V. Ramesh, who is a Senior Scientist and Structural Engineering Research Center at CSIR. So I invite all the panelists, and the time that we have is like around 40 minutes. So I would really like to hear from all the panelists, and maybe what we can agree that about 5 to 7 minutes presentation, if that much time would be available with each one of them, so that there is time for discussion of around maybe 10 minutes.
Yes.
Right? So thank you so much. So may I invite Professor Pendan Chinnaswamy to please deliver his speech. Thank you.
What we'll be doing is, just for the 7 minutes, I'll cover a case study and how this has worked in India. Because, next please. Yeah. Point is working, but the slide is not changing. Yeah. This one. Okay, so I'll be talking about groundwater in particular, because this is UN's water theme. This year is for groundwater, making the invincible visible, right? So in climate change scenarios and for farmers, groundwater has been the key for increasing the productivity, and also it has been the greatest climate change buffer. For example, during droughts, you go to groundwater, and during floods also, if the water is not good and all the water is gone from the watershed, you go to groundwater. How is this sustainable? Because we are pumping so much, and there is a need, as the speakers before told, like there is a need for holistic management and integrated approach. I will give an example of a bottom-up approach, which is MARVI. MARVI stands for Manage Aquifer Recharge Through Village-Level Interventions, funded by CSIRO, now uptaken by the Government of India and World Bank. And then how do you create ownership? So these are the current issues we know, which has been covered very well. What happens is we have all these wells in the picture monitored by the government. Sometimes it doesn't give the correct picture of the farmers, because the farmers are too much distributed and the landholding size is so small. At the end of the day, we are the highest groundwater extractor in the world with 245 kilometer cube per year. So how do you bring this technology of monitoring and helping smart technologies reach the farmers? So what we did is, whose water is it? We first brought this to the picture. So each person or each entity stakeholder looks at groundwater differently. The government agency may say that it is a communal source, but the farmer may say, no, it is my source, it is my well, and I have to use it wisely. The engineer talks about deep and shallow aquifers, but that extension or that knowledge is not shared with the farmers. So how do you bring them on board? Is when you include them in the monitoring phase. Then they know how much water they have, and they can plan wisely for the water use. So this is the example of a top-down approach. When there is a problem, for example, there is a groundwater issue. You see a mother and child waiting for water, it doesn't come in the pump. Suddenly the policymaker, what they do is they go to the banks, which could be your World Banks or NABARD, which funds some water projects for the village. However, it's a short-term approach. Here, there's no feedback from the people or the farmers to the policymakers. So that is where we need to augment observed data, build a public-private partnership for data using a bottom-up approach, and also monitor, measure, and then manage. So this, without monitoring, we have started to manage it, and unfortunately, it is not working. So this talk would be giving an example of how bottom-up can work, and I'll give you an example how it looks like. So the same issue here, we do have the farmer, women and the child waiting for the groundwater for drinking. We also collect data, so we're going to go cyclic on this picture. So we first collect data. In the meantime, the policymakers are talking with the banks and getting some projects for the water, but we still collect a lot of data, use high-end AI and ML analytics. And then as Dr. Sharma said, there is a lot of teaching and research extension that is needed. So that we build into the system. So in Western countries, something technologies are easily transferred to the people through extension networks. That is missing here. So we are going to use technologies that are developed in high technical institutes like IITs and create extension materials for them. Okay, so we first define the problem, collect big data, which includes all data sources, including surveys, farmer data, satellites, drones, government observation data, all these data. So once all these data come in a pool, we have a big data kind of a scenario to use for understanding the problem, where we collect, clean, collaborate, and then communicate the research methods. Now we go back to the policy and landholders, and then we say that how you can manage the water better. So this is a cyclic approach and a dynamic approach wherein anywhere our resolution or our research doesn't work. So we can come back to this data. We can come back to this data and then build more robust models. Right now, that bottom-up feedback to the dynamic models is not available, and we are going to create it. So what has this created? Let's take the case study, as I said. So this is what we do in this lab called Rudra, which is called Rural Data Research Analysis Lab. A very specific lab created just for rural data analysis. Marvi is the project, I've given it. It's a public participatory approach of sharing data and then building knowledge with the Australian partners. And this is how it looks. So we have Marvi at the center, we have researchers, we have Bhujal Jankas, who are the local volunteers trained by the researchers in the Marvi project. We have the state and government agencies providing data and other accessories, and then the village and school communities. So all they do is they monitor all the water resources in the watershed. It could be groundwater, it could be your check dams, surface water, rainfall, discharge, everything. And we train them on these concepts. Because of time, I'm just going through. But these are the maps and data that the farmers have created. Normally, we give the data to them, right? We give a watershed boundary, we give a land use, land cover map. But look at how the farmers and the locals are preparing these maps with the trainings we gave them in the local language. And we also created an app where they can monitor the rainfall, check dams, water levels, etc., etc. So when we first introduced this, there was a question if farmers are trained to use this. What we casually said is no one trained them to use TikTok or other apps, but they picked it up. How? Because their interest and the need was there. So same thing, we initially went through this and they're very well now putting the data and monitoring it. So now what has happened is you can see a heat map generated by the locals by themselves, right? So the farmer is giving the data, the heat map is generated on the left-hand corner. What should I press? Okay, thank you. It's still here on. Okay. Yeah. So what happens is this heat map tells what is the net available groundwater in the village. So now this data doesn't come from the top down, from the government to the public, but the public is giving the data to the government. So now all these farmers have better ownership of how to save the water and share the water. It's no longer a single person's water, it is a communal water. Now they have better management scenarios like diversification of crops or sharing the profit or loss, and more understanding on how this works, right? And because of this public participatory approach through the MyWell app, there has been village farmer communities called village groundwater cooperatives, where they participated in the data collection. They estimate how much water is available before the Rabi season or before the non-monsoon irrigation season. And they collectively take an estimate of how much acreage they're going to cover and what crop. They cannot all grow sugarcane if the water is not there, so they will have to sacrifice all for the same profit. So collective discussions are taken, addresses water equity, shares, reduction in losses, and sustainable agriculture. So this has also enabled us to move out of the project and go to another village or another area, because now they have the data, they have the training, we have trained them, the trainers of trainers are there, and we have exited freely. Now we are going to South India. So this was done in Rajasthan and Gujarat. Now we are moving in the South to do the same things. So at the end of the day, more data can be synergized. So while the farmers are collecting data, we are also using the smart tools like ICT, IoTs, and IOEs. So ICT, everyone knows that's a lot of communication tools. On the top, you have some examples, Plantex app-based models. And then IoT is more on the precision farming, agricultural drones. Whereas IOE is connecting everything through the internet, like farmers and the markets, right? So we have reduced these losses, and this Nature paper, which recently published in June, says ambitious partnerships are needed for reliable climate prediction. So the top-down approach, where you have global circulation models and data coming in, is no longer enough. We have to have these ambitious partnerships where everyone pitches in data. So with the last slide, the work was a 5-year project. 2 years was just put to sensitize with the farmers, talk with the farmers, bring them on board, and make them understand that when they collect or give the data, they're not going to be taxed. It is for their use, right? So now this book has been released. Jaldut is a manual on how to train the farmers, how to collect data. It is a very well-established approach of a bottom-up key approach, and it has been accepted in the Jal Shakti mission, and also all these banks and development agencies are looking at it. So the smart tools can aid. So as I said, all the high technical institutes are working on ICT, drones, and then low-cost sensors. But how can you train them through these integrated apps, and also spoken tutorials like FOSSI, which is the program in IIT Bombay. We give tutorials in 60 languages across the world. So we have actually established how to train them. With this, I will stop with my 7 minutes. Thank you. Questions?
The last, otherwise the speakers would have lesser time. So may I invite the second speaker, Dr. S. Bandyopadhyay, to share his presentation and thoughts. He will come in. Pointer. So it's still there. Means so.
Very good morning. I thank organizer for giving me the opportunity in the international conference for the system analysis and enabling integrating policy making. Today I will speak on the space technology, how it intervenes in climate smart agriculture. As we know, the remote sensing is a tool, and that gives the opportunity for the satellites having the synoptic views from the space to observe the ground. So we can see a whole set of area which is required for monitoring these agricultural crops, surface water, and the landscape, land cover, land use, so etc. Now, this type of a setup which exists in the ground can be observed through the satellites, and it also helps to plan the agricultural operations in the realm of the climate change. So climate change, as we know, is a global problem, and UN has already predicted that the populations will increase to 9.7 billion, and also the greenhouse gases are increasing in the atmosphere, and this is creating the change in the temperatures, and it will certainly affect the water and agriculture in the coming decades. So if we look into the different dimensions of the agriculture, smart agricultures, we can see the three concepts, which is, you can say, these are the philosophy, and this philosophy is practiced in the field where the climate smart agriculture is in the core, and the total arena of this agriculture which is being practiced is the conventional agricultures. And the difference between the conventional agriculture, precision agriculture, smart agriculture, and climate smart agriculture is narrowing down day by day. As we can see in the conventional agriculture also, we are using high yielding variety, water is managed. Earlier, the flood water is used, fields are flooded for giving irrigations. Now people are getting matured, and how economize the water use, they are also understanding. A lot of extension activities are going on thanks to our the research institutes and government organizations. So if we see in that perspectives, the climate smart agriculture is smart weather, smart water management, smart crop management, knowledge management, and farming practices. So if we specifically see what is the precision agriculture, it is nothing but the input optimizations, and it provides the opportunity to intervene and mid-course corrections in the where these field sizes are small, particularly in these foreign countries. They uses the VRT, variable rate technology, where the tractor-driven or truck-driven nutrient pesticides with GPS maps, it goes inside the field and spray wherever it is required nutrient, wherever it is required pesticides, where the soil test is done, and that map was fed into the computer. Okay, sorry. Now, where this space technology comes in climate smart agriculture, if we look into this different perspectives of the climate smart agriculture, the crop management, soil water management, agroforestry, livestock, and integrated food and energy, where the space technology is used for crop inventory, watershed development, horticulture, crop management, even solar energy harvesting potential using this albedo, which is nothing but the reflectance, incoming solar radiation and reflected solar radiations. It is the ratio. So these can be estimated using the satellite data. Now, if we see the crop management and crop survey, so in last 5 decades, space technology is being used. When the ISRO used NASA's Hasselblad camera, that is the thermal camera, to map the coconut wilt disease. So what happens, this thermal camera, when it goes over this, it was fitted with the helicopter over these coconut plants in Kerala. The temperature difference where the wilted plants having the higher temperatures and where the normal plants having the lower temperature because of the transpirations of the plant. And it gives a clear differentiations between the disease plant and the normal plant. Then comes in late 1980s, the project started called crop acreage and production estimations. And from there, it became the forecasting agricultural output using space, agrometeorology, and land-based observations. It is an integrated approach, and it earlier in Cape, it was pre-harvest forecastings before harvesting, but in case of Fasal, there is multiple, during the initiation of the crop, mid-season of the crop, and before harvesting, multiple forecast is given. And this technologies has been transferred to Ministry of Agriculture at Mahalanobis National Crop Forecasting Center. And they are using operationally this technology around 9 crops at the present time. Next is the Chaman. It is a coordinated program in horticulture assessment and management using geoinformatics, wherein the different types of soil, these layers, that is land use, land cover, water depth, soil productivity, all are merged together to find out the type of this crop suitability in a particular area. In this case, it is the horticultural crops. Mango was done in Iluru districts of Andhra Pradesh, and the map was generated using the different layer created using the satellite as well as the ground observations. Now, agriculture water, as we know, the pressure in the water in the realm of the climate change, it will be very high. So the command area development or the irrigation infrastructure assessment, the space technology is used. In case of the irrigation potential benefit estimations, the area which is in the command area, the how much area is potential for the irrigation or designed rate has been generated, and then what is the difference between the actually utilized, that can be determined by such type of picture where we can see the gap in the canal constructions. So this area will not be irrigated. So other area will be irrigated. So potential area is the total area, but the actual utilized area is much less than the potential area. Then improving the water use efficiency in the dryland agriculture. As we know, different types of structures are built, check dam, percolation tanks, nala band, for these watersheds to conserve the soil and water. And also the reservoir capacity. Reservoirs are used for the irrigation purpose, and remote sensing temporal data is used to map the sedimentations of the reservoirs, where the area capacity curves is generated, the reservoir level and the capacity of the reservoir, and use the satellite data to map the water spread area, and between the two water spread area, it is using the mathematical formula, it is estimated the how much reservoir, the silt has been deposited in the reservoir. Watershed development is the another aspects, and here also the different layers are integrated together to generate the watershed development plan and prioritize the watershed based on the information. The land development activities in integrated watershed management plan, we can see clearly how the difference between the implementations of the development plan and the water which has been accumulated, has been harvested, and this is the tank. Earlier it was dried, and afterwards it is filled, and using this remote sensing data, it can be done easily. What happened? Anything, any problem in this? Okay. Oh, okay. Now, the another part is bringing green revolutions in the in eastern India, wherein using the satellite data, it has been identified after the rice crop is harvested that residual moisture in the field has given lot of scopes for the growing the pulses in these areas. Around 9 million hectare has been identified for growing of such short duration crops in the eastern India. So Odisha, Chhattisgarh, Jharkhand, Bihar, Bengal, Assam, these are the eastern states where this type of technology is used to identify this area, and it add to the fruit production with the amount of soil moisture left into the field, and those crops uses very less soil moisture. So this is the one of the important applications of this technology. Another part is using the hyperspectral data. What is hyperspectral and multispectral? There is little difference between that, because multispectral uses the band which has the little more ranges, like 0.4 micrometer to 0.7 micrometer, or 0.4 to 5, 5 to 6, like that. But hyperspectral uses in a nanometer. That is, the difference between the bands is 5 nanometer. So using the high spectral resolution bands, it is identified the different types of disease plants using this hyperspectral data. However, it is being in the research domain and still not operational, but using this field spectroradiometer, researchers are doing the different types of experiment for identifying disease and the normal crops. Another area is flood hazard zonation. In the Bihar, around more than 20-year data is used to generate the flood hazard maps from very low to very high flood hazards. And this around more than 20 years data is used for such type of studies. So as the time is less, then the applications of drought, and this is the new drought index has been created using the satellite data or using the shortwave infrared and the visible band. Another desertifications is the major problem in India, and under the UNCCD program, the desertification map and land degradation map has been prepared to take the intervention to by ministry sponsored by the Ministry of Environment and Forest to take the ameliorative measures in those areas. And the wasteland maps are also being prepared around 46.73 in 2009 million hectares, and that is around 15% of area of the wasteland, and different types of interventions measures are taken to bring these culturable wastelands into practices. And also the cold wave, heat wave also can be determined using this type of technology. And renewable energy potential, our center, Space Application Center, has created the calculator for solar energy harvesting potential estimation. So thank you very much for giving me this opportunity.
Thank you so much, sir. I think this was a wealth of information, and the time is short, and sorry for this wrapping up, but thank you so much. So just to break a bit of monotony, maybe what we can do is we can invite some of the speakers now who are connected online. So is it possible to connect our next speaker who is online, Ms. Suruchi Bhadwal? Yes, that is easy to organize. Yeah. So over to you, Ms. Bhadwal. You have around 5 minutes, Ms. Bhadwal. So I'll request each participant to please be conscious of the timeline. And also maybe after Ms. Suruchi, we will have we'll hear from Professor Floran. Over.
Can you hear us?
Yes, we can hear you loud and clear. Please go ahead.
Very good of you. Can you hear my? Hello. Yes,
No,
I can. Can you hear?
Sorry.
It's okay.
Ma'am,
Yeah. Please go.
Ms. Badwal, you are
Can you hear me? Yeah. So my presentation basically focuses on adaptation technologies in the agricultural sector. And just to give it, I'm not able to move my slides. Just to give it a climate context, basically throwing some highlights from the recent IPCC-AR6 report, where it is well evident that the impacts of climate change are being observed in many ecosystems and human systems worldwide and likely to continue. And of course, we are observing more frequent and intense extreme events that has caused widespread adverse impacts and losses and damages to nature and people beyond natural climate variability. Of course, the agricultural sector is within the ambit of the natural and human systems that we're talking about, and of course, the impacts that are connected to people and communities which are dependent on the agricultural sector. There have been some development and adaptation efforts that we see worldwide that have reduced vulnerability. And across sectors and regions, basically, we have found that the most vulnerable people and systems are observed to be disproportionately affected. There has been a rise in the extreme events that we see across different parts of the world, and of course, substantial damages. And we've also observed that there's been significant effort in terms of trying to address these issues worldwide, and different countries, regions basically stand at different positions to be able to address these issues. Now, with regard to India and projections that basically we foresee in the future with regard to the climate, it's going to be a hotter and wetter climate. So there's going to be higher temperatures, both maximum and minimum, high humidity levels in certain seasons, and more rains coming. But the distribution of the rainfall and its spread is not very clear. There will be some regions with more rainfall. There will be some regions with less rainfall. There are predictions saying that possibly the dry regions would become more drier, but there would be, surprise events in the form of heavy precipitation events, even in the dry regions, leading to waterlogging and flood conditions. Impacts are widespread across all sectors, including the agricultural sector. Impacts on agriculture are direct and indirect due to changes in the climate parameters, but also because of water scarcity, extremes, and influence on pests and diseases. Overall impacts is on yields and production. We're already observing these changes. For example, with regard to agriculture, we have seen huge economic losses to horticultural crops like apples, where the quality of the crop had been affected. In India itself, a couple of years back.
I'm sorry to interrupt you. Can you please turn on the slideshow mode? Full screen. Yeah.
Sure. I wonder. Yeah. And of course, all this basically has an impact on the impact on crops, basically has an impact on food security in regions. How is it likely to affect exports and imports? And of course, create a divide between those who can procure the food because of high food prices and those who cannot, and thereby basically leading to stark differences in poverty and social inequities. It's just not about food that we grow on land that is likely to get affected. We're also observing impacts on fish catch and, of course, ocean acidification and ocean warming, basically causing an impact on marine fisheries. We do talk about climate change adaptation and its implementation. It is a necessity because the impacts are already being observed. It may basically require a sectoral, cross-sectoral focus when, while considering various measures or interventions that need to be undertaken, a mix of measures. It could be some of our existing schemes and programs and policies that the government is basically taking forward, but in certain cases where there are gaps, and clear gaps identified, I think the need of the hour would be to basically develop new measures and define them and get them implemented. Also, sectoral focus, there is a large discussion whether the nature of the intervention should be sectoral or should it be thematic based, because there's a close link that we see now between food, energy, and water. And therefore, possibly some people have been talking about to look at this whole area as a as a thematic in terms of the interventions, the nature of interventions that need to be promoted, rather than basically just say it is agricultural focused. Now, adaptation technologies in the agricultural sector, we do talk about climate smart agriculture, and there is something that we are basically promoting now, which is called as climate resilient agriculture, which is a subset of climate smart agriculture. What we assume is the climate smart agriculture, by definition, is basically much larger in focus and may include many elements to it. But when we're talking about in the context of climate, addressing climate risks and climate resilient agriculture, possibly this is going to be a subset of the large discussion on climate smart agriculture. There are overlapping objectives in terms of mainstreaming climate change adaptation, but also overlapping objectives with sustainable agricultural practices that has been talked about in terms of promotion. This is an example of a study that is being a program that is being implemented in India, which is called the Program on Climate Resilient Agriculture. It is implemented in Maharashtra in the Vidarbha and Marathwada region, which is a dry belt of Maharashtra. It's a 5-year World Bank assisted program, which had started somewhere in 2019 and is to close in 2023. And we are basically a third-party evaluator to this particular program. This is the outlay of the program where we have project intervention-based villages, regions versus controlled villages, where comparison villages where there has been no intervention introduced under the program, where the objective is to introduce certain set of technologies to make those regions climate resilient in agriculture, and then basically draw on a lot of statistics to see what difference has it made on the ground in terms of making people resilient to climate risks. So this is an example where basically saying that 97% of project villages were covered, basically grow crops in the Kharif season, 99% in the comparison villages, Rabi season, same distribution to an extent. These are the different sources of water that these are irrigated villages or regions that we're talking about, both in the comparison and the project villages. And of course, basically, they're very similar kind of crops and cropping pattern in both the project and the comparison villages that had been picked up. These are the various technologies and applications that basically we're considering under promotion of climate resilient agriculture. One at first and foremost is promoting technologies at the crop level, largely biotechnology-based applications, looking at new variants and varieties that can be produced and introduced that are heat and saline tolerant, survival under waterlogged conditions during floods for a period of few days, strengthening of food producer companies for provision of quality and certified seed quality testing facilities, skilling of these organizations and human resources. At the soil level, basically use of organic manure and promoting that, traditional means and methods that can be employed that may improve the quality of the soil, and exploring the role of new technologies, including microbial technology to enhance soil fertility, nanotechnologies for nano-fertilizer applications and nanopesticides, and promotion of biopesticides, technology-based application of inputs including manure, irrigation, large sensor-based systems being suggested, and land salinity management, use of efficient irrigation systems, which includes looking at drip and sprinkler-based systems, watershed plans that can be developed, water catchment treatments, drainage line treatments, water storage, construction of water harvesting systems, promotion of micro-irrigation and protective irrigation systems, and then protective farming through the use of shade nets, poly houses, based on the crops that are basically being grown, promoting changes in farm practices, including integrated farming practices, combining land-based farming with livestock-based sericulture, apiculture, poultry, and fishery-based farming that can be promoted. Besides also looking at opportunities for mixed farming and rotational cropping systems and promotion of agroforestry and generation of market mechanisms for carbon credits. And in the end, basically looking at opportunities for operation and maintenance on any of the above. Post-harvest management and value chain interventions that can basically be thought about. And in the end, not to leave out the fact that all these interventions that we're talking about cannot be possible if you do not have the institutional setups to take them forward. And therefore, looking at institutional setups, promotion of startups and innovation centers, strengthening of R&D in institutions at the local level, creation of platforms for sharing of these technologies and scaling up at the local level, development of custom hiring centers at the panchayat level, establishment of seed hub infrastructure, setting up of information knowledge centers, and training and capacity building all at different levels that can basically be promoted. This is basically an example of the comparison and the project villages which are in June. Yeah,
Dr.
just 2
Suruchi,
minutes.
please look at that
Just
time.
2 seconds. Yeah, I'm just wrapping up. 2 seconds. So these are technologies that have been promoted in the in the project villages and the comparison villages, and you see a far greater uptake of the technologies in villages where basically the interventions were carried out through the program, and basically concluding the point that you do need institutional support systems which can basically help you take things forward. And we may know about all these technologies, but until we work with the farmers ourselves and promote them and have certain setups basically built in a manner to help them take these forward, I think it will not basically see the light of the day. And of course, these are farmer field schools and trainings that are imparted to farmers, along with them, promotion of these technologies and a whole range of community benefits in the form of natural resources management that we see through the project being implemented. In the end, I'm closing my slide with this particular, slide, which basically says, while all the implementation may be taken forward and you may work on a bottom-up approach, you may work with the farmer field schools, a lot of training capacity building involved. I think a crucial component of every implementation project should be an impact evaluation of how the program has basically how the program has developed and how the program has delivered. This is at the start of the project only, having a strong monitoring evaluation framework at the baseline, in the midterm, and the end line of any project that is being implemented. Of course, the key points in conclusion are we require appropriation of technology and practices on the ground. We require channelizing of resources to help implement these technologies. We need the right kind of institutional setups and support systems. Of course, the infrastructure to support that, and not the least is basically strengthening capacity and training of stakeholders involved. With that, I would just conclude my presentation.
Thank you so much, Suruchi. I think this was really great to hear from the ground level information and execution, specifically of the climate resilient agriculture. So now I'd like to request participants, if they have any questions, if they have any comments, please. We can actually collect maybe 2 from here, and if there is online as well, if there are some question, maybe 1. Sure.
Thank you, ma'am, for giving me this opportunity. This is Adi Narayan from IIT Bombay. My colleague is sitting here. Just sort of more observations than questions here. You made a point on adaptation. I think, unfortunately, we do not have those smart models in this regard, barring a few rather, I know, multi-layer canopy model, which takes care of right from root to the plant level. But we need to have more models which are customized and contextualized. I think that's what you mentioned. Do you have any other models that we have which can be adopted in India and Asia particularly? That is my first question. And the other question, I think Professor Sharma talked about climate resilient precision agriculture or climate smart agriculture. For example, we have been following this precision irrigation based on water use efficiency irrigation methods. We do have that precision agriculture project, which is distributed all over India by Indian Council of Agriculture Research. But my question is, do we have any showcasing these studies on climate smart agriculture so that the farmers can adopt this? Thank you very much.
Any other question? So Professor Sharma, do you want to respond to this?
Sir, thank you very much. In fact, in India, there are n number of pilot projects. I was in Jharkhand, and one block development officer, he in his whole block, he's using modern irrigation facilities and drip irrigation, etc. He has shown to the farmers that how much, in 50% of water quantity, how they can have a better crop. So pilot projects, as far as pilot projects are concerned, there are many examples which we can give. And the only thing is that how, upscale this. This is the issue. And not only in Jharkhand, for example, Sikkim. It's a very good example for organic farming. The whole state is organic. But how to take it, to other states, I think. And in a systematic way, not like Sri Lanka. It should be very systematic. In Nagaland, they are doing it, now. There are other example of Sikkim. For example, we have revived 4,000 springs, which were dried completely. And there were about 169 villages where there was no water, actually. So, community, forest department, our, government, non-government, community, we work together, and you come to Sikkim and you will see that 4,000 springs are revived. So, there are many, many stories, which we have. But these are the short stories. It's a big country. And now the issue is that how you can upscale this. Thank you, sir.
Thank you so much, Professor Sharma. And about your, the same thing, in fact, applies for models if we talk about Asia and all. What we really read is more from the similar kind of pilots or micro pilots, I would say, rather, than really big pilots. So from Bangladesh or Indonesia. So there are some things which are documented, but I also see, my question which was basically that do we really have enough kind of information and tools which in fact also can replicate these kinds of the small pilots or success stories. So in fact, one important thing in my opinion is like when we are really investing in implementing some pilot, can this itself in the design phase have some aspect of scalability, how that pilot can really be scaled up? So in case if certain things are happening, how it will be really made sustainable in the form of also economy, like how finances will really work. When it goes to the economy of scale, will the cost come down? And those kinds of studies and all, at least for some of these funding which comes from outside, maybe the World Bank funded projects or maybe the projects which are really of very important, which are very important from the national or international perspective to bring the change. So it's very important to have this documentation of success stories and the potential to scale up, that angle added to this. But then, yeah, I think that's a kind of right point that there is a dearth of that information for sure.
Can I come in a bit, ma'am?
Yeah, ma'am. I saw Ms. Suruchi needs to put a question. So, ma'am, please.
Not a question in response, actually. So because he mentioned it's with regard to adaptation, and when we look at these technologies, business as usual technologies in agriculture that is being implemented, including precision farming, need to be evaluated in terms of their contribution with regard to the climate risks that are basically likely to happen. So we need to understand, and that has not happened. So there are technologies that we have which work well and are delivering on the ground. And all of these technologies need to be evaluated with regard to climate risks and how do they perform under the changing climatic pattern. And if they perform well, then possibly they have the potential to contribute to adaptation. They are not adaptation technologies per se. And so we cannot just pick up the technology and say they are adaptation technologies. We need to first evaluate them. And once they are evaluated and we are confirmed that they are performing under enhanced climatic condition and change pattern, then possibly we talk about the issue of scaling up of those technologies. So these kind of studies are very limited. There's hardly anybody who's done evaluation of technologies per se to be able to qualify them as being efficient enough to address climate risks and our climate resilient technologies and our supporting adaptation. So I think there's a big gap there in terms of our understanding of how these technologies would perform under an enhanced climatic condition.
Absolutely. Thank you so much, Suruchi, for that intervention. And the second issue, which is also of the localization. I mean, when we are talking about actually scale up, the other thing which actually has to be taken into consideration, and the point which Dr. Chinnaswamy, you brought in about bottom-up approach and localization, how that actually can also be incorporated. So yeah, quite a lot really needs to be done for sure. Any other question from the audience here or online?
And those who have even joined virtually, I would request they can keep putting their questions and we can address it later on.
Sure, perfect. So request all people who have joined online to type in their questions. So then we move to our next speaker, who is again connected online, and I mean that probably partially will also address some questions about examples from the region. So this is I request Professor Florin to please come in and share her story of success and experience. So we are eager to really listen to you, Professor Florano.
Thank you very much, Madam Chair. Am I loud and clear?
Yes, you are.
Okay, so this is a systems analysis on the environmental risk to food security in the Philippines. This is a post-pandemic food security research. So I'll just be mentioning the food insecurity in the Philippines, and then the concept of food security and framework of analysis, and then the environmental risk to food security in the Philippines, including COVID-19. And the general policy recommendations. And then from the research, I found out that there is a need for a food bubble, which is related to territorialized food system. So food security in the Philippines, we are very much insecure. As you can see from the Global Food Security Index score, from 2015 to 2020, we have moderate performance. Okay, so our ranks and scores are very much irregular, but still, again, we are in moderate performance. Because we have problem with regard to our protection of natural resources and resilience, for example, protection of land, water, ocean, and also our political commitment is low, and also there are demographic stresses. So the question that this paper would like to address is, what are these environmental food risks? How do they affect food security and the policy measures needed? Okay, and then I'm taking off from the concept of food security from the Food and Food Agriculture Organization, and I'm focusing on access and sufficiency. Now, my framework is derived from the driver pressure state impact response created in the 1990s by the OECD. And then I got some of the factors for the DPSIR from the high-level panel of experts framework, which was developed in 2020. And these are the ones I got the drivers of environmental change, pressure, environmental change, also impact, and then the response. And in this case, the policies that are needed. And then I line them up so that I can draw them up. Show the cause and effect relationship, like food availability and agricultural productivity as impact, and the drivers of change are the economic and environmental policies, demography, economy, stresses, etc. And then the pressures are climate change, conflicts, disasters, including pandemics and epidemics, and then environmental change. And the response, the policy response will be on the drivers, the demography, economy, politics, economic, environmental policies, and agricultural practices. So what are the food security risks? Well, we just identified the major food security risks. And these are the what I found out from existing indices, which I researched on. Our food availability has medium rating. agricultural productivity, low, medium productivity. Our environment is degraded. We have medium to high risk conflicts. We are medium risk when it comes to the pandemic, high risk in climate change, disasters, high risk, business as usual in terms of the drivers, and we have pollution causing agricultural practices. And then I drew them up using a causal looping, which is a systems analysis using the BENSIM program. It shows us in qualitative terms the cause and effect relationship of these variables. Okay, so it's difficult to see them. I drew them using the causal tree diagram. So you can see here the primary factors. The primary, the impact, and then the primary factors and the secondary factors. Each of them are actually the cause and effects. In the succeeding slides, I will just be telling you that climate change has been identified as really problematic. Even 1% change in climate change affects our agriculture. Typhoon is one of the most disastrous disasters in the Philippines affecting food chains. We have agricultural and farming practices which pollute the environment, which in turn reduces our it threatens our food security. We have been causing so much damage to our forests. Denudation of forests, which leads to habitat alteration, loss of genetic biodiversity, soil erosion, etc. And then conflicts, domestic conflicts could lead to food shortage and hunger. Food shortage and hunger could start or amplify conflicts. So in the pandemic, we noticed that during the first 2 months, we had problems with production because the workers were not allowed to go to work and the business establishments did not operate. And there were also problems with regard to distribution because the government implemented community lockdown or community quarantine. So there was a problem of food distribution which affected food security in major urban areas in the Philippines. So what are my general policy recommendations using the cause and effect diagram? This is to make a sustainable and sufficient food production by promoting eco-friendly agricultural practices, increasing sustainable agricultural productivity, resolving domestic conflicts, inculcate high eco-awareness in the society, enact, amend, or strictly implement policies related to environmental protection and sustainable development, and prevent or curb pandemic, epidemic outbreaks to avert food shortage and price manipulations during pandemic, epidemic outbreaks. And these are the same variables that are the means and ends of this diagram. So general recommendation is to promote food sufficiency anchored on sustainability and resilience, make food security as part of national security policy and national security strategy, conduct annual food security summit meetings, hold meetings of the National Council on Food Security at the local government, and review existing policies relevant to in the light of the post-pandemic lifestyle changes and their implications to food security. One of the things that I was able to find out that during the pandemic, there was this, even though there was a community quarantine or lockdown, food supplies were still able to delivered in certain areas in the Philippines. Like here, you can see Basilan. They were able to get their food supplies from, like the essentials like rice, chicken, eggs from the nearby areas. Okay, so I think this is a good system that can be developed, and I would say this is related to territorialized food system. A territorialized food system includes production, processing, distribution, consumption, and waste management organizations, as well as their interrelations in a specific territory. They are based on the partnership between multitude of territorial actors, private, public, and civil society members. Okay, so this is a concept that I developed, the concept of food bubble during pandemic crisis lockdowns. A food bubble is a grouping of contiguous local government or areas that produce, supply, and distribute essential foods, goods, and agricultural implements to each other during prolonged public health crisis situations that call for lockdowns. The network in the bubbles should be big enough to sufficiently supply each local government unit with essential foods, but small enough to prevent or manage widespread infections, chaos, disruptions. Okay, so last slide. The way we can institutionalize the food bubble system, as I see it, is the adoption of a policy about it, identification of contiguous local governments, agreements among local governments about the appropriate agricultural produce suitable to the climate and terrains of the areas and the dietary needs of the targeted local consumers, adoption of sustainable and resilient food production system and smart farming system, identification and or construction of the fastest land or sea-based transportation infrastructure to connect the local governments, creation of food distribution system in each of the local governments, and ensure peace and order within the food bubble areas. In a way, this is a small scale way of managing the environmental risk to food security in the Philippines. Thank you very much.
Thank you so much, Professor Florano. I think this was a very interesting and different kind of experience, specifically looking at the COVID perspective and also, an interesting study about the supply chain and then the concept of bubble food system. So thank you for sharing that.
Thank you very much, Madam Speaker.
May I now please ask Dr. Chandrasekhar Bahinipati to make his presentation. Thank you.
Oh, I can use this for next. Yes. So.
Yeah, good morning to everyone. Thanks to the both TIFAC and IIASA for giving me this opportunity. So already the previous speakers, including the Professor Sharma, has already set the table for me. So all of them basically talking about the different varieties of climate smart adaptation practices, and someone also talking about the main issue, the dissemination. Okay, we have different pilot projects regarding the climate smart agriculture. So either it's a technology or the space intervention. So now the main question that, okay, how it can be disseminated to the farmers. Okay, when it comes to the dissemination, we have three institutions to play the role. One is the institution, both formal as well as the informal institutions. We have incentivized those mechanisms or technologies so that more adoption can happen. Then we have information. So we provide the information. So my question is that, okay, how these three things, okay, the institution and information and incentive actually helps or accelerates farmers to adopt different kinds of technologies. Okay, so I'd like to thank the Indian Council of Social Science Research giving me the funding to carry out this study. So I'll not spend much time on this because most of them already spoken about it. So as you know that we know that the farmers are adapting because there are some evidences, some studies have already taken that, okay, there's a pilot project, the farmers are undertaking different varieties of adaptation measures. Okay, someone has mentioned that, Dr. Bardwal is mentioning about that, okay, the impact evaluation of those adaptation measures. Okay, whether those adaptation measures are actually effective or economically viable farmers. Maybe someone is effective in Manipur or Sikkim, may not be effective in Gujarat or the Tamil Nadu. So it's very difficult to scale up. So when the basically doing the HIMAP project or the Himalayan region of northeastern part of India. So I basically verified the Himalayan, basically that after I've seen that there is very less literature in the northeastern part of India that basically talks about what are the things that basically farmers are adopting. Still, we have less literature in the scientific knowledge that, okay, what are the adaptation measures are there from different parts of the country and which are the effective adaptation measures. So in that, because I already told you that I'm interested on the look at the institutions, incentive and information, how these three things basically influence farmer to adopt, because these are the three mechanisms which are important to basically disseminate all the supply side technologies to the farmers. So I did a systematic review. So basically I was looking at all studies available in India from the 2006 to 2019. Okay, so what are the studies basically focusing on different varieties of adaptation measures in India with respect to agriculture? We have basically the farm level, farm management and technology. I've divided all the adaptation measures in five categories. One is the farm management and technology, diversification on and beyond the farm financial management, government supported generic and disaster risk reduction measures, and knowledge management, network and civil society. So I find that most of the studies are focusing on farm management technologies, but there is less studies which basically talks about it in the climate change literature on the diversification. There are around 50% studies talk about the diversification, 43% studies talk about the farm financial management, and also less literature on the government supported mechanisms as knowledge management network. So when looking at within each measures, okay, what are the things basically looked at, you'll see that there are most literature talking on the farm diversification, basically about the crop diversification, adoption of agriculture technologies, or altering crop calendar and or land holiday, basically keeping the land as fallow, or crop choice and water management. So water management was mostly studied, because maybe the region that, okay, there's a water scarcity across the India, most of the parts of India, that's the water management technology is mostly studied. And other things like, okay, crop insurance, borrowing from formal and informal sources, or the migration was basically less studied in India. Okay, so since it is already talked that, okay, we have National Mission for Sustainable Agriculture or different flagship programs which basically trying to promote the different varieties of adaptation measures. So basically what I've done, I basically surveyed around 1,274 farm households in 4 southern states, Andhra Pradesh, Tamil Nadu, Kerala, and as well the Maharashtra. So what I've done here, there's another paper, basically I was looking at the causal relationship between the variables. So I found that looking at this is basically published in 2022. You can also even download this book. Entire book is open access, published by the Sandy as well as the ICIMOD. So basically we're looking at, okay, when people look at the causal relationship between the adaptation measures and the variables which basically influence, I found that there's very less studies with respect to institutions and information incentives. So basically they took household demographic characteristics and soil characteristics. And basically they are not considering the risk attitude, behavior, or other development policy or the information. These variables are basically less studied, we found that. Hopefully it works. Can someone help me? Okay, so these are the district-wise vulnerability index we have developed for all 4 states. Based on that, we basically select the study districts. So these are the study districts we have selected from the 4 states. From the Andhra, we have taken the 3 districts, and from Tamil Nadu, we have taken the 3 districts, and Kerala, we have taken 3, and Maharashtra, we have taken the 2 districts, basically considering all kinds of disasters, cyclonic storms, and floods as well as the drought, so that we can get a diversity of the farmers, so that we can address the issue. So these are theoretical framework. I just ignore it, skip it, because so these are we're looking at okay, what is the percentage of farmers undertake the adaptation options. I found around 91% farmers are undertake the adaptation measures. And what are the different varieties of, basically I've taken around 7 varieties of farm climate smart agricultural practices like crop diversification, changing of crops, disaster resilient crops, soil management, altering crop calendar, short duration crops, and water management. So you'll see that around soil management, 68% of farmers are taking the soil management, and 70% farmers are taking the water management, and other varieties also. I have mentioned that, okay, around 39 to 59% of farmers are undertaking the adaptation measures. So I'm just skipping because of the time. So yes, I come to here looking at the, okay, I've just taken the household characteristics or the other studies are taking to control. So I basically am interested on the farm and soil interventions. So look at this, we will see that basically when taking the irrigation, which has some positive relationship with the altering crop calendar and the short duration crops, and having the negative relationship with the soil management. But soil health card is almost significant as the positive relationship with all the adaptation measures, because as you know that after our Honorable Prime Minister Modi, when it comes to power in 2014 to 2015, they basically centralized the soil health card scheme. So it's basically we find that, okay, those farmers are access to soil health card, they're basically able to undertake more adaptation measures. So when it comes to the institutions and incentives, you'll see that insurance is not mostly not significant, although significant in some cases, but having some negative relationship. Okay, those guys are having insurance, but not having the information. Similarly, access to primary agriculture credit societies having some negative relationship with some variables and only positive relation with the soil management. Similarly, subsidy in agriculture instrument is not at all significant. And similarly, minimum support price or access to that MNRGA, and also access to self-help groups, which are basically significant in some of the cases, not in all the cases. Similarly, when coming to a diffusion of information, we have taken the training program, whether we attended a training program or Kisan Call Center or access to farmer producer organization. Or similarly, so only one variable, that's access to agrometeorological advisory services, has some positive significant relationship with all the variables. Apart from that, all the remaining basically information through the institutions we have, so that we can diffuse the information. Okay, it's not having any significant relationship. So we need to rethink of it. Although we have supply side think that, okay, we have different technologies, okay, in place, but only problem is that we have to restructure those institutions and information mechanism, incentive mechanism, so that it can be disseminated with the farm to the farmers. I'll just keep it. This is basically talking about complementary substitute relationship. So with the lack of time, I just want to summarize it that, okay, we need to now to rethink of basically revise these institutions and information incentive mechanisms so that it can be disseminated to the farmers. So thank you.
Excellent presentation. Thank you so much. And I do understand the time constraint, but really we would have liked to learn more from this kind of study, which is pretty useful in guiding some of the policy decisions that we are talking about, which measures are more effective as compared to others and all. So thank you so much for sharing that study, and we'll look forward to maybe learning from you more in some other occasions. Now let me invite the next speaker, and I think we are already out of time. The next session starts at 11:30, but so of course, last but not the least, Dr. K.V. Ramesh, over to you, and thanks for your patience for being the last speaker and hearing everyone, but over to you, and we really look forward to hearing from you.
Can you see the slides? Can you hear me?
Yes, sir.
Yeah.
See your slide?
Yeah. I will put.
Can you make it slideshow so that?
Yes.
Yeah.
Is it clear?
Yes.
Yeah.
No.
So as I gone through the whole session, because it was from the localized solution to the upscaling trend. The main problem now is the weather and climate informatics, because most of the application we use for localized systems. So I will be presenting a system integrated approach. So for increasing sustainable quality protection for enhanced livelihood as well as food security. So a crop system, when you take a field or something, it is a system of interconnected subcomponents of so many components of the natural ecosystem. So we cannot address only one crop field as it is. So the crop, when you go, it has a type, which are the crop, variety, phenological stages, and soil, water, and the climate, of course. The changing climate will put more pressure on the what type of information we can share to the farmer. Then if you take management part of thing, land, crop choices, because is it market driven, market demand, profitability, because we can see most of the time tomato prices goes up to 100 and sometimes the farmer throws on the road. So then crop residue management, that is another thing, it is there. So what are the things to decide usable information? So we have remote sensing based solutions, data, station-based observation. Even now, due to the IoT, we get the microclimate and the dynamic.
So sorry to interrupt. Can you be a bit louder?
Yeah. Can you hear me now?
Yes. Now
is it okay?
You're loud and clear. Yeah.
Yeah. So remote sensing and the station observations. Then we have the modeling systems, say crop system models and AI, deep learning based and traditional knowledge. Yes. So what are the things, actionable input, when, where, and how much? What farmer wants, but out of all the things, what we can throw a lot of information on the farmer. Finally, end of the day, what farmer wants, we have to find it through surveys, and then they need, we have to give. To give an overview of this thing, the agriculture feed is not a small system as to it is when we see a modeling perspective, it has so many complexity. Due to late time, I will just skip through. So I will go through these things to see remote sensing, soil and climate scenarios. So what we can do, climate system, crop system models, and deep learning and AI-based models now come handy to unravel the complex relationships, multivariate models. What are the limitations and opportunities for our context? So India, because we cannot ready-madely adopt from the Western agriculture practices, because we can see 67% of our land holding is marginal. So we cannot directly adopt those models and put it here. So we should be very localized. Solutions are very critical for our thing. So where are we stand in the yield perspective? I have put only two things in the global, because if our data sets yield, I have taken paddy, we can still go lot of way to achieve, because we can still achieve a lot in the yield. So productivity, even banana, we have one of the best, but still there is a scope available there. So the field data and imaging, when you come, because instrument-based measurements are very critical, because satellite, UAV-based, drone-based observations are now coming, IoT, and field validating these products, especially the remote sensing based, NDVI, chlorophyll, leaf properties, then imaging and all those things. Finally, the pool of the data we can put, what are the approaches, can be regression based or dynamic based or AI plus deep learning or image analytics. For example, if you want to predict a disease, crop disease, when and where, and giving advanced information along with the weather and climate, that is very critical for farmer to act. Because one of the critical problem for our, we are two monsoon seasons we get, northwest and southwest and northeast monsoons. So you can see the remote sensing, the satellite images from Sentinel for 2017 over the Indian region, we get very less, very cloud-free images. So we cannot purely depend on the satellite-based images. So what we have proposed, we have developed a methodology, part of the NMHS program. So you can take the coarse resolution satellite images plus MODIS. Then you have best resolution Landsat and Sentinel plus UAV-based multispectral 10 centimeter thing. So you make a reconstructed spatio-temporal database so that it enables for predictive analytics. So this is the development of climate and weather informatics. Then we will go through, because this is everybody. So we have done for high resolution the forecast for the Karnataka state, and we have validated, because this is the WRF setup. Don't go into the detail. So for irrigation scheduling and pesticide applications, if we apply how far we can reliable on the forecast, so it can be reasonably good if we can validate and give the inputs. Then we can give, the irrigation scheduling can be profitable. Whatever these studies show that it is almost like for 4 acres, it can give a 2,600 rupees profit if we can science-based thing. So we have proposed recently for the smart agriculture for informatics, how we can give is a combination of setup. You have all the things, you take the crop phenology and crop type based solution for at a field. So I will be explaining briefly about the SDM. Typically, we have used this for Almora district. Recently, we have implemented. So what we have done is we have included the major component of the agro ecosystem, the crop system. And with weather and climate by WRF, then crop system we have used APSIM and DSAT, then hydrological SWAT and CUM, then satellite-based the crop phenology estimation, then participatory rural appraisal, we get to know that what farmer need. Then we take a system dynamical approach to develop what they want to give. So I will quickly finish it. So what we need is development of crop specific, region specific, sustainable, climate smart approaches are the need of the. Thank you.
Thank you so much, Mr. Ramesh. I think this was very succinct and very powerful presentation. Thank you so much for sharing it. If there are questions from audience.
There's a question in the chat box from Girija Shankar. How can we improve individual psychosocial resilience by having digitalization in climate issue? If anybody, like even in the virtual platform, if anybody would like to just answer it.
So any of the panelists?
The question, how can we improve individual psychosocial resilience by having digitalization in climate issue?
The psychosocial resilience.
Resilience, yes, sir.
Using
digitalization in climate issues.
So I don't think we have really discussed quite a bit on this, but if anyone on online, the experts, Suruchi, Mr. Ramesh, do you want to answer this question?
No, I will make a small point. You see what the resilience of socio-economic system. So first of all, we should look at the household.
You will have to be a bit louder, Mr. Ramesh.
Yeah, can you hear me now?
Yes, you're loud and clear, sir.
See, because a lot of socio-economic models for the resilience part, it is available. What is the problem for our system is our socio-economics in the rural area is it's not well documented. So we have to make a survey and we have to identify the root cause of the problems. Then we can identify the problem. We can find solutions.
Yeah, just actually one thing is that I reflected something on behavior change because adapting to climate change from the perspective of the practices and behaviors, both are important and they are something where at this point in time, I think there is quite a lot of coordination and what I would say is like the impact of climate change on health is being discussed, and quite a bit of that actually goes on the psychosocial well-being of a person, and there probably it becomes much more feasible and important to look at those aspects as well. And specifically when given the experience of dealing with COVID-19, everybody has realized the need for looking at the psychosocial and psychosomatic disorders and all. And so with the changing climate, we see that all these things are really converging at some point in time. And so important to really respond, but that is something probably which will be another domain of discussion rather than this particular one. So any other questions, or I think, we have taken quite a bit of time, but just to say a heartfelt thank for the organizers for bringing out this particular issue to the forefront. And esteemed panelists, I really want to thank for very insightful and detailed, as well as still, very pertinent, raising pertinent points and giving a lot of information. So I would like to really thank all the panelists, Dr. Chinnaswamy, then Dr. Bandyopadhyay, Dr. Atri couldn't be here, but Dr. Bahinapati, and then Dr. Suruchi Bhadwal, Professor Florano, and KV Ramesh. I think, there is no kind of two ways, or it's a kind of unequivocal demand, and which is highlighted by all the panelists, that there is a need for further work on climate smart agriculture, which is need of the hour. So I'd like to close it and thank the audience for great participation and listening. Thank you so much, everyone.
Thank you, ma'am.
Now, as we have reached the end of this session, I would once again like to thank each one of you for gracing us with your presence. But before we part ways, on behalf of TIFAC and IASA, we would like to felicitate you for being our honorable speakers for the day. And for speakers joined virtually, Ms. Suruchi Badwal and Professor Ebenezer, who I think is not virtually present at this moment, and Dr. K.V. Ramesh. Thank you so much. It was a pleasure to have you with us. Now, to present our little token of appreciation, I would like to invite Dr. Pradnya Petnekar to please hand over the token of appreciation to the rest of the speakers. I would invite Professor Pennan Chinnaswamy. Thank you, sir. I would invite S. Bandyopadhyay to please receive the token of appreciation. I would invite Dr. Chandrasekhar Bainapati to please receive the token of appreciation. Now I request Ms. Sangeeta Bakshi to please hand over the token of appreciation to the keynote speaker, Dr. Pradnya Petnekar. Thank you, ma'am. It was a pleasure to have you with us. Now, I extend my sincere gratitude to each one of you. Thank you for joining us. We'll have a short 50 minutes of tea break.
Yeah, actually, we are already late for our next session, so I don't want to delay our other speakers for the next session. So we'll just go quickly for the tea and come back. Yeah.
Good morning, everyone. I would request everybody to be seated so that we can just start the session. Welcome back to our third day of the International Conference on System Analysis for Enabling Integrated Policy Making. I'm Harsha Mohan, and I feel privileged to extend my warm welcome on behalf of Technology, Information, Forecasting and Assessment Council, TIFAC-IIASA, International Institute of Applied System Analysis, who have clubbed all of us for a system analysis approach. I extend my deepest gratitude to all dignitaries, honorable speakers, and guests for your esteemed presence at the assemblage. Just to begin with, the topic for this session is agrometeorology, from scientific analysis to the operational application. Now, it's time for me to invite our keynote speaker who will formally start the conference and advance the session, Dr. Pramod Agarwal. Dr. Pramod Agarwal currently leads the Asia Regional Program for the CGIAR Research Program on Climate Change, Agriculture and Food Security. Dr. Agarwal is a fellow of the National Academy of Sciences and the National Academy of Agriculture Science India. He has won many awards, and some of them include Ernesto Eli Tresti Science Prize with the Academy of Sciences for the Developing World and Young Scientist Medal by the Indian National Science Academy. Sir, I welcome you. Thank you, sir. Now, I would request Dr. Pramod Agarwal to just advance the sessions and kindly call the respective speakers.
Thank you very much.
Thank you.
At the outset, let me thank the organizers for giving us this opportunity. I presume we have 7 speakers and I see more than 7 people here. So I think all the speakers are here, presumably. Unfortunately, we don't have any live audience. I'm sure there will be some online to listen to you, but at least we 7 can listen to each other for sure. So thank you all the speakers, panelists, and other guests here for joining this session. The session, as was just mentioned, is about agrometeorology, from scientific analysis to operational applications. Now, this is a topic on which there has been tremendous progress in last 10 years in particular. In terms of data, as we all know, there is a lot of progress in terms of granularity, in terms of confidence, in terms of availability and accessibility as well. We have lots of data from satellites, and I'm sure several speakers following me will be talking about that. We have grid data, we have satellite-based weather data available till yesterday. And I think all of this is making life easier for lots of applications, and they're more or less ready to take off. Same time, we have seen a lot of progress in agromet-based models, especially crop models. There has been good number of progress. In last 10 to 12 years, let's say rather 10 to 20 years, we have seen considerable progress in use of models, the whole systems analysis approach, largely spurred by 2 major reasons. One is the importance of climate change and climatic variability, a demand for knowledge around that, and also because of availability of granular data. I think both of these have spurred the demand in crop modeling in particular. In fact, so much so, if you ask for a crop modeler and if you want to recruit a crop modeler, it's very difficult to find one because they're all overemployed. I see if you look at international vacancies, every day there is at least 1 vacancy for a modeler these days. That's really good news for many of us who practice systems analysis. But at the same time, I think we really need to fill this gap quickly. Lots of applications are being made in terms of understanding climate impacts, climate change impacts, adaptation strategies, mitigation strategies, designing improved agronomy and varieties, and so on and so forth. Considerable progress has also been made in terms of assimilating remote sensing. So you see different facets of systems analysis remote sensing is also being used. I was here in the last session and I saw lots of people talking about how do we use remote sensing in crop models. In fact, I just heard our colleague Dr. K.K. Singh also mentioning that they are thinking of, or they have already started using remote sensing for advising farmers. And we really look forward to hearing more details. And finally, those of you who are familiar, there's been considerable progress in integrated assessment models as well, because lots of time when we talk about biophysical, that's not complete. So these integrated assessment models, and they're not too many globally, they have also made a lot of progress where we are able to link the socioeconomics with the biophysical. And I think there's been progress in that in terms of designing improved land use and so on and so forth, the whole food security modeling around that. There are few groups around the world who do this type of research as well. Now, all of this progress in systems analysis, modeling, data is seeing several applications in terms of operations, and I think operationals are becoming better, more precise, more granular, and are increasingly being used. And we'll see several examples from our panelists today in terms of how exactly they're using. So I will not take much time beyond this. I see we have about how many speakers? 7 speakers, I suppose. Let me just quickly see Dr. K.K. Singh. Can I invite you to the stage, please, to share the dais here? Dr. K.K. Singh is Scientist G, India Meteorology Department. Dr. Bhan is DGM, New Delhi. Please, if you could also join Dr. Bhan. And we have Dr. Chaudhary, VM Chaudhary. Is he?
VM Chaudhary is not attending the session.
He's not attending?
No, he's not attending.
He's not attending. Okay.
We have Ms. Shweta Sen joining virtually.
Dr. Shweta Sen is joining virtually.
Yes.
Mr. Ronit Jaiswal.
Joining virtually as well.
Ronit Jaiswal also virtual. That's it.
And Dr. Upasana Sharma, she's present here, so she can join us.
I'm sorry, there's another sheet. Dr. Upasana Sharma, please. And Dr. Amit Kumar.
He's joining virtually as well.
Okay,
yeah.
So we have about 6 speakers and we have about 50 minutes left. So can I request each speaker to take about 5 to 6 minutes to make presentation and leave maybe 2-3 minutes for discussion? If there's a question, immediate question, we'll try to address it. Otherwise, we'll leave about 10 minutes for questions later on. With this, may I request Dr. K.K. Singh to make his presentation first? Dr. K.K. Singh, please.
Thank you, sir. And at the outset, I go there.
So it's up to you. You can also, the slides, they will handle it. So you can speak from here as well. Yeah.
The outset, let me thank the organizer to invite us and give us the opportunity to present before the audience what we are doing in collaboration with the many organizations at national level, state level, and also not only government, but private and NGO also. I'd like to start.
If you want.
This is, in fact, related to agro-meteorological advisory services with stakeholders engagement. So I'd like to go to the first slide. I mean, second, next one.
Is there a... So,
yeah, this is managing climate risk at farm level. In fact, under changing climate becomes more challenging and to cope up with the risk and find out solution. And that for us, because we are providing the weather-based services to farmer. So at farm level, at planning level, maybe easy to use the climate information. When I say climate information, includes climatology, what based on the 30 years or more than 30 years average information plus variability also, plus forecast also, forecast with different lead time, including whole season, whole crop season. So managing, but at farm level, if we go, this becomes more challenging using the forecast with the higher lead time. Managing climate risk at farm level using agromet information. So these are data climate risk, weather forecast of different temporal scale, translating these weather forecast into actionable advisory by farmers, which is done by the genuine group of the agricultural experts working at district level or agriculture university level. And then customization, because being the central organization, we can definitely work up to providing the information related to the crop. But further customization, which farmers could find specific to his plot, his farm, and suiting his own requirement. So definitely that is the another area where we have to work with the different organizations to meet out the farmers' specific requirement, and then of course dissemination. Finally, it should reach in time. There are a lot of information. Dr. Agrawal was saying, Chairman was saying that there is the model, data, all those things, but how to reach with the suitable information up to the farmers so that they can consider while taking the decision. Next one, please. Sorry. Panel weather forecast is being weather forecast is being prepared. Centrally, global model is run. So once forecast is generated by the model, then our Met Center forecaster at provincial level, they undertake the value addition, means they add the value to these forecasts, and then finally at district level and block level, and it goes to different agromet units established in the at district level in the country. All the districts are not covered so far. Half of the districts are covered, around 330, and their job is, because agricultural experts are there, those agromet units are with Krishi Vigyan Kendra in the country, or the agriculture university, or their research station. So pool of agricultural experts are there, and they are senior also. They are from different subject. And also IMD is helping by especially recruiting 2 manpower, one in the scientist grade, and dedicated for this purpose, for preparation of the agro advisory, considering forecast and other crop information in and around the districts. And then once advisory is prepared under the guidance of senior agriculture scientists, then those advisories are disseminated to the farmers using different communication means. And then of course, feedback mechanism becomes part of that, which is happening, and also economic impact of the service is also calculated. And in this case, economic impact assessment is possible. And we know with the all programs, all the programs, means central sector scheme funded by government, that is necessary. Economic impact assessment, if not possible, social impact of what the program leaves on. This is about the network in the phase manner, how we have reached to, and next 4 years we will be covering 430. And every station we are also providing the automatic weather station, which has in addition to normal weather parameters, soil moisture sensor as well as soil temperature sensor up to 1 meter. So this we all know, weather-based farm management advisory, what are the important aspects, agronomic operations for which advisory is required. This is the source of observation. One is the observatory, then state observatory network. Other than IMD network, there are few state governments have put their observatory under their other schemes, and that is our. We are integrated. We are trying to integrate, and some of the states we are integrated with our system so that all those data goes to the model, and also that is used for the verification of the forecast. Then soil moisture observation, crop and pest and disease observation. These are the forecast spectrum which are being utilized in agriculture. Nowcast for 3 hours, accuracy is very high, medium range up to 10 days. Then extended range for 4 weeks, extended range, long range for the season. These are the probabilistic in nature. And it is, it is also advisable to use the probabilistic information in these time scales, extended range and long range. And early warning system also on extreme events, cyclone, hailstorm, thunderstorm, cold, heat wave, drought, is of importance to agriculture. This is about the medium range. In medium range also we are providing the probabilistic, means what is the probability of the rainfall on a given day. This is the process, like what are the components: past weather, present weather, forecast, sensitivity of crop to weather, means different thresholds like soil moisture stress or other kind of stress which are operating on the crop. That information should be available. And in this case, we are working with the state government. In fact, at the district level, expert panel, district agriculture officer is the part of that. And there are a lot of information which is required through the state government channel to be available every week with the agromet units established at KVK or State Agriculture University. So this is from the district level advisory, state level composite is prepared, then national level composite is prepared. National level composite is shared with the Crop Weather Watch group at national level, Krishi Mantralaya, and the state level also shared with the state government planners. So this is all the information at forecast generation, forecast sharing with the meteorological center at provincial level, then sharing with the agromet unit at district level, then further advisory preparation and uploading, and then further dissemination. So this all through happening through the decision support system, which has been developed in collaboration with the RIMES, International Organization Consortium, RIMES, which is located in Bangkok, and then further. Just excuse me, sir. Can I leave? हाँ अभी वहीं आऊं?
I think Dr. Singh has some urgent meeting. He is being called by PMO, so we'll have to excuse him. So thank you very much. I think.
Really, beg pardon of the audience.
No, that's okay. So some of the remaining points, I think he has made most of the points. Perhaps Dr. Bhan will also cover in his presentation. May I now request Dr. Bhan to please make his presentation.
Should be there in that also.
Okay, yes. Yes, already this, so they're just putting it.
Listen.
Just go.
Anyway, good afternoon. Again, apology on behalf of India Meteorological Department. Dr. K.K. Singh has to attend an urgent meeting at Prime Minister's office, so he had to leave. So I'll mostly continue from where he left, and good thing or maybe bad, there's a lot of repetition in the two presentations we have. Because they were prepared not in consultation. I was not in the office for the week due to some health issues. Can I make it full screen from here, or you will do that? Thank you. So I've been asked, as pointed out by Chairman, I'll take about 5 minutes and 2 minutes of Dr. K.K. Singh. So sir, please remind me after 6 minutes, I'll try to wrap it there. Thank you. Coming to systems, very basics, though the audience is probably more learned than me in terms of system and system analysis. We have many ways in which systems can be defined. But all the systems have involved an arrangement of the parts, the component of the whole system or the subsystems of the entire system that interact according to some set rules based on the whatever inputs are provided to the system, and then based on the interaction, some outputs are there. And then properties emerge from interaction of the components. And the whole probably is, different from the subparts, and elements can be taken as components, interaction, the boundaries, what are the limits from which a system interacts within that. Then subparts of the systems interact. Then there are inputs. Outputs for boundary for agriculture, if we come, can be taken as soil up to root zone is a boundary. Atmosphere is a boundary for the cropping system. Nutrient status is a boundary. So those have to be defined for coming to analyzing any system. And agrometeorological systems, they study the impact of the meteorological. If you see agro and meteorological systems, the impact of meteorological conditions through the process of transformation of inputs, which are primarily the solar energy, the nutrients, and the carbon dioxide in the air, and also taken in form of carbon from the new soil into an outputs, usable outputs probably. And the knowledge so gained to assess the impacts of and the transformed into these agromet advisory is the agrometeorological system. Further on, there is some repetition, so I will deviate from the presentations. What inputs do we really need for agrometeorological advisory system? If I put the agrometeorological advisory in terms of time span, there are two processes. One is strategical decisions, long-term strategies. Other is the tactical decisions for taking short-term actions based on the immediate weather. For long-term strategies, primarily involve if we see the current situation, the impact of climate change on agriculture. So that involves two things. First, the analysis of the impacts, for which the chairman pointed out in the beginning, the availability of the data. I would like to point out to the House and the audience online that the India Meteorological Department has now come out with gridded data of rainfall and temperature. Rainfall at 0.25 degree grid and temperature at 0.5 degree grid intervals. And all those data are freely available now online on the website of the India Meteorological Department, our climate center at Pune. So those data can be made use of studying the impacts of climate on different crops. And also, the Indian Institute of Tropical Meteorology has come out with the projections of climate over different parts of the country at a grid level of about 36 kilometers up to the year 2100. So based on the interactions, the studied interactions of the historical data and the projections now available up to for next 80 years or so, the strategic decisions based on how the crop diversification should take place, what areas should become more suitable for different crops in different parts of the area. Will the cropping pattern shift? And if that shifts, what kind of varieties has to be developed? Maybe short duration varieties, those resistant to drought, considering the extreme weather events which are on the increase. If we come to Rabi crops, terminal heat stress is becoming an issue. This year's March heat wave probably had some impacts. We have to see on the final data, but it's a known fact that terminal heat stress of February and March have tremendous impact on output of the Rabi crops. So what variety should we develop based on that? It can be utilized into that. How would the pest and disease infestations would be there in the future? So can we develop for that? So those data can be utilized for those purposes. And the advisory system which Dr. K.K. Singh was discussing just now, primarily for the short-term tactical decisions based on the weather, what happened in the immediate past, considering the stage and state of the crop, how the farm operations should be aligned to take care of the just past weather and also the weather which is forecast for in the medium scale up to, say, extended range scale of 15 days or 3 weeks. That involves us for taking a decision, a study of the agrometeorological system in terms of crop weather relationships, in terms of pest weather relationships, and also, though not, I would say, the chairman, sir, that the impact of extreme weather events is not so well quantified so far, because those are sporadic, they don't happen at fixed intervals. So those physical damages, we are not able to, take them into account into the modeling so well, particularly thunderstorms and extreme rainfall to some extent can be taken care of. So the systems primarily are based, we started with statistical models of crop weather relationships. Somewhere in maybe in 80s onwards, we started working on the process-based crop weather models, the dynamic simulation models. One of the pioneers in the country is in the chair today of the modeling. So based on these knowledge gains, we also have now factored into our agrometeorological advisory system what Dr. K.K. Singh was talking about. So we are trying to automate the system. So yeah, sure, I'll take another just minute and a half. So if I can come to that, this is the impact. Can move from here also? No. This is most of a repetition. Economic impacts will come a bit later. So, okay, this was this. Can I operate from here? No. Okay, two important things I'll speak, you need not do it. We have developed a decision support system, as Dr. K.K. Singh was talking about in association with RIMES. The system is capable to automatically pick the forecast for right now up to block level. And some of the process-based findings based on the research carried out by SAU, National Agriculture Research Organizations, and ICAR. Those algorithms have been built into this system. It is automatically taking care of two aspects as of now: the growing degree days for coming out with crop phenology, when different phenologies would appear, and also the crop water requirement. So the farmers can be automatically advised if some stresses are developed for different stages. Also, we are now integrating 10 crop pest and disease weather relationship into the system, for which we have developed the algorithm in association with various agriculture universities. So those systems have been automated so far, and we are able to advise the farmers on likely stresses on particular water stress and likely appearance of pest and diseases. So that's the operational agromet advisory. And the farmers are then advised based on these stresses are appearing, and maybe the pest and disease are also likely to come up. They should take whatever actions required, and those advisory system is giving a lot of economic benefits to the country. Various assessments show that economic benefits range from 30,000 crores per annum to about 50,000 crores per annum, based on the different years. So that's how the agromet advisory system operates. Thank you. I'll stop here. I think the time will be. Thank you.
Thank you very much, Dr. Bhan. I think this work of IMD is voluminous and monumental, so time available is really too short to do justice. But it's a tremendous work that has been put by all the scientists, Dr. Bhan, Dr. K.K. Singh, and all his colleagues. So thank you very much. We'll move on to the next speaker. I think this is Dr. Sweta Sen from IIT Kharagpur. She will be speaking on an empirical study of choices among adaptation and coping strategies and welfare measurement of tropical cyclone shocks in India. I think Dr. Sen is online.
Yes.
Dr. Sen, you have about 5 minutes to make your presentation.
Ma'am, can you hear us?
Yes.
Yes.
Am I audible?
Yes, you're loud and clear. Can you make the PPT your slideshow? Yeah.
Okay. Yes, topic.
And we can start now.
Yes, my
Dr. Sen, you have to move on. We can't see your next slide.
Since we have a time constraint, so I would request the speakers to keep it as fixed as possible.
40 years, and with this, there is an increase in intensity of large storms, which has led to more deadly disasters. In a recent report of IPCC, where climate risk, which is a product of climate hazards, exposure and vulnerability, this can be transformed to resilient state with proper action from governance, finance, knowledge, capacity, technologies, etc. 7% of the world's tropical cyclones occur in North Indian Ocean, where 80% are formed in 80% of that 7% is formed in Bay of Bengal, and the whole coast of east coast of India, entire Bangladesh and Myanmar coast is at high risk from tropical cyclones in Bay of Bengal, and this is a serious challenge as large vulnerable population reside along the coast. And from 1891 to 2020, there has been approximately 42 landfalls in Orissa coast, and among all the cyclonic disturbances, about 22% has been severe cyclonic storms, which has impacted Orissa coast. 45 are cyclonic storms, and 57% were depressions. And the most recent cyclones, Bay of Bengal, which has occurred in Orissa coast, are Fani and Amphan, which has caused economic loss of $1.8 billion, $15.38 billion, respectively. So here in my study, I have identified some of the adaptation and coping strategies, and found its determinants affecting the adaptation to coping strategies adopted due to tropical cyclones, and quantified the household welfare gained from them. So what are coping strategies? They are short-term, immediate routes to escape from the cyclone shocks, and which are taken after the cyclone has occurred, like the selling selling of assets, mortgaging assets, borrowing, and adaptation strategies are long-term strategies which are taken before any disaster, and these measures are taken to protect the households from shocks, and they are like changing of cropping pattern, irrigation, and income diversification, etc. So individuals always tend to maximize utility bounded by numerous constraints, and there are biases and heuristics which are the anomalies in behavior which leads to bounded rationality. This is also explained by the cumulative prospect theory given by Kahneman and Tversky, and the loss aversion behavior of individuals, so where the loss is valued much more than the gains. And in my study, the loss aversion behavior shown by that the loss from the cyclones are valued much more than adopting any coping or adaptation strategy. So, and also in many we will see that coping strategies are preferred more as it is taken after the occurrence of any cyclone than adaptation strategy. So with this background, I have surveyed 504 households from Ganjam and Puri districts in 13 villages, 30 to 35 households in each village. These are some of the pictures. And from the survey, I've identified 4 major adaptation and coping strategies. The adaptation strategies are mostly land-rented, livestock production, income diversification, mixed cropping, and about 55% of the households have adopted any one of the adaptation strategies. And the major coping strategies are discounting healthcare, changing food habits, selling of valuable assets, discounting children education, and about 91% of the households have adopted any coping strategy. And from the joint
Dr.
probability
Sen,
table.
can I interrupt you, Dr. Sen? You need to conclude. Sorry.
Okay. So 2 minutes. From the joint probability table, we see that maximum of the households have one coping strategy, but no adaptation strategy. And we also see that there is households rely on single, not only on single strategy, but they take a mix of strategies, which can lead to endogeneity problem. And in order to address that, to find the determinants of different strategies, multivariate probit model is used, and to see the welfare gain, which is addressed by the increase in consumption expenditure in last 1 year, endogenous switching model treatment effects are done. So this is the conceptual framework. First, the determinants of different strategies are assessed, and then the welfare gain, different strategies. The results show that more income or consumption, more dependent, natural resource dependence, assets, education, and formal access credit leads to more likely to adopt any adaptation strategy. Whereas social cohesion, the bonding and which is represented by the bonding and sharing of between relatives and friends, leads to decrease in adaptation strategy. This may be because they do not tend to take any extra effort to adopt any strategy. The risk, there is high perceived risk, leads to greater likelihood to adopt any adaptation strategy, and risk takers are willing to take risk rather than risk averse people. So risk takers are more willing to take risk.
I'm sorry, Dr. Sen, you will
take any
need to
adaptation
conclude
strategy.
now. Sorry, you've already taken enough time. Do you mind concluding now?
Okay, sir. I'll conclude one more minute. Like in determinants, the main determinants, we see that the income increase in income leads to less adaptation of any coping strategy, and also with more increased risk perceived, there is less adaptation of any coping strategy.
You have 10 more seconds if you want to just make concluding statement. Please, 10 seconds, ma'am.
So, in conclusion, I would like to say that there is interdependence in the strategies, from where we have the trickle-down effect. Risk behavior is very important for adaptation decision, and the suboptimal solution is having both adaptation and coping strategies. And people need to have timely adaptation, which will make them less vulnerable, and there should be change in behavior to increase opportunity for transformation. Last, I would like to thank the coastal households in Ganjam and Puri district who have helped me complete my primary survey. Thank you.
Thank you very much, Dr. Sen. We would now like to move on to the next speaker, and that is Mr. Ronit Jaiswal from IRI. So Ronit, we have about 5 minutes for you.
Yes, sir.
Go on, please.
Okay, sir. Okay. Is my slide even?
Good afternoon. Just before you start, we have a time constraint so that everybody can just precise the presentation.
Okay, okay. Yeah, is it my slide moving?
Yes, you can start.
Okay. So my topic is deep LSTM for agricultural price forecasting, and these are my contents. So we all know agriculture is linked with economic growth of a country, employment opportunities, poverty alleviation, and environment. Promoting growth in this sector alone can tackle many of the sustainable development goals simultaneously. However, government schemes which are running so many are not sufficient, as these schemes are mostly production centric and not market centric. These schemes are helpful in only increasing the overall production, but not the farmer's income in the same proportion. Agricultural commodities, as we all know, heavily depends on the weather extremities and all, and follow the cobweb model, which leads to ultimately high price risk. Yeah, to manage the price risk, accurate and real-time price forecast is the need of the hour. And the need for highly accurate price forecast of agricultural commodities is not only necessary for farmers, but also for policy planners and agro-based industries. Agricultural commodities price series are a type of time series data only, which are recorded over a period of time. And as a statistician uses time series model to discover the pattern in historical data series and forecast that pattern into the future. So various models are developed for price series forecasting. Some includes statistical models and some are artificial intelligence models. Statistical models are having so many shortcomings, like they assume very defined relationship among the data, whereas artificial intelligence models just are data dependent. Among the artificial intelligence models, we are having uh, artificial neural network is the most dominant one, which is a data-driven, non-linear, and having self-adaptive approach. These following are the characteristics of artificial neural network, which is possess the capability to generalize, learn by examples, and have high processing speed. Two types of architectures we are having in artificial neural network. First one is feed forward. These architectures are divided into three layers: input layer, hidden layer, and output layer. In feed forward architectures, the information is flowing only in forward direction, whereas in recurrent neural network, we are having a feedback loop also to minimize the error. Recurrent neural networks are preferred for time series forecasting. So we are using recurrent neural networks for forecasting any price series. However, the training of recurrent neural networks is problematic because the fraction of the gradient due to p steps backward either approaches zero or becomes large. The former case gives rise to a problem of vanishing gradient, while the latter causes exploding gradient. Exploding gradient can be easily solved, but
You lose his connection or?
wait,
You don't see his slides anymore.
is it visible, sir, now?
Yes, go on.
Okay. So for the solution of vanishing gradient, we are having either exogenous variables or using deep learning technique. And here is our research in deep learning technique, which is long short-term memory model. Long short-term memory model is nothing but a recurrent neural network, but it knows which information to forget and which important information we have to retain. This the figure 5 is showing the structure of the long short-term memory model. So the key to the long short-term memory is the cell state, which is like a conveyor belt which process the information, and the to forget and update the information we are using gates. So the three types of gates we use in long short-term memory: forget gate, input gate, and output gate. Forget gate removes the unwanted information, input gate adds the important information, and output gate decides which information to forward. So in the DLSTM model, we are using the stacking of this LSTM layer as a hidden layer. For empirical illustration, we use the time price series data of maize and palm oil from the World Bank commodity price data. These are the time plots of these two series. Yeah. So first we start with the normalized price series. We divide the price series into training set, validation set, and testing set. Training set is then moved to supervised learning format, and then it went to fitting of the DLSTM model. In the fitting, we define the topology of the DLSTM, setting hyperparameters and the training of the model. Using the validation set, we decide the best model using the grid search for the grid search, and then we go for model regularization and then evaluation of the model metrics, model based on the performance metrics, and we use that best model for forecasting. So this is the stacking of LSTM layer. In the hidden layer, we use the LSTM nodes to stack one over the above. These are the forecasting evaluation criteria we used, RMSE, DSTAT, and Diebold Marino test. These are the descriptives of the maize and palm oil series. We can see that both the data is non-normal, and these are the tests for stationarity and non-linearity. And we conclude both series are non-stationary and non-linear. And see, for the maize series, we achieved that DLSTM as far better than the usual time delay neural network and a linear statistical models, which is ARIMA, in terms of RMSE, MAP, MAD, and DSTAT all. And we get 2 hidden layers is the optimum for the maize price series model. And thus here we can see as a bar diagram, this yellow bar is showing the model DLSTM, and we can see that error is consistently reducing. For the PALM series also, we get the same results with the 2 hidden layers only. And to check the improvement, statistically, we use Diebold Marino test for 12 forecasting horizons, and we achieved that the DLSTM model is highly significant and showing highly better significant results in terms of ARIMA and TDNN. And these are the forecast results and performance comparison. See here, the blue line is showing the actual values, and this yellow line is showing the forecast achieved by the DLSTM model.
Jaiswal, you need to summarize, please.
Yes, sir. Thank you. In conclusions, we can say that we developed a promising model, deep LSTM model, and perform comparison with ARIMA and TDNN models. The developed DLSTM provides better forecast accuracy, and we see that the neural network models are better at capturing the patterns of any nonlinear series. However, the training of these neural network models requires skillful handling of data set, vigor coding ability, and ample amount of time. Thank you so much.
Thank you, Mr. Jaiswal. I think this is a very interesting presentation, although we did miss agrometeorology in this. Unfortunately, we don't have time for questions right now. So may I now request our next speaker, Professor Upasana Sharma. She is right here. Professor Sharma is Associate Professor, School of Public Policy, IIT Delhi. Dr. Sharma, you have 7 minutes.
Hi, good afternoon, everyone. In the meantime, while my presentation is being put up, I'd first like to acknowledge the role of IMD and Chaudhry Charan Singh Haryana Agricultural University in facilitating this work. This work that I'm going to present, very briefly, would not have been possible without Dr. L.S. Rathore, Dr. K.K. Singh, and Professor Ram Nivas, Professor M.L. Kitchard, and Professor Surinder Singh, and many others actually. But thank you so much. So because time is short, I'm going to skip many slides. So basically, we wanted to see whether these SMS-based advisories that are sent to the farmers in different states by the agri-med field units, which are located at the agricultural universities, CCS how in case of Haryana, do they really make a difference to the decision-making of the farmer? And does it improve uptake of agri-med advice by farmers, these SMS advisories? Two main questions. How the information reaches the farmer, and once it reaches the farmer, does it make a difference? The agri-med advice, so I'll not go into details of agri-med advice because that has been discussed pretty well by Dr. Bhan here and Dr. K.K. Singh. Where the many potential channels for agreement advice reaching people, mobile phones is one of them, and we wanted to see whether mobile phones make a difference in uptake and whether they really affect farmers' decision making. Essentially, we did this study. I'll skip the review of literature, but the main point here is that most of the literature showed that SMS agreement advisory services had a positive impact on farmer outcomes, but most of these were correlational studies, and we wanted to do a causal one. So we set up a randomized control trial, actually. So I'll skip this as well because you all have this information. And this is a sample of agreement advisory for wheat crop, which was sent on a mobile phone. So the first one is like weather changeable from 10th. This is literally the text of the SMS. The messages were sent in Hindi because we are looking at Haryana region, but we've translated that into English. So my research questions were, does provision of agreement advisory via SMS lead to greater uptake of advisory? In other words, does it lead to greater compliance with the advisory recommendations by the farmers? And does cost differ for those who received agreement advisories via SMS? And does yield differ for those who received agreement advisory via SMS? So our hypotheses were farmers who received the agreement advisories via SMS are more likely to comply with advisory recommendations with respect to crop growth cycle. So basically what we did was that we looked at three different aspects. One was, decision making of the farmer with respect to normal operational decisions in a crop growth cycle like irrigation, like sowing and so on. And one was when they received advisory regarding there's going to be an adverse weather event and you should not do a particular operation. Did they comply with that? And the third thing we looked at was, were they able to use rain advisories to reduce their irrigation? So these were the three outcomes that we were looking at. So study site, as I mentioned, was Haryana. We chose 2 districts in each of the 3 agroclimatic zones. Panchkula, Ambala, Jind, Palwal, Mewat, and Hisar. Sorry, this is pretty slow. I don't know why this is not showing up. Okay, study design. As I said, we set up an RCT in an interest of time. This is published paper, so you can easily access it if you're interested in the study design. But we followed the protocol of setting up a randomized control trial, so I'll not go into full detail of this. But the thing was that there was a control group of farmers, there was a treatment group, and to the treatment group, the CCS HOW was sending the SMS advisories. We chose the control group in a manner that initially they were not receiving any sort of advisory, and that is where we had needed CCS HOW's help, rather their database to whom they were sending. So we chose villages where the advisories were not being sent and so on. So again, the details are there in the paper. I will not go into that. But essentially, what did we find? Just let me quickly scroll through this. So basically initially we started out with 600 farmers, but obviously there was attrition because this was a relatively longer study over a period of 2 years, 2016-17 Rabi season and 2017-18 Rabi season. So one of the things you check when you're doing a randomized control trial is, are the farmers in treatment and control group similar? And we find that they're very, very similar, except that in treatment group and there seems to be some difference in operational land holding, but that's minor, it's not too much. So they are similar, so they can be compared. Variables of interest, I mentioned those 3 variables or outcomes, so I'll not go into detail again. I'll like to move, because this will take too much time explaining, I'd quickly like to move to what did we find. We did a difference in difference analysis, a difference in difference regression approach we took. And so what did we find for crop growth cycle based advisories? We found that except for compliance with irrigation advice, first irrigation advice, we found in every other kind of advice, there was greater compliance by farmers who were actually getting the SMS advisory. Now, SMS advisories were effective, but the thing is, this was intriguing because farmers are usually well aware of maintaining these time intervals for different operations. But this indicates that nudging the farmers about following good practices that he or she may already know still may render benefits. What did we find with respect to weather-based, where they were advised not to do a particular operation because of a particular adverse weather impact, so farmers who did receive weather advisories managed to utilize that advisory to avoid some of the irrigation and therefore the associated costs. And we know that the costs in Haryana are pretty high because of sometimes diesel being used, not always electricity, for pumping water, right? We do find that for many other variables, we did not find the effect, but there are many reasons for that. Again, we could discuss if you're interested. For cost of irrigation, yes. And for yield, again, the difference was very minimal, but it was significant nonetheless. Did a lot of analysis and robustness checks. So our piece of work had implications for different kinds of audience, particularly for IMD and AMF agreement field units, and of course, the farmers themselves. But more of that if there is interest. Thank you so much for giving me this platform.
Thank you, Dr. Pasa Singh. I think that was a very interesting presentation, although I missed your last point. What is your message to IMD? What they are doing is useful or not?
Advisories are delivered in how the content of the advisories the channel, the SMS advisory route is great. Of course, one will have to do better things because upgradation of phones is taking place, but there's still a large number of farmers who are still on the basic phone. So it is very, very useful, but improvements are needed. And what are those improvements is a detailed discussion.
For us, Dr. Pasa.
Great. I'll be happy to.
If you can formally recommend to.
Sure.
I think that's a very important and very healthy conversation. Findings like yours from social scientists to some of these technocrats would be very useful in fine-tuning their work. So good. Thank you very much. Unfortunately, we have to move on. The next speaker is Dr. Amit Kumar. Dr. Amit Kumar is from Central University of Jharkhand. Dr. Amit Kumar, are you there?
Yes, sir, I am here, sir.
Please go ahead. You have about 6 minutes.
Thank you, sir. Is my screen visible, sir?
Yes, we can see your slide.
Thank you. Thanks for giving the opportunity to present my one of the work here. My work title that I am presenting here is the evaluating the impact of extreme climatic events in the mountainous urban system of the Himalayan region. And as we all know, it's covering a wide set of area in the northern part of India. It is Himalayan region is not only concerned in the Indian region, it is also spread over the Nepal and the Bhutan region. And in the last few decades, the large scale of land transformations has accelerated the anthropogenic contribution in the global climate system. And that has evident in the change in the precipitation and temperature patterns overall, and it has also experienced in the form of the extreme events, that is reading with the number of high warm days, cold spells, extreme flood events, and so on. So considering the fact that we have taken into this taken this research take-up work, and we found that this particular type of extreme events is basically more influential and more effective in the regions of Himalayan region, which is a mountain ecosystem, and leading to a various severe challenges in the region. So considering this fact that we have taken up the data of era 5 with having a resolution of 9 square kilometer of horizontal level, and to reduce the long-term, almost 119 years of data analysis for the temperature and precipitation pattern. Later also the CRU-based data sets, climate research unit data sets, also used for the analysis. So in this, we have used, like, as I said, the European reanalysis data of ERA 5 has been used to extract the information of the precipitation and temperature variables. We have extracted the temperature, 10 temperature indices using the maximum value of daily temperature, maximum value of daily minimum temperature, minimum value of daily maximum temperature, warm days, dry days, cold spells, and likewise for the precipitation pattern, the maximum amount of precipitation in single day, simple daily intensity index, heavy precipitation days, wet days, dry days, those things we have evaluated and based on the ERA 5 data sets. While the CRU-based data sets used for the long-term analysis for the annual mean temperature, maximum temperature, and minimum temperature, and also for the precipitation pattern. Overall, that has been again used to analyze through the trend anomaly pattern for the entire Himalayan region as well as the major urban centers. So these are the list of the various indices that has been used with their details. And these are the outputs here, where we can see this slide is representing basically the temperature patterns in the Himalayan region over the 118 years. This mean temperature is defining the pattern, is basically having the longitudinal pattern and changing latitudinally. And we can see the star patterns are there, that is defining by the topographical variability in that region. And mean temperature generally doesn't give a significant outcome and reliable concrete information that way. So we have analyzed the minimum temperature trend and maximum temperature and so on. We found that the temperature trends, there is a shift in the temperature trend. Basically, the minimum temperature range has increased to a higher side as compared to the minimum temperature. Both the temperature, minimum and maximum, has been shifted to the higher side, and the minimum temperature has been changed rapidly. And the pattern of precipitation in the Himalayan region, again, we have taken the cumulative mean annual precipitation to understand the pattern overall during the 118 years. It has some significant pattern, like we found that lower precipitation in the northern northwestern region as compared to the northeastern region, while the temperature trend of annual precipitation exhibit a slight distinctive figure, that is like we can see the deficit regions are in the central and the eastern Himalayan region as compared to the western Himalayan region. We have performed the standard anomaly for the specific anomalous period based on the cumulative mean annual precipitation, and try to relate the extreme events observed over the different period. We found that it is well matching with the extreme events occurred during the period 1917, 33, and 1996, and somewhat 2014 and 15. Rather, we found that basically the 2014 is very prominent for the Kashmir flood region, and the region is not so anomalous. Pattern was not so anomalous in this area. Whether we can see the range is in green, ranging from 1.5 to 2.5. We found that in detailed study, we found that the rainfall was occurred in the upper catchments of the Srinagar city, and that led to a devastating condition where itself the city has having the normal to moderate, highly moderate rainfall in that area. So next we have come to the extreme climatic indices. We have analyzed the cold days and cold nights, warm days and warm nights. And when we check into this perspective, we found that there is a decreasing trend in the cold indices, basically the cold days and cold nights, where it has decreased by 2 to 6% on an entire days in a year for the entire length of Himalayan region. While at the same time, the warm indices, basically the warm days and warm nights, has been increased. Basically, it has increased.
Amit Kumar, please try to summarize now.
Okay, sir, please give me 2 minutes, sir. In the eastern and central Himalayan regions. This is the same representation representing the different perspective, the number of cold days, cold spell days and warm spell days. We can see the changes has observed basically in the cold spell days has been almost has a reduction, while the warm days, warm spell days has been at increasing trend, basically in the eastern and the central Himalayan region. The trend of extreme precipitation was also analyzed, and we found that there are erratic change has been observed during the number of heavy rainfall to very heavy rainfall and consecutive wet days. And it has a concentration in the central Himalayan region as well as some pockets of the eastern Himalayan region. While the consecutive dry days in this entire area has been increased in a segregated form throughout the Himalayan region. So this is one of the very key slide of this presentation, in which we have taken the input from the all this perspective, like all these indices of temperature and precipitation taken into one platform, and all the cities of 7 major cities of Himalayan region taken for analysis. We found that there is shift in the temperature with temperature and precipitation based on is the balance means it's normal. And we found that in the Himalayan region, Kathmandu and Dehradun observed comparatively higher warming and the reduction in precipitation pattern while the Srinagar observed an increasing trend of precipitation. So this is the last slide, and the study exhibit the Himalayan region is warming, and this is primarily higher number of warm days were observed in the central Himalayan region and warm nights. Along with the and as compared to warm nights, means warm days are increasing more, and as well as the number of cold days and cold nights declining, especially in the central, eastern, and western Himalayan region. Similarly, we have analyzed the precipitation is declining and are more erratic as observed with the percentage of wet days, very wet days, and extremely wet days are declining moderately in the entire Himalayan region, especially in the central Himalayan region. And the city scale study exhibited comparatively higher warming condition in the Kathmandu and Dehradun urban agglomeration, while an apparent reduction in the precipitation recorded in the Kathmandu and increasing trend of precipitation in the Srinagar. So the study recommended to go for the nature-based solution, adopting green space provisioning methods to mitigate this adverse climate-based adversities, and the promotion of green brew infrastructure in the fragile ecosystem of Himalayas is very pertinent, and also the development process which is being taken up there can be considered meaningfully and considering all these recent changes. Thank you. Thank you, sir.
Thank you, Dr. Kumar. Thanks a lot. We don't have time, sorry, for any questions. I think there's one more speaker.
Yes. So we have one more speaker joining us virtually, Dr. Kripan Ghosh, Head of Agriculture Meteorological Division. So I would like you to just keep the presentation as precise as possible, and we need to wind up. Dr. Kripan, yeah. So we can see your slide, yeah.
Go on, Dr. Ghosh.
Yeah. Fine. So mainly this is that weather information for management of pest and diseases, and that too also with Agromet Advisory Services. And already actually I joined late because I got that link and I could hear only one side to speak only for 1 or 2 minutes. So I feel that Agromet Advisory Services, what IMD is what is operational in IMD, that has already been discussed. So I'll try to give some idea regarding that how this pest and disease part that is taken care of in that advisory services. It's not moving, I think so. Yeah. So already we know that I will be skipping all these slides, that we know that how this pest and disease that is affecting the crop. And if we consider the global scale, that present days, this climatological impact, disastrous impact, that is already increasing a lot, and as compared to the other which was dominating previously. And if we consider that agricultural sector as compared to the other sectors, that 26% is mainly absorbed by agriculture, the damage of the crops. And when we are coming to your this specific disastrous, that weather disastrous events, that because of this climatological event and crop pest and disease, that is affecting 9% loss, that is all over the this globe as compared to the other climatological events.
And I have also enlisted here that impacts in Africa and Asia, where it is maximum. Though Asia is, if we consider the percentage contribution, that is less, but because of this vastness and production consideration, this financial loss is quite high. So I try to give some kind of idea that what are the global losses, and I will not mention here. Only we can mention that this is the recent report of IPCC Secretariat of FAO, that 40% of global loss, that is almost happening every year. Now, this is for the Indian region. In every decade, I have tried to bring out some kind of information, and it is observed that this climatological impact on pest and disease formation and its impact on crop, it is also huge in India itself. This is the disease development. It may be known to all the this agrometeorologists. So this is the pathogen which will be at this vulnerable condition. That was along with that conducive environment and host pathogen. When this interaction will be there, then only disease will be occurring. And if any one of them can be removed, it can be managed, then positively disease will not be there. These are the different weather elements which are affecting that both insects and diseases, and optimum condition of those weather impact, weather information, that is very much important. So this I try to enlist different this impact of weather events on this insects and pest development and its impact on crops. So this is the temperature itself, which is actually affecting your photosynthesis and transpiration of the crops, as well as the root system, which is reducing the immune system of the plants as well as crop. And it is also influencing the incubation period, generation time, and infections period. So when these two will be amalgamating, and ultimately specific temperature condition, it is helping the crop, helping the disease as well as insects to develop. A similar way, I try to bring out the effect of soil moisture as well as that air moisture, relative humidity, and then your this impact of your this soil temperature. And I try to bring out that when this will be the combination of impact of temperature as well as relative humidity, and how this is giving the impact on this insect as well as diseases. Different authors. Similar way that your this raindrop, it is helping that splashes and all, how these are helping in transmission of the disease, as well as the dew, it is helping in leaf wetness, longer period, and ultimately disease development. So time constant, I cannot explain all these parts. Similar way that wind, a very specific in this example is this during 2021, there was this desert locust multiplication migration, and that happened because of this 850 HP level, means 1.5 kilometer level of wind. Similar way, radiation also, this is also influencing. So I will come to this role of IMD, what is happening present day under AS system itself. Already IMD in collaboration with different SIUs, we try to collect that information. Only a few I kept it here. The regression equation, which will be giving the number as well as that congenial weather condition, which will be helping you to go for your automation, or as well as the alarming system based on what the experts can generate their agromet advisories for pests and diseases. And these are some pest weather calendars developed by IMD as well as that different agricultural institutes. I kept it here. And recently, and these are the agromet advisory services where past weather, your weather forecast, and the sensitivity of the crops are being used for giving the pest weather this information to the farming community. These are different kinds of forecasts. And finally, these kinds of inputs are being used by the experts for giving that advisory, so well in hand. And presently, one platform has been prepared, developed under the IMD system, which will be integrated, as Vansar mentioned, with the agromet DSS, and ultimately it will be helping the experts to get the alert message and prepare the agromet advisories for communicating to the farming community. So presently, the status is that it has been developed for 8 pests as well as 25 diseases for rabi crops, and 22 pests and means insects mainly, and 27 diseases for with the platform. And finally, this is the idea is that along with this, all the crops we will be trying to cover along with the pests and diseases, whatever it is available, and at the same time, different agromet field units and district agromet units, what has already mentioned by 2 speakers before, what they are developed at their universities, those will also be integrated with the system, and finally, the agromet advisories will be prepared and given to the farming community. Thank you very much.
Thank you very much, Dr. Ghosh. With this, I think we come to conclusion. I think, although we are running late, let's see if there are any questions here. Any question to any of the speakers? Anything on
No, I
the
think, yeah.
web? Any questions there?
No questions in the chat box as well. So I
All
think we
right.
can.
So with this, then we would like to conclude this session. I'm very sorry. There was a very distinguished panel, but unfortunately, because of time constraint, I had to cut down practically every speaker. My apologies, but I think you made your point very well. The very interesting points that have come up. You have seen very seasoned work from India Meteorological Department, the great summary by Dr. K.K. Singh and Ban, and also good feedback from Dr. Upasana Sharma and others that how exactly these advices could be further fine-tuned. There were some young scientists, some very interesting development in terms of artificial neural networks and other sorts of modeling that can provide further insights into fine-tuning this whole agrometeorological research. May I now request all of you to please join hands to give a big round of applause to all our speakers. Please. Thank you very much for your patience.
So we have a question in the audience. Yes, sir.
Mr. Chairman, thank you very much. Just a small question or my observation rather. Most of the models, I think you're pioneer in this, either empirical or either agriculture or eco-hydrological model. Basically, they are, the what we call they're taking care of only the current meteorological conditions, whereas what we require is an agriculture-based models which can actually capture the future climate conditions. I think if you can throw something, maybe it's useful for the audience. Yeah, thank you very much.
I think that's a very important point. Unfortunately, because of time constraints, some of the speakers could not do justice to that. You're spot on that we really need to think not only of what is current, but also in terms of future. So we need modeling which can address some of these. Thank you. Thank you very much.
So as we have reached the ending of this session, now I would like to thank each one of you for gracing us with your presence. Now, before we part ways, on behalf of TIFAC and IIASA, we would like to felicitate you for being our honorable speakers for the day. Now, for speakers joined virtually, I express my appreciation for your valuable contribution to our conference. Thank you so much. And to present a little token of appreciation, I would request our keynote speaker, Dr. Pramod Agarwal, to hand over the token of appreciation to the speakers. Firstly, I would request Shri Subhash Chandravan to receive the token of appreciation. Thank you, sir. I would request Dr. Upasana Sharma to kindly receive the token of appreciation. Now I would request Ms. Sangeeta Bakshe to please kindly hand over the token of appreciation to our keynote speaker, Dr. Pramod Agarwal. Thank you so much, sir. It was a pleasure to have you all with us. I extend my sincere gratitude to each one of you. Thank you for joining us. I would request all of you to join for the lunch. Thank you.
we have our session starting at 2 sharp. So Professor Rangan Banerjee, who's a keynote plenary, he's coming from IT Delhi. He's a director there, so he should be here at any time. So we'll see that we finish the lunch quickly and we could come back at 2 here. Thank you.
Hello. We cannot hear you.
And a huge round of applause for Professor Banerjee first. Thank you so much, sir, for coming. May I request you to kindly just come on the dais? Thank you. I just want to briefly introduce him, first of all. He served as the Forbes Marshall Chair Professor in the Department of Energy Science and Engineering. His major area of interest includes the energy management, modeling of energy systems, energy planning and policy, hydrogen energy and fuel cells. Professor Banerjee has been serving on the editorial boards of International Journal of Sustainable Energy, International Journal of Sustainable Thermodynamics, Solar Energy Advances, Global Transitions, so on and so forth. He is the faculty advisor of Team Shonya, the India's first student team in the Solar Decathlon Europe Finals. Professor Banerjee, please. Thank you so much.
Thank you. Good afternoon. And I think we have some people online and some people here in person. I hope, can we have the presentation? Is this the changer, slide changer? On? Yeah, I understand that, but it's not. Pointed somewhere else or? Mic is off. On? I think. So good afternoon. I realize we are all running behind time, so I would request the organizers, when it's about 25 minutes, give me so I will stop and then take questions if there are. So I'm going to sort of set the stage and give you a perspective on sustainable energy transition in Asian countries. About too much about all Asian countries, but I mostly focus on India and give you a perspective. And then okay, so first thing is we have in the title sustainable and energy transition. So let's start with what is an energy transition? And you'll see that an energy transition is a particularly significant set of changes to the patterns of energy used in a society, different definitions. And the important thing to realize is that energy infrastructures are not just technical systems, they are socio-technical systems. And the system transition creates a substantial change in the state of the system. And that is why we need to be able to study it. And I know that today this conference is about systems analysis and modeling. And this is the challenge before us, to look at what happens when we talk about energy transitions and what characterizes a sustainable energy transition. So to go forward, why is it important? I'm sure you've seen this image before. This is much sort of, Google, you'll see it. It's basically an image which talks about the same street in Manhattan over a period of 10 years. And you'll see in the first image, you'll see that it's all horse-driven carriages, and there's one IC engine vehicle over there. And just about a little more than 10 years after that, there are all IC engines and there's only one horse-driven. It shows a very rapid kind of transition. And we are, of course, moving towards the transition, and the transition has implications because we have existing systems, we have people whose livelihoods depend on it, and all of this has implications. So if we move ahead, again, because of time, I'm not going to first rethink. We have some perceptions of what happens in terms of transitions. In the last 40 years, for instance, if we see, I asked the question, what has the share of renewables in the primary mix in India more than doubled, remained almost constant, decreased, increased by 10%, none of the above. And the interesting thing is, it's a sort of, most people think the correct answer for this is actually decreased significantly. And what you need to see is, go forward, you will see that this is a tri-axis plot, and you will see that basically what happened is in the 70s, we had a significant amount of traditional energy which was being used. And we had this transition where that traditional energy has been moved to fossil. We also had a significant amount of hydro. So actually, in the last 10 years or so, we've been shifting back to renewables. But if you take a long time period, we made a transition from traditional renewables to modern fossil. and then we're moving back in that direction. So if you look at the directions, yeah, this is the direction in which we've got increasing coal, renewables and nuclear decreasing. The challenge is to go back down that pathway. If you look at now the power sector, you will see that it was almost like 40+%, which was large hydro, and then we've now gone to about 80% fossil, and then we are now moving back. And so that's the kind of challenge that we had. We've moved with thermal, nuclear remaining almost constant, renewables and hydro over a period being decreasing. And now we are trying to see how we can move back. And of course, we have different ways in which we can move back. We can go with predominantly renewables, or we can go with renewables and with a higher share of nuclear. There are issues related to that, but that's not the topic of our discussion today. So what has been the transitions in the past? And as I said, this is for India, but this will be true for most of the Asian countries. We made a transition from traditional fuels to modern commercial fuels, mainly fossil. We've also made very significant investments in centralized energy supply and distribution infrastructure. We've created a large centralized interconnected electricity grid. We've had large hydro and coal-based thermal power plants. The focus has been on augmenting supply. The entire thing has been let's augment supply. Most of it has been through public sector and government investments. As we move forward, what are the drivers? And you are all familiar, we are sort of preaching to the converted. All of us are in the same thing. The main driver today, climate change, Paris commitments, Glasgow commitments, global move away from fossil. We've also been supported by significant drop in the prices of solar PV and wind, reduction in prices of shale oil and natural gas. And in the Indian context, we've also had significant successes in public procurement of energy efficiency and rapid decline in prices. There's another trend which we think should make a difference, but it's not showing up so much. There's been a significant improvement in terms of technology development on IoT devices. So intelligent sensors, controllers. So we would expect that we would have large number of more distributed energy systems, but that's not what's happening. So as we move forward, yeah, so this is typical, I will share the slide. This is sort of energy balance of India today, and you will see that predominantly it's still coal, oil is a significant import, and a lot of our energy goes to the power sector. Let's move ahead. So what is the issues? What are the issues in our energy transition? One of the issues is the changing supply mix. The focus on looking at efficiency. In the transport sector, moving away from oil is a big challenge. We are looking at CNG, we are looking at electric, we are looking at biofuel, hydrogen, methanol, shifting from private to public transport, and what COVID has taught us that we can even reduce the demand for travel and air travel. Another transition not much talked about, cooking energy. We are making the transition from traditional biomass to LPG. That's a stated government objective. Now, when we want to move forward, are we going to do modern biomass? Are we going to look at electric cooking? Again, a question not much studied and looked at. In the case of buildings, in the Indian context, if I go to look at 2047, look at 20 years or 30 years ahead, and you see the building stock and the rate of growth, a large proportion of the buildings which will exist 20 years from now have not yet been built. So that gives us a big opportunity to look at net zero and energy plus building. Industry can go low carbon and we can go to zero carbon, we can look at, but given the existing technologies and the kind of constraints, it's not going to happen in a business as usual case. Move ahead. And these are some evidence of the things which I said, solar prices going down, LED price reduction, IoT sensor price, this is international prices, again going down. These are some of the things. And you may have seen our Paris commitment, which talks about essentially, these were the initial commitments. This has now gone to where we now have, we have increased our commitments, and we said 50% would be based on renewables and emission intensity would reduce by 45% and net zero by 2070. We have a whole host of different options. I'm not going to discuss that. So, for 2070, if you look at the existing CO2 trajectory, there are many different ways in which we can go to the 2070 goal. And this is just one of the possible pathways. Within that, you can see, so whenever we think in terms of planning a transition or looking at, there are choices. And there are multiple ways in which we can go ahead. And when we look at that, so this was the Indian context, past transitions, and what we are planning for the future. I'd just like to show you that other countries in Asia also significantly today are fossil driven. So this is 2021 numbers. Of course, you may not use BP, you may use IEA, the numbers will change a little because the way they treat biomass is different. But basically the thing to see is that if you add up all the things, fossil is significant in most of the countries. And if we go ahead, you see even in the power sector, you see primary energy consumption per capita. Differences are there, of course, in India. It's still a lot of things to be done in terms of development. Many others have developed in that sense. And you will see that CO2 emissions again have a proportion. So this just gives you this. Most of these, many of the Asian countries have announced. So we are starting with a situation where we have an infrastructure which is predominantly fossil based, and we have announced an intent to become zero carbon. Different countries have different years. People have taken 10 years, 20 years, 30 years, and we've taken 40 years as a target. And now the question is, what are the implications of this? Where does model? What are the challenges? What are the models? So I'm going to show you some quick numbers from some exercises we did with the IESS, that is the Niti Aayog has an energy calculator, which we at Bombay, we were working on updating that, and I'll show you some numbers of different kinds of scenarios. So we looked at the target here was for 2047, and you can look at basically the 4 different pathways which are there. You'll see that in the 4 pathways, the share of renewables in the capacity can go we can actually look at terms of capacity, it can go to, because that's the target that we put. So we can actually meet the 2030 targets and we can go to this. Again, for each of this, there's a detailing of what it implies, and this is something that we need models for. This also shows you the whole spectrum of GHG emissions that we can have under the 4 different scenarios. And per capita GHG emissions, again, we can actually go to a situation where we go lower than what we are today as we go forward. And then the emission intensity of GDP, we can meet, basically these scenarios show us different options by which we can meet all of our targets. So this is all possible, and modelers are very good at generating these kind of numbers. The question is that, what is meant by a sustainable energy transition? How do we assess if a transition is sustainable? Who are the stakeholders and how will they be impacted, and what is the role of systems analysis? These are the questions, and I'm not going to be able to cover these questions in the time that is there, but I'm going to show you some glimpses of things. So what are the issues? The first thing is the nature of our energy system is changing. Essentially fuels, which are high density fuels, which can be dispatched, which can be stored easily, and then you have a way in which you operate that. Now we have, by and large, non-dispatchable, if you are looking at wind or PV. Because biomass is there, but there is daily and seasonal variability, there is fluctuation when there is planning. So there is a need for storage, there's a need for flexibility, there's a need for supply-demand matching, and the rules of the game are different. There's another issue, because of climate change, there is an impact on renewables. I'll show you some results from that. So we also need to have resilient infrastructure. We also need to see extreme events, whether it is on renewables or whether it is on fossil. We need to assess for ourselves during this transition, what will be the impact on the economy? What happens to all the investments that we made in our fossil infrastructure? Who has paid for this? Well, many of them are taken with
loans, which are, and remember, many of them are government-based. So then there are banks, and so who takes them? What is the cost of the transition? What are the alternative pathways? Are there pathways by which we can minimize these costs? What happens to stranded assets? Because rules of the game have changed. Addition to that, regional differences. I'll show you some example of that. Then the question is, finally, does that make our energy during the transition, will it be affordable, will it not? What will be the impact on vulnerable populations? If you see what COVID has taught us, the differential impact of COVID, economic impact of COVID, many studies are there which show you that it is vulnerable populations which have been impacted much harder. The inequity has increased, and equity impact. These are things that for the modeling community, key in the questions of modeling what happens in transition. It is not just about getting the numbers and knowledge. And most of these questions or models are not able to answer. So just to give you an idea, just you can see this, and into the last 2 years, if you have our wind is very, very seasonal. And that has implications, and you see that in Tamil Nadu. That's a topic of a separate discussion, but then that means overall over the year, our load is more or less this. And unfortunately, the season where you have the highest wind is also the time when the agriculture, it's the rainy season. So that's a problem. And you can see that for Tamil Nadu. For instance, if you build 3,000-4,000 megawatts of capacity in some particular months, you hardly get 100 megawatts. And so, this has implications from a system point of view. In the initial phase, it's fine, because you just have a thing where you incentivize and you say you get so many rupees per kilowatt hour. But when you have large scale, then the whole thing changes. And so these are issues. And there have also been some interesting issues that over the last few years, the wind output for plants have decreased. And there's a very interesting paper, some of you may be. As a result, also, the rules of the game were such that initially renewables are must run. Because renewables are must run, the PLFs of coal-based power plants have decreased. Because coal-based power plant average PLFs have decreased, there are many coal-based power plants which are now not viable, and they become stranded assets. This is an interesting paper which talks about decrease of wind power potential in India based on the warming which has been, it's a climate impact, and it's very interesting. They've shown different regions and they've shown what is, and so these are again things which we need to understand and see. I'd also like to show you basically what happens is that if we had predominantly solar, right? If we had predominantly solar, our demand, etc., is more in the evening and nights. And because of that, what happened is that the traditional California dark curve that we have, I just show you for India what happens is if you look at if the penetration of PV keeps going up, then beyond the point, what will happen is every unit that is supplied during the daytime in PV has to actually storage and reset some other. So this is not factored into the costing portion because each thing has been in terms of individual projects, not in terms of these. So we'll see changes in the rules of regulation also, and you can see basically what happens also the ramping up, ramping down of the plants becomes an issue. So these are all sort of technical issues, but these are things which models cannot in terms of it. But what models cannot, so you go to a point and you can see at what percentage of generation you need to have and what will be the amount of storage. And of course, this is on an aggregate level. No one decides at an aggregate level. Everyone takes their individual decisions. And so those are also the kind of things. So these are more or less technical kind of issues. Let's look at that. There's another issue which we had studied a little bit. The PhD student had worked on this. And this is an issue where we see that we make some investments in the energy sector. And if that means, well, there's an assumption. So that you have to have a model of the economy and you say that you make certain investments, you don't make investments in other things, then you will, the sectoral mix and the growth changes. And so we did a decomposition analysis and then used an input-output model and then tried to show under different scenarios what happens to different sectors and what also happens to different classes of population. And so there is an equity impact, and interestingly, it showed that unless you targeted it, the equity impact of some of these aggressive renewable targets is not necessarily possible. So that's another thing to look at. I'm not going to bother about the numbers. There's a paper which talks about it. I wanted to show you one other thing, which is most of our renewables, Rajasthan, Tamil Nadu,
Yes.
most of the coal and fossil are the east, and we are talking of Jharkhand, and we are looking at. So we looked at a situation where we said that in Rajasthan and Chhattisgarh, we are looking at a certain amount of generation from PV or from coal, and you offset a coal-based plant, and then you see what are the jobs created. We also see the entire life cycle and see what is the kind of job creation, and created a framework to see net there's a positive number of jobs, but the displacement of jobs is different for different states, and that's the kind of framework, and these are the kind of things. We didn't do the economic impact, but basically the question is if it was done, if the PG plant was at Chhattisgarh itself, we can see that it sort of offsets, and you can see the jobs in different categories. And if it was in Rajasthan and Chhattisgarh, where is it? So the reskilling, the job loss has to be worked out, the economic impact. There are many states which actually the economy depend on fossil, and we need to work out what happens in terms of transition. Time do I have? How much time do I have left? 5 minutes more. Okay, great. I'll quickly sum up so that you can have questions. I just also want to say we did a study, again, this is a PhD work Amit had done, where we looked at different kinds of village electrification, and we tried to create a framework to see what is the impact. And in this, basically what we were looking at, health, education, gender empowerment, and impact on local economy. That PV, we looked at biomass and different things, and in each of these, basically we use the system dynamics kind of approach, and we tried to see what happens with electrification and what are the kind of things. Created these frameworks, got some data still. So each of these indicators, you can see the kind of linkages, and these are the kind of things I think we should be doing. We also looked at the Women Empowerment Index, impact on women, and then the impact on health, and the local economy. We tried to see how much of the flows, cash flows are coming from outside the economy. This is, of course, a little tricky to do, but we made some estimates, and I think this is very important because finally that will look at the employment potentials and things. So just to illustrate to you some of the kind of things which is there, impact on local economy and the household expenditures, and then the impact on local economy and micro enterprises. So these are some of the things, challenges in terms of the modeling. I'd just like to also say that there is a lot of scope in all of this for innovation, interdisciplinary and grand challenges. And in IIT Delhi, for instance, we've had some things where we created some prototypes where we have a three-wheeler running on hydrogen, biogas. We're looking at different kinds of technologies for hydrogen fuel generators and other things. Getting young people excited about challenges is, I think, a way to look at possibilities. One of this is a student team which I was associated with in IIT Bombay, which built a fully functional solar house. This was the. It's possible, and you learn a variety of things. They monitor the performance of the house and that how the performance with simulation, and you read the cooling load and a variety of things. We also had. This was the second team, which went to China, our first team project done. So I'd like to quickly summarize, and then if there is time, I'll take the questions. The first thing is low carbon and net zero futures are possible, but transition is not easy. Several costs and impact. The national priorities of development, equity, access, and security are equally important when we think in terms of this. There are significant uncertainties in many of these. And this provides a scope for research on technology, systems, as well as policy. We need to think in terms of reorienting the models. we are as modelers, we are always tied to our modeling framework. We need to be able to reorient our models to assess the costs of the transitions, to look at the impacts to vulnerable populations. We need to relook at the modeling framework, check the robustness and value for improved decision making. And this is an important task that we have. There are multiple different futures to understand. We need to understand the future and see what would happen at the future. A challenge and an opportunity for all of us. Thank you so much for your patience, and there is time for a few questions that we have to take time on.
Thank you so much, Professor Banerjee. It was indeed a very, very enlightening talk from your side, and you did it like very, very timely. I mean, it was no delay. And any questions if you have before he leaves? Okay. Yeah, somebody has to give him the mic, please. No, we are here.
Hi, I'm Shankar Ghosh from the Celestial Earth. Small question, maybe. Our GDP and population projections are probably going up. And whatever I saw in ISS, it was the behavioral pattern that we saw was just in terms of the transport sector that we see a kind of flattening. So that's why even if our power systems are maybe getting 80%, 90%, 100% renewable, even then our demand side still produces that much of emissions by 2070 that it still is, we are emitting more than we are emitting now. So what could be the, as an energy systems modeler, what could be our approach?
See, technically, of course, we can always tweak the numbers and see, but overall, there are two things. One is there is growth. So growth, long term, there will also be saturation. Transport, there is saturation. In the case of transport, there are issues because one is, of course, if we decarbonize our electricity sector and we go all electric, or we are going for hydrogen or biofuels. Now, in hydrogen, the technologies and costs, we are talking of a large-scale hydrogen, but there are many. And what we need to understand is that when we think about the future, we need to deal with uncertainty. So we should not keep talking about one particular future. We should look at ranges of futures and what if kind of things. GDP growth, etc., are usually based on government projections, which what comes out of the models is not the numbers, but the trade-offs and the possibilities. And that is what I to reorient our models towards, to see today's decision, the impact and the things and what we and put the uncertainty in balance. So it's a tricky thing because there are many elements of the reality that we are not able to capture in the model. But we have to ask the right kind of questions of what is the model being used for. I'm not sure if I answered your question.
I think the basic question was that we already are very less emitting country, like per capita, if you consider. So if I want to change, then why should I change? Because
we are low in terms of
population is very high.
As part of our global as a part of the solution of the global climate, our responsibility. Yes, others have more of a responsibility, but that doesn't mean. So we'll have to work that out. But I think there are costs involved, and we should not underestimate those.
I'm Girish from NRSC ISRO.
simple question. Are there any gamified portals or gamification available for policymakers to play with options available for energy and come out with some kind of optimization?
There are many. The think tanks have models which people can tweak around and play around with. So there are, but the interface between modelers and policymakers, I think, needs that you can have a dialogue and build the appropriate models. I'm not sure about time, but I think the last maybe.
Yeah, I think because we have a next session, so we'll just take maybe one or two more. Yes. Use the mic first and introduce yourself and then ask.
Sure. Hi, sir. My name is Shivangi. I'm representing Invest India here. And sir, for a lot of the models as well as policy advocacy work that we see, the basis lies in data collected even for IPCC reports, etc. But fundamentally, I mean, how much variation do you actually see in the GHG emissions that are reported versus that? There are a lot of sources in which reporting may not actually be happening, right? How do we account for that within the variability of the models that we build?
So I think what happens is that, we know overall, we know the kind of sources, and the way it is done is we know if it's a fossil fuel based source and it's market, you know how much quantity, we then estimate, we calculate the composition, and then we get the CO2. There are uncertainties in variety of different, whether you look at biomass and other sources. Those uncertainties can be quantified. The fact is that we have to always take decisions under uncertainty. So we have to do with the best level of knowledge, and then there are people who are working on refining each of these. So these are large-scale models. So we can't wait for getting all the numbers right before using the models to take it.
It was not a question, it's a compliment. It's a really a good delivery of the talk. One apprehension which I carry over this, like, okay, we'll be able to do so with low carbon, but not net zero. This is what I feel like, in the next 20 years or maybe midterm, like 2050, we'll be able to do low carbon, but not net zero because of the complexities which are there and the optimization of the technologies and things. Probably that's something because India as such has been the developing nation, and we have been trying to still optimize many technologies, and now diversifying it again from it into something different. It's a little tough task, and we have been interacting with almost all sector from TIFAC. We interacted with the steel sector, with the thermal power sector, cement sector, and we feel that yes, what the apprehension still holds valid.
That's why we've taken 2017.
Yeah.
Yes.
We need to understand that as we make these pathways, there will be changes, and that has impacts on the economy. And this is what we need to identify. There are multiple ways.
Correct.
So I think that, we'll take your question as the last one. Yes.
I am Anjana Das. I am with IRADE. Someone asked if there was any modeling platform for policymakers. I think that calculator ISS, which was built in Niti Aayog, that was for policymaker, I think. I heard so. Okay. My question is regarding the hydrogen. We see every day 3 or 4 news regarding hydrogen in ET energy world. But everything, hydrogen production, hydrogen export hub, and then electrolyzer. So what is your opinion on that? Because hydrogen production, 1 kg needs about 35% of green electricity will be lost to produce 1 kg of hydrogen. Then for electrolyzer, when we see the materials, I saw other day IEA came out with all these new materials which will be needed. And China has done material shopping long time ago, and India does not have any share of any of these materials to produce electrolyzer or other solar PV manufacturing also India is trying. So what is your opinion? Because I don't think any system analysis also has been done to look into the potential, export potential, domestic consumption of hydrogen and so on. So that is my question.
There are some studies. I mean, there are a few studies even in the Indian context. But I think in the initial phase is we have very little of green hydrogen today. We have now a few electrolyzers. So the first 5-10 years, we must get enough experience to be able to have an assessment of the technology and costs and then move forward. So to say that hydrogen, but it is clearly one of the possible options. And government has taken a stance that we will be exploring this, and also I think some of the large industries have also said that they will be making. We have to wait and see. You know what happens there are uncertainties, and people often try to project that they know finally what will be the. And I think hydrogen can be one of the players in that solution, but the role of hydrogen vis-a-vis electric vehicles, batteries, and storage will depend on how the technology plays out. But I think in my opinion, first 5 years, we must make enough. We must make a significant we make some investments, see actually and assess for ourselves in an unbiased fashion and see where it can go, and then I think I should stop with take a minute.
Yes, thank you so much. Thank you so much, Professor Banerjee. Just 1 minute more of yours. I'll request as a token of appreciation, we'd like to just hand over a small window. And I'm requesting Professor Pradeep Srivastav to do the needful, please. So we end this plenary talk right now, and then we now move on to the next 3 parallel sessions which are going to happen. One is on the energy and just energy for sustainable energy, sustainable in Asia, which will happen in this auditorium. Then there will be a transforming to the net zero emissions energy system opportunities and challenges. That's what happened in Mirza Ghalib. And human dimensions of transition to sustainability would be in Tagore. So maybe you can move on to your next sessions and you can split. So I'll.
Good afternoon, everyone. It's time for us to start our next session, session 9. And the topic of the session is Clean and Just Energy for Sustainable Asia. This session will have a potential. Sorry for that. The session will have a discussion on aspects related to energy, justice, and livelihoods, the opportunities and challenges towards net zero emissions, human dimensions to sustainability, and clean energy access in Asia. Now, to move ahead, now it's time for me to invite our keynote speaker, who will formally start the conference. Professor Ambuj Sagar, founding head of the School of Public Policy at IIT Delhi. His recent work has focused on innovation policy for meeting sustainability and inclusivity challenges, energy innovation policy and strategies, climate change policy and politics, capacity development, and higher education policy. I would request Professor Ambuj Sagar to please come to the stage and advance the session.
Thank you and good afternoon. Can you hear me? Is the mic working? Yeah? Okay, good. Thank you all for being in this session and thank you for actually to TIFAC and IASA for putting together this conference. Obviously on a very important set of topics, and I'm hoping that our session is also going to be able to do justice to the complexity of the issues that underlie the kind of themes that we're going to be talking about. And we have a whole lineup of speakers in this session. We're running behind time, so I'm going to keep my comments fairly brief to kind of set the stage in some ways, but also talk a little bit about a topic that's near and dear to my heart, which is innovation. And so what I was asked to speak on is thinking about innovation for clean energy. And I think it's in that vein that I'm going to try to. All right. So as I said, I'm going to keep things short, but fundamentally, I think one of the points I want to make is that innovation is absolutely key for addressing climate and sustainable developmental challenges, right? In many ways, my comments will very much build on Professor Rangan Banerjee's comments. I think he's already kind of in a sense, laid the foundation for my talk. So I think I'm glad that I don't have to repeat many of the things that he said. But the key point that I think we should understand is that one of the central elements of this energy transition that he was talking about is a requirement to accelerate the development and deployment of clean energy technologies, right? And for countries such as India, but other countries in Asia and other developing countries, this is a complicated story because we have to engage with both climate and sustainability developmental challenges. But the reality is that what drives innovation more often than not is strong markets. In the case of climate technologies or clean energy technologies, the markets are not that strong. And very often in most countries, including India, we don't have very clear set of policies to drive these kind of clean energy innovation. The other side, of course, you can drive innovation by investing in R&D. But again, developing countries, India included, are not, by global standards, don't invest as much in innovation on the upstream part of innovation R&D as many of the bigger players. So for us, it's kind of a tricky question, but we do require the implementation of these technologies at scale because that's when you get the societal benefits that you want. So at least from my perspective, when you think about all of this and you're talking about thinking about innovation, strategy and prioritization become absolutely key. And that, of course, is a very big conversation, but I'm going to, in the next few minutes, at least kind of point us in directions that I think are meaningful for India and other developing countries to think about, but also to take a kind of a little bit of a global perspective. Sorry. I'm just going to give you, actually some of this data has already been presented by Rangan, but I want to kind of just take us again. The fact is in recent years, we've had a kind of a remarkable transformation in the deployment of clean energy technologies, which is a result of actually decades of work in this area. But of course, the most impressive transformation has been in the renewable energy space. This is data from IRENA that actually tells you in the last 10 odd years what an incredible transition that's happened. By the way, the bottommost dark blue bar is renewable hydropower. So we've always had hydropower as a kind of a major part of a renewable capacity. But in the last decade or so, we've seen a remarkable increase in wind and solar photovoltaic across the world. And this is something that has played out not just in one part of the world or other parts, it's actually across the globe, especially Asia, that really has taken the lead in this space, India and China, very much kind of leading the pack here. But of course, as you can see, every region in the world is actually undergoing this renewable energy transformation. Again, as I said, underpinned by decades of R&D and other kinds of exploration of these renewable energy technologies. I'm not going to go into detail on how that happened, but the reality is another dimension of progress, of course, again, Professor Banerjee had highlighted this, is a remarkable drop in the energy prices. And this is the LCOE numbers for renewables in a number of different countries. And you say India has actually done quite well at reducing costs remarkably. We have some of the best, the cheapest kind of projects underway in solar PV. Sorry, this data is for solar PV. This is the data on patents. In some senses, I talked about what's actually playing out on the ground. Patents are, in a sense, the shape of things for the future. And again, you see that in the last 10 odd years, there's been a remarkable increase in the number of patents relating to renewable energy, in effect telling us that there's enough investment going on. Well, I shouldn't say enough. There is substantial investment going on in R&D, which is leading to patents and hopefully leading to a pipeline of technologies for the future. We know that when we think about net zero 2050 as a global target, that a substantial fraction of the technologies, about half of the technologies that will be required to meet the net zero transition, are technologies that are still in the pipeline. So this is, in a sense, a kind of an illustration of that we have been investing to lead to some pipeline of innovation technology. So in other words, there's a substantial amount of action that's already going on. Mission innovation, a massive program of collaboration and coordination among now 22 major countries and the EU across the world. EU and 22 countries across the world that are basically collaborating their efforts on innovation. Mission Innovation was launched at COP21 in 2015, and you can see on the screen, there's been a remarkable enhancement of innovation as a result of this coordination. Still a lot to do. They've now just launched Mission Innovation Phase 2.0, which is thinking about how do you build on this kind of progress. But again, just to highlight that there's a fair amount of action going on in thinking about international coordination and collaboration on innovation. And I want to kind of just talk a little bit about India, and again put up a kind of a classic slide, which is from the Ujala dashboard on the number of LEDs that have been deployed in India, which really is one of the classic success stories across the world in terms of being able to take a low carbon technology and deploy it at scale to lead to all the gains that you can see on the board. So given all this, how do we think about the future? There's still a long way to go. Some of the slides that Professor Banerjee showed tell you that where we are in the transition and what a kind of a steep shifts you have to make in our own trajectories. The same is true across the board. So we have a long way to go to a 2050 net zero target. On that road, we have a number of dimensions of the domestic and global energy challenge. Different people will come up with different lists. In my list, I want to talk about three particular things. One is expansion of energy services. And I think in the previous session, the question and answer actually highlighted the fact that we are going to be expanding our energy requirements, not just India, but pretty much all developing countries, because energy is intimately related to human development. And we've so far not been able to decouple energy fully from human development. We can use energy more effectively to drive human and social development, but we are going to need more energy in order to address our development imperatives. One also has to think about questions relating to accessibility and affordability, which is making sure that energy is available for people who don't have access to modern energy today, right? And that means making it cheap and affordable. And the last one, of course, is the climate challenge. So effectively, as we're looking forward, innovation has to address multiple kinds of challenges, right? What do we do about that? I'm going to just in a few minutes tell you what my views are on what needs to be done. Given the complexity of this transition, I talked about the fact that we are talking about massive shift. Professor Banerjee illustrated how it's going to be happening across pretty much every part of our energy economy and therefore our economy. Managing this transition is incredibly complicated, not just for India, but actually for all countries. And that requires a capacity to manage this transition. And I've highlighted, again, 4 dimensions of capacity that I think are absolutely key, which any country has to put in place in order to be able to manage this transition where technology is the heart of it to yield the results that we want. First one is just framing the problem. What are our objectives and strategies? India is making a massive push on solar PV, for example. Is this primarily a decarbonization strategy? Is it primarily an energy access strategy? Is it energy access, energy security, or is it industrial policy? Or is it some combination of the above? I think these are the kind of questions that countries are grappling with, right? What are even the broad objectives as you think about decarbonization in relationship to societal challenges? Once you've got that, you've got to think about, okay, how do we then manage the innovation process in order to develop the right kind of technological opportunities and understand what implementation pathways we'll take? We're seeing this playing out in every sector across the world. What is the implementation pathways to decarbonizing transport? Is it electric vehicles? Is it electric vehicles in combination of mass transport? Is it hydrogen? How do you think about the balance between all of that? And then, of course, once you even understand what pathway you want to follow, how do you implement it? That's a completely different set of capacities. And last, and probably I think the most important, is the capacity to learn from experience. How do we assess critically what we've been doing so that we can actually do better as we move forward, right? To me, these are 4 critical dimensions of capacity that countries really have to put in place. And the reality is most developing countries do not focus on building capacity. We are so feeling so much pressure to engage in the transition that we're moving forward, and rightly so, but it's not an either or. As we move forward on the transition, we also have to think about how to build the capacity that allows you to manage the transition well. So this is in some sense the kind of putting in place the intellectual infrastructure and the institutional infrastructure to guide the transition. But the question is, what are the things that we want to be thinking about that may get forgotten otherwise? I would make the case that a lot of the work that's going on across the board on energy innovation is being driven by decarbonization, and we have forgotten about an enormous swath of humanity that does not have access to clean and modern energy. Specific 2 examples are folks who don't have access to electricity. The first slide should have actually said 770 million people don't have access to electric power in a systematic way. And about 2.5 billion people do not have access to clean cooking energy. Incredibly, these numbers have stayed quite stable in the past couple of decades. The first one, the numbers have come down somewhat, but these numbers are astounding, and so is the fact that the numbers have not changed a lot, right? It's an incredible developmental challenge. Because if you don't have access to electricity and you don't have access to clean cooking energy, it impedes human development and livelihood opportunities in a massive way. So I would actually posit, in addition to all the other work that's going on on innovation, this has to become an important part of the clean energy innovation agenda, not just in India, but across the world. Enhancing this access to modern and clean energy will have enormous benefits across the world. And as I said, innovation can play an important part, and the clean energy revolution that's underway, renewables, energy storage, much of that can even be leveraged in this space. Again, a lot of thinking has not happened in this space. I should, by the way, mention that progress on these and other fronts, a gazillion other things that I've not talked about, requires both domestic and domestic efforts as well as international coordination. And On some parts of this, I actually have a comment coming out very soon in Nature Energy that talks about what do some of these things mean for mission innovation in phase 2.0, because I think the international community has an enormous role to play. But of course, so do we in countries like India and other developing countries. I'll stop with that. And I think we'll move on to maybe the other speakers. I know we are way behind time. So what I'm going to try to do is just run through the session with the various speakers, and then we'll leave some time for overall Q&A at the end so that we make sure the speakers at the end don't get shortchanged. So I'm going to stop with that, and we're going to then maybe move on to the speakers, and I'm going to take my place on the dais. It's kind of strange being here by myself, but anyway, the first speaker of the session is Shonali Pachori, who I'm assuming is going to be joining us online from IIASA, I would be guessing. Just in terms of some instructions to the speakers, if you've not got instructions yet, at least let me reiterate, because we're running behind of time and we have 7 speakers in the session. I'm going to try to limit you, sadly, to 7 minutes a person. I know it's going to feel like you're really rushing through it, but something of that order, I think, will allow us to at least make sure that every speaker's had their say, and maybe hopefully even leave a bit of time for Q&A. So I will give a signal to every speaker once they're approaching the 7-minute mark. With that, thank you.
Yes, sir. That would help you.
And Shonali, welcome, and over to you.
Thank you so much, Ambush. Sorry, I'm just going to try and turn this off. Yeah, so I hope you can hear me, and I will try to. Okay, I still seem to have an echo. 1 second. Yeah, I hope you can hear me clearly. I will try to share my screen, and hopefully that works. Yeah, thank you so much, Amber, for introducing me, and for also letting me know what the timing is. I'll get right into it. And you've already mentioned in your speech, Ambuj, about how important energy access is, and in fact, how critical innovation is also in the energy access space. And I completely agree with you on that. I think it's often forgotten, but it's very much needs to be very much part of the transformation that we're talking about. So in fact, when we're talking about expanding access to modern energy services, of course, this is not an end in itself. I mean, the reason why we want to do this is because we want to alleviate multidimensional poverty. We want to enhance livelihood opportunities for people and improve welfare, right? So basically, when we are talking about this, we are basically looking at as a scenario where we've seen globally that the share of agriculture in total employment and output has declined over time in most countries. And this is really from the fact that there's been agricultural intensification, there's been access to modern energy that has allowed for irrigated agriculture and increasing productivity, mechanization. And this has freed up people's time to really move into other activities than just producing our survival. And this is also what we see when we look at annual working hours, labor productivity over time. So, I mean, these are just graphs from our World in Data, which kind of give you the global picture of what's been happening over the last few decades. And very clearly, we see vast differences The differences are often related to levels of development and prosperity across the globe. But there's been a general trend of reductions in agricultural employment in terms of the total and in working hours and improvements in labor productivity that accompany all of this. Now, one might ask, what's been the role of modern energy access in the contribution of this rising productivity and better? And actually, when we look at this question and look at the evidence, it's very mixed. So if we look at the evidence in literature, we see that, of course, everyone recognizes that modern energy and electricity access is necessary for improving productivity, for enhancing. But it's not sufficient on its own. And that's very clearly shown in many studies. And that really you need complementary infrastructure access, like access to markets, financial services, skills, and so on, to really make this happen. And even when you have all of that, of course, there's a lot of heterogeneity because the distribution of resources across different contexts is very different. And if we look historically, we've seen like long-term studies where we've seen actually initially when you provide energy services in rural areas, you actually have shifts towards more agriculture because people start doing agriculture in better ways. And then over the longer term, you're seeing the shift to other sectors. And also critical in this whole process is not just the connections alone, but the quality of energy access. So basically reliability of energy services and so on are really, really important to see some important impacts in terms of livelihoods and productivity. So, while this session has a focus somewhat on Asia, I'm going to take more of a global picture on what we are seeing globally. And Sub-Saharan Africa is one of the regions where we still see that the vast majority of cropland is rain-fed, and there's very low yields in some of these areas. And of course, smallholder farmers are accounting for over 80% of the production. And these farmers have very low access to any services and infrastructure. In fact, 2/3 don't have access to electricity. So there's a huge potential in Sub-Saharan Africa to really improve productivity yields, to provide irrigation. And we've just done recent research that we've submitted where we've kind of looked very specifically at the techno-economic potential and resource availability for decentralized solar irrigation in Sub-Saharan Africa. And in fact, we see that over 2/3 of these smallholder farmers could benefit from solar irrigation. And this will improve yields and productivity and income for these farmers tremendously and also contribute to food security. We've done more micro work that's looked at how over time in different countries, specifically Nigeria and Ethiopia, non-farm entrepreneurs and non-farm employment has changed. And actually what we see is over a period of like 10 years, 2 to 4 years after electrification, we don't really see much change in non-farm employment or non-farm entrepreneurship. What we do see in some instances is an increase in farm employment, particularly in Nigeria. So again, this kind of follows what we've seen in other countries historically, like in the US, where basically with access to energy, initially it's the farm mechanization that occurs, irrigation and so on. And then over a period of time, with the right other inputs, you can have other benefits to non-farm sectors. In Sub-Saharan Africa, we are also seeing that in addition to access to electricity, of course, access to other modern energy services regarding cooking in particular is very important, because in the informal food sector in particular, we see this is dominated by women, but women, who are very poor. And energy is, of course, a critical input to the informal food sector, but often, people can't afford access to better energy services in this sector because of affordability constraints, and also the lack of policy focus in the sector, because often these informal food vendors don't even have a legal basis for their business. So this is again, a very complicated issue which has often been neglected. And this is the case even in India, where we have a lot of informal food vendors, though it's not so women dominated, but they face similar issues. So, there's been research that's been done recently that's been looking at how can we, synergize in terms of meeting multiple goals like women's empowerment and modern energy access and improvements in livelihoods. And again, this work really highlights how one needs, a whole ecosystem of development to happen simultaneously in order for the big impacts to be benefit people. So we really need access to finance, business mentorship and networks, skill development, and also, combining efforts to be more inclusive of men and women in these kind of programs and projects.
Sorry, ma'am. Sorry to interrupt.
I know.
Can you please wrap up and conclude?
Running out of time, so I'm going to kind of speed up a little bit and just end with a recent report that's just come out by Irina and Selco, where again they've kind of advocated for a livelihood-centric approach to modern energy access expansion, including decentralized
can you hear us?
Deployment. And this is really, again, kind of speaking to the same point, which is that we need to be having many things happening simultaneously in order to provide the benefits of livelihood improvements for people through modern energy access expansion. So we really need technology innovation. We need training and capacity building. We need policy that supports all of this, and of course, financing for all of for people who don't really have access to finance.
Hello.
So with that, I'm just going to try and wrap up and say a few words on what I think are the key messages that I'm trying to convey here. One is that even for the financial viability of modern energy supply, we really need productive loads, because if you're focusing only on household connections, this is rather low loads for consumptive uses, which then, don't really often contribute to the viability of the energy suppliers. And what's important is that, we know that modern energy access is critical for productivity increases and development, but this alone.
Hello, ma'am. Can you hear our voice?
Enhancements. We really need complementary infrastructure and services. So really, there is a big need for cross-sector integrative policies that kind of link modern energy access with the wider development efforts and tackle barriers that are there for livelihood enhancement and enterprise development. So this really, as I said, requires an ecosystem of services to be developed: technological innovation, finance, equipment, access to equipment, markets, and technologies as a package. So I'll end with that, and thank you very much for your attention.
Thank you very much, Shanali. That was a really very, very interesting perspective on the energy access question. So thank you very much for that. As I said, we are actually running on a very tight ship, so we're just going to right away move on to the next speaker, and then hopefully we'll head up at the end for some Q&A between the audience and the speakers. The next speaker is Dr. Ganesh Hegde from Princeton, who's going to be talking about India's energy transition and assessing resource and infrastructure implications.
So Dr. Ganesh Hegde is joining virtual as well.
Is he joining?
He's joining virtually as well.
Okay.
You can hear me?
Yes, we can. You're very loud and clear. Good.
Thank you. So I'm going to try and probably answer, or we are at least trying and to answer some of the questions which were flagged in the keynote by Professor Banerjee, as well as in his talk by Professor Ambuj Sagar. What are the implications on India's recent policy announcement, which is getting to net zero by 2070, or getting to very high share of renewable energy by 2030, I don't need to probably explain to this audience that the challenge is quite ambitious, and achieving economy-wide net zero emissions by 2070 needs a lot more analysis, a lot more scenario-based analysis to understand which of the pathways would be uh, easier, which of the pathways would lead to a lot of financial requirement and things like that. So if you look at the transition, so this is probably the second time India is trying one of the most ambitious challenges or the effort. In the last decade, there was the National Solar Mission where 175 gigawatt of renewable energy and with solar being 100 gigawatt and wind was something like 40 gigawatt was tried. If you look at the capacity addition in the last decade or so, the share of renewable energy in the annual capacity addition has been sort of constantly improving. But if you look at the wind and solar in specific, we see that there's a huge increase in wind and solar energy addition every year, and wind seem to be sort of hitting the parity in the last 5 years or so. But the challenge is much bigger if you look at, and it requires something like 2 to 3 times of installation in the coming decade. And it has significant resource and infrastructure implications. Resource in terms of where are these lands for renewable land and wind installation, and do we have enough transmission and distribution infrastructure for evacuating all this power? And it is something of the order of 3 times the present renewable energy, and at least more than more than doubling the existing all installation. So some of the concerns we see here, which was also discussed in the keynote and the earlier presentations, is there seem to be no coherent national roadmap yet, but I think a lot of researchers and some think tanks are also trying on that. And the subnational level planning, which is quite important in India, is also seem to be missing. And we are trying to sort of answer these 2 questions in this study. And this is an ongoing study. I probably won't be able to share some of the results, but I can give a brief overview of what we are sort of trying to achieve. So we are trying to understand to assess resource and infrastructure implications of this transition in the coming decade, and what are the implications on let us say the land availability, and where are these plants are going to come up, and how that is sort of going to transform subnational level energy share and subnational level land use and land use pattern, and what are the feasible ways. If we let us say if we cannot achieve by 2030, can we achieve by 2035? And if we do so, what are the implications on our grid system, and what are the costs involved in that? And beyond 2030, we have a net zero target, and how this policy of achieving 35% net zero carbon or reduction in carbon intensity is going to sort of pump into the net zero targets by 2070. So very briefly about the methodology. So there are sort of 2 parts. One, we are going to, or we are in the process of understanding what are the least cost options for the upcoming capacity or the capacity expansion model. And we are also trying to unpack some of these scenarios in terms of their socio-political implications, socio-economic implications, such as the job in the states or the transition of jobs, and also the share of state level GDP, because some of the states have very high reliance on their on coal for their revenue and things like that, etc. So this has sort of two sort of analysis. One is the cost optimization, which is probably most of you know already, where we try to estimate the least cost or optimized energy option based on their capital cost and expansion requirement and the operating cost. And then we sort of unpack this spatially. We understand where are these locations, and depending on their suitability, we also look at their zoning and things like that. There are a number of filter maps. I've just given a few examples here. For example, population density is one, and the existing plants which have already taken probably taken the most suitable land and suitable sites for this kind of activity, and the land use as a whole, which is very important, and there are competing players in India for that. And then we have a resource map such as solar density, power density map, and wind speed map, and etc. So at the end of this study, we are expecting to have some kind of zonal analysis of candidate areas, and then what are their implications on, let us say, existing land use pattern and existing infrastructure. And if you have to build new infrastructure or new transmission lines, where are and what sort of capacity addition we would need, and the whole other application, whole other implication on socioeconomic aspects as well. Just to give you a very broad idea here, this is what sort of all the land which are available for solar and wind plants look like. And as expected, we have quite a large area which is available in the western desert zone, mostly in Rajasthan and some part in probably Gujarat. And also there are some patches of lands which are available in the central part of India. But if, as you see, the Ganges belt, which is high population density area, and also the hilly terrains of Northeast India is probably not much suitable. And then, so we sort of unpack it. Yeah, I'll take maybe a minute or so to conclude. Unpack it at 4x4 kilometer grid, and so that will give at very micro level what is a cost optimized capacity expansion which would need for 2030 target, and the grid level sort of suitability in each state and even the subnational level. And we'll also try some kind of a zoning where in some places it is so possible that solar and wind compensate and complement each other, then those could be, renewable energy zones in the future. As I explained, we are also sort of trying to understand what are the employment opportunities and what kind of capital investment which is required to this. As a way forward, we are also looking at Net Zero India analysis, which is based on Net Zero America report, and we're adopting the similar methodology for India, but India has a very different and unique challenges of itself. So the final sort of attempt here is to construct multiple decarbonization pathways and scenarios, and unpack these scenarios in terms of their implications on infrastructure, resources, and socioeconomic aspects. And most importantly, downscale this analysis at the state and sub-state level wherever possible, and give sort of a spatial analysis of these scenarios as well. So that will give a lot of insights to policymakers and planners. Thank you. I'll just conclude here. And if you have any questions and comments, feel free to reach me on this email. And thank you for your attention. And thanks for this opportunity to present some of our work.
Thank you very much, Ganesh. As I'd mentioned earlier also, please do stay online. And if you have time at the end of the session, we will certainly try to do some Q&A with the audience. Next is Thanks, Ganesh. Next is Dr. Shashikant Sharma from ISRO. It's going to be pressingly talking about satellite data-based assessment of renewable energy. I think Dr. Sharma is also online. Dr. Sharma, as we've been telling the other speakers also, because we're running on a very tight schedule, approximately 7 minutes per speaker. Sorry, I know it's very tight, but we're just doing the best we can. Thank you.
Thank you. So I'll be talking about satellite-based satellite database assessment of renewable energy. As we know that we have a very high target of 500 gigawatt by renewable energy by 2030, and we have a lot of solar potential, but there is a lacuna that no high-density network of parameters and the spatial temporal data is available. So because of this, satellite technology is best suited for this. And that's why, we are doing all this solar potential using satellite data. So here the role of geostationary satellite is very important. And on daily basis, like every half an hour, we get satellite data from INSAT 3D and 3DR. Together, we get data in 15 minutes. It is a continuous monitoring and where you can find out clouds, fog, water vapor, dust, aerosol, and everything. So this type of data can be integrated on weekly, daily, and seasonal. And then we have come out with the solar potential map of the country. So this type of temporal variation we can see every half an hour. So these are the data at 6 o'clock, 9 o'clock, and so on. So we can get this data in visible, thermal, water vapor channels. So you can see how these visible water and thermal channels are seen in the satellite data. And using that, we are able to find out the solar potential. So this is the solar potential map of the country. So on the right-hand side, what you see, every half an hour solar insolation is aggregated to week and then month and year. So this is the annual insolation average for last 10 years. So this single image is made up of about 1 lakh images obtained at every half an hour for the last 10 years. And also we have developed a solar calculator app, so that with given a lat long, you can get what is the monthly solar insolation, what is the average in last 10 years, what is the solar zenith angle, azimuth angle, and also in case if there is a mountain, then using DEM, we are finding how much obstruction is there. And also we are giving prediction for the next 72 hours at every 15 minutes interval. So all this information is available on our portal with us, and it is on Android app is also available for it. Also, we have developed a global solar calculator wherein you can know all these things using globally, but we have used a solar GIS data, which is freely available. So once again, at any given point in the country, one can find out the monthly solar energy as well as the related information, and you can download this all into a PDF file wherein you can get the complete report. Also, we have developed a 3D city model using satellite data. So here using AI techniques, we have found out the building footprints using high resolution Carto3 data, which is less than 1 meter. And then we using Carto1 data, which is stereo data, we have developed a 3D model. And for each building, like we can find out how much time solar energy will be available. So because of the shadow of adjacent buildings, which rooftops are what they call potential for putting solar PV. So this type of building level information we can get using this 3D model. And this right now we have done for Ahmedabad as well as for Gandhinagar cities. Oh, could you share it again? Can you see a share is like share?
We're not able to see your slides.
Sorry, we lost your slides.
Yeah.
Sorry. This was okay. Global solar calculation over. So this is 3D city model. So using this model, we can find out the solar potential of each roof. So for each roof on these 3 days, 21st March and 21st September and December, that is equinox, how much solar energy will be available on daily basis. So this type of things can be done using 3D model. Also, we have estimated GHI over India and solar potential in smart cities. So these are the 100 smart cities we have taken, and we have found out what is the potential in this 100 smart cities. So we have taken the total area which we have got from satellite. so about 6360 square kilometer. And we assume that 25% is useful for rooftop. And out of that, 25 is useful for putting PV plant. And then finding the GHI at that point, we have come out with the final, what you call, number that 31 gigawatt can be available using PV rooftop in 98 smart cities. Also, we have developed a solar site selection tool to identify the most potential solar energy site. So here we can use 5 things: distance from the power line, distance from the road, maximum slope, minimum solar insolation, and type of land use. These 5 things can be combined and you can get online answer to it. So all these 5 layers can be combined using multi-criteria analysis, and this online information is available on our Vedas portal. So we can find out the most potential site for solar sites. Also, now to achieve such target, we need to put these things in agriculture domain also. So here we have a very good agriculture information system wherein you can find out the complete information of crop growth and crop monitoring at field level for the whole country. Every 10 days you can monitor the field. Also you can do image processing analysis and find out what is the agriculture potential of that field, how much cropping intensity is there, for how much time the crop is there in the field. So all these things you can know for each and every agriculture field of this country. So that type of information is available, so we can expand it. Then apart from solar, we have wind potential also. So we are using OceanSat data and SCATSat data, satellite, and we are using scatterometer. Also, we are using altimeter available from our Saralatika mission, and also we are using SAR data from RISAT. So this type of 25-kilometer wind vectors are available for the many times, and we have averaged it out, and we have found out the solar potential. Also, on land, such sensors are not available, so we are using WRF models, and these models are available, and we can find out the wind power from these models. And 5 kilometer, they are available at 15 minutes interval. So this type of wind potential using satellite data as well as from the models are available for the country. And using this, we have classified the wind energy, the hotspot region. So this region in the Gujarat coast, and this is the best area near Kanyakumari, Rameshwaram, and some part in the eastern part of Odisha also. These are some of the good areas which are potential for wind energy. Also, now in the coming time, wave energy is also a good candidate for renewable energy. So wave power from Saralatika that we have calculated, and also we have models which are available for using these models at 2.5 kilometer. So wave height, wave power, and this thing are available. This is on the monthly basis. So this type of things can be used. Also ocean thermal energy, if the difference between the temperature is more than 20 degree, then we can use this technology to tap energy. So this type of thermal, what you call anomalies, can be found out, and this also things are available for in this Bay of Bengal is good for this as compared to Arabian Sea. We have developed a geospatial energy map of India, wherein the data from 5 ministries are available at one platform, so that it is very good for installing new power plants and to know the potential in all these 5 different fields of energy: natural gas, nuclear, hydro, coal, refineries, and everything. So this also is available on Vedas portal. So this is all about the solar potential and renewable energy potential from satellite data. Thank you very much.
Thank you very much, Dr. Sharma. That was indeed a very, very interesting presentation. We go on next to Dr. Prabal Ghosh from IRADE. You're here, so great.
Yes, sir.
The topic of my presentation is key policies to promote and support EVs in Delhi and impact of EV charging on Delhi's grid in 2030. The objective of the study was to understand the factors that impact the consumer's decision to purchase EV, and based on that, outline policies that will help in increasing the adoption of EV in Delhi, and also to estimate the impact of EV charging of electricity demand on the grid in Delhi, and thereby develop a tool to help DISCOMs to calculate the impact of EV charging in Delhi. So for this, what we did was that the methodology that we adopted was we organized and implemented primary surveys covering 500 respondents across Delhi. And these surveys were organized in 5 consumer segments. The first one was private users of EV two-wheeler, called the early adopters of EV two-wheeler. The second was private users of EV four-wheeler, early adopters of EV four-wheeler. Then the prospective consumers of EV, which are people who would be wanting to buy a vehicle in the next 6 months. They may be buying EV, may not be buying an EV. Those who said that they want to buy an EV, we call it EV intenders, and those who aren't are conventional intenders. The fourth segment was institutional owners of electric vehicles, and the fifth is the e-rickshaws. And the survey questionnaires was designed to assess them for the respondents for the socioeconomic profile, travel patterns, their access to parking and charging facilities, and the preference for them, their charging behavior, a lot of parameters associated with charging. And of course, the questionnaire was open-ended for suggestions and preferences from the respondents. This survey was conducted between August to September 2020 with the reference period of February 2020, which is the pre-COVID period. So we start with the presentation on consumer profile of private EV users in Delhi. So what we found out is that the table below is the average household expenditure of early adopters EV two-wheeler and four-wheeler and prospective consumers of two-wheeler and four-wheeler. What we find is that the average household expenditure is higher for four-wheeler buyers and compared to two-wheelers. And what is more important is that the average household expenditure for EV intenders is higher than the conventional intenders, which basically means that the preference for EV increases with income. And then what we also find is that in the graphs as shown, the most people use the most common purpose for which the electric vehicle was used by people across all profession showed that it was used more for regular office commute. And apart from that, the next most popular or most common purpose was short distance travel. This was similar for two-wheeler and four-wheeler. And this was also true for prospective consumers. That is what they use their vehicles for. But what was interesting is that among the prospective consumers, EV intenders were those who had more short distance travel. So therefore, EV buyers are those people with more short distance travel. And additionally, what we also found is that those early adopters of EV two-wheeler and four-wheeler, most of them were buying EV as their second or third vehicle. So they all mostly had a previously owned conventional vehicle. So this was an important finding, which I'll come to now. So in this slide here, we analyze the travel usage of electric vehicles by private users in Delhi. And the table below gives the VKT using the electric vehicles of early adopters of two-wheeler and four-wheeler, as well as the VKT of currently owned conventional vehicles of prospective consumers. And what we see is that the electric vehicle two-wheelers are used more higher on weekdays and less on weekends, whereas it is reverse for the four-wheeler. But what is also very important is that for early adopters of EV two-wheeler, if you look at the first two graphs above, two graphs, so what we find is that for the early adopters EV two-wheeler, they said 55% of early adopters of EV two-wheeler who also have a conventional two-wheeler said that they have used their they use their conventional vehicle to travel 0 distances. Similarly, on working days, and this is 82% on non-working days. So 82% of the early adopters of EV who have a conventional vehicle
I don't know if you can hear us, but we can't hear anything. Hello? We can't hear anything. I don't know if you're speaking, and I don't know if something is going on.
Pooja, can you hear now?
Yes.
Now we are audible, yes.
Yes.
Okay, please proceed. And as I've been telling the other speakers, I'm in the unfortunate position of having to tell people they have very limited time, about 7 minutes for their remarks. I'm really sorry, but we started late. We have many speakers, and we have a tight deadline. We're already out of time, so we're running kind of pushing against time. So I'm very, very sorry, but maybe if you can compress your remarks into 7 minutes, I'll greatly appreciate that. Thank you. Over to you. You're muted, I think.
You're muted.
Can you see my screen?
Yes, we can see you.
We can see you, but not your screen.
Yes.
I am sharing it, but it's not working.
Come up.
Is there someone who can go before me? I don't know. I'm not able. I have to share permissions and stuff. I think it's going to take some time.
Would you like some other speaker to go first? Is that what you're saying?
Yeah, I think
No problem. Shivangi, would you be able to go first? While Pooja sorts things out on her end? Yeah, why don't you please? All right, Pooja, so we're going to have somebody else go first. And maybe about 7-8 minutes from now, we'll bring you on. Thank you. Thank you, Shivangi.
Yeah, please go. Use the phone. For your slide. Okay. Sorry. Yes. I just have my notes here. Oh, you have your notes here. Yeah. Okay. No worries. And you can just stand here and use the pointer notation. Yeah, sure. Just see how this is working.
It's a PDF.
Sure, perfect. I'm just going to start right ahead. Thank you, everyone. It's a pleasure to be, addressing the gathering here. My name is Shivangi Tiwari, and I'm a senior investment specialist at Invest India. I have about 5+ years of work experience in strategy consulting, government institutions, as well as process engineering and design. I would, just in lieu of addressing the time, I'd just like to go ahead. Today, I'm actually here to talk about how climate change strategies, particularly energy transition strategies, are being redeveloped in Asia. The challenges are being witnessed by the Asian subcontinent, and I'm going to share a couple of case studies of a few countries in this energy transitions journey and how this journey has been evolving. Finally, I'd like to highlight and use this platform as a call to action for sharing the need to strengthen our social, economical, technological, as well as government ties to be able to successfully achieve our net zero targets. Now, going ahead. Taking a step back, let me just start by providing a context on these transitions that are being targeted by the developing and developed economies of Asia versus the globe. A brief analysis of the net zero energy commitments made highlights that 57% of Asian countries have either made energy net zero commitments or are proposing to do so in the near future. As it can be noticed, across all the 5 regions of Asia, West, East, Center, South, and Southeast Asia, we have a pretty equitable share of countries getting onto this wagon. Moving on, if we have an in-depth look at the timelines as to when, the countries are looking at achieving these energy transition targets, it can be noticed that although Asia is still mildly lagging behind the global peers of, about 75% of Asian countries are looking at targeting 2050 net energy commitments, while globally about 85 to 90% of the nations are looking at getting their global energy transitions by 2050 sorted. Now, just putting in, just sharing a view as to why we are actually even talking about 2050, 2060, 2070. What do these numbers even mean? 2050 was actually defined as the year by IPCC to be able to meet the 1.5 degree target. And if we start going ahead towards 2060, 2070, we start exceeding the Paris Agreement timelines and commitments to 2 degrees Celsius scenarios. Moving forward to the unique situation of Asia, we are probably, after Africa, the most severely affected region within the whole, global system. And as you can see, within Asia, across, let's say, West Asia, East Asia, as well as South Asia, it's not just going to be an equitable distribution of 1.5 degrees. West Asia can actually see up to 2.5x times the temperature rise of 4 degrees Celsius, which actually recently also saw, in terms of monetary value, a loss of 13 billion USD in infrastructure plannings and development. And therefore, as you can actually have a notice, these climate change implications have a very severe correlation with our sustainable development goals, with the social and economic divides within the society. And as actually was hired, this affects the lower strata of the economy the most to be driving people towards the poverty segment. A brief view by IPCC actually, highlights the regions across Asia and what kind of impacts that they might be foreseeing because of this climate change. And we can see from the West, which might be most affected with dust storms, sandstorms, there is heat waves, extreme rainfall, floods, biodiversity challenges, etc., that can be foreseen. And each of these goals, if you have a look at it with regards to the sustainability development targets, we actually notice that in Asian subcontinent, we are going to be seeing at least a medium to a severe extent of, hurtful impact to our economies. Just in lieu, because I want to actually address the diversity factor within the subcontinent, you can see that across Asia, we actually have various topographies, demographics of mountains, lands, seas, oceans, etc. Today, I actually want to portray a small case study of a few countries and what they are doing to address their energy transitions journey, for which we have countries like UAE, India, Japan, each of them varying very drastically and having made net zero commitments from 2050 to 2070 respectively. As you can see, each of these nations, even though similar in the similar subcontinent, are in a very unique situation of their own right now. UAE, for example, comes with the factor that, yes, they are one of the largest benefiters from fossil fuels. And yes, they face the large resistance that a lot of their economy is actually employed in the fossil fuel sector, and therefore for them to be transitioning to renewable energy scenario can be challenging on multifold aspects. But let's see, why is UAE even then interested in getting a net zero energy target, created? And you will uniquely notice that UAE was one of the first countries that launched a net zero climate change action plan 2017 to 2050. They are so drastically impacted due to the temperature variations in the state, where they've already started seeing 4 degrees temperature rise, and going forward, they're foreseeing about 10% increase in humidity. In fact, as a fun statistic, if we were to allow the conventional fuels to be able to account for the energy increase that's going to be in the region, someone would be able to take a car from Earth to Moon 18,000 times. And that's the amount of carbon dioxide that you will be generating over and above what you're already generating in the economy. Sure. Okay. Sorry, I'll go ahead quickly. Therefore, when UAE, as was raised by my previous folks here, The way UAE has prioritized its energy transitions journey has mainly been through manage, build, and advance, where their key focus has been on understanding the statistics, therefore building digital tools to be able to monitor statistics on GHG emissions, as well as economic diversification and promotion of private sector to be able to empower them to get to that stage. I'm going to quickly jump through a few other sections and move to India as a nation and how we can see India differs. Now, with India, the unique thing is, yes, we want to target a 2050, but it cannot be a step change for us. We are still far behind a lot of global nations, and therefore the key important fact that we notice is that we are looking at a much more diverse strategy for moving towards our net zero energy transition. In fact, we are looking at a 7-pillar approach where we are asking them to allow gas-based economy, cleaner use of fuels with stuff like carbon capture, 500 gigawatts of renewable energy target by 2030, promotion of biofuels, as well as digital innovations. India is actually one of the first few countries to be launching a carbon capture policy already. And we see this going forward. Another key pillar that India is really strengthening towards alongside startups is looking at G2G collaborations as well as alliances. We are also amongst the pioneers in Indian Solar Alliance, Coalition for Disaster Resilient Infrastructure, as well as we've signed strategic energy partnerships with countries like USA, Denmark, Italy, Japan, Russia, etc., in order to be ensuring our climate targets as well as energy targets of security, sustainability, equity, as well as distribution. And I mean, there are just a few points that are here to show what all we have done for promoting renewables within the nation, how we are looking at decarbonizing conventional fuels, and what all we are doing for promoting biofuels in the nation. And especially considering we have already risen to 5th largest bioethanol producer globally. Overall, I would actually like to just summarize, and even then you can see that for both the countries, independent think tank analysis have actually shown that after so much effort, even the so much effort being put by countries like UAE, India, etc., the way we are progressing, we will still not be able to meet the 1.5 degrees mark, and we will most likely end up in a scenario which is 3 to 4 degrees Celsius higher by 2050. I'd just like to end by saying I mean, this presentation was meant to be like a call to action for everyone and for increasing awareness that, the countries need to look at promoting technology sharing, cooperation, skill development, as well as ensuring the right level of finance to allow for a just transition with key bedrocks of the sustainability development goals, as well as allowing for, leveraging on the digital technologies that we have. Thank you so much. I think that's all from my end.
Thank you. Thank you, Shivangi. Thank you. And now back to Pooja. Hopefully she's got her screen sharing working. So Pooja, can you hear me?
Hello? Yes, I can hear you.
Yeah?
Yeah.
All right, let's see if we can get this going. And as I said, I'm sorry, it really is 7 to 8 minutes, and I will.
No, it's okay. I just don't know why my screen sharing is. Okay. I think I sent the slides to Sangeeta though, so maybe I don't know if she has them. It's just not working. It keeps telling me I'm not allowed to share.
We're going to try to see if we can actually get it to work in this direction. Can we?
Oh, can you see it now? I think it may be.
Yes, now we can see your slides. Can you?
Okay, great. Thank you. Oh, I'm so sorry about this.
Can you make it a full? Yeah, that works.
Yeah, I'm going to stick to 7 minutes. Hi, sorry about the complications. So I am from Princeton University, and I have been working on kind of the social science aspects of energy transitions in India, mainly looking at public references along with my PhD supervisor. I mean, I guess I can kind of just gloss through this, but basically, I'm sure we all know that how India generates energy will have global climate repercussions. And if we need to do rapid decarbonization, we have to focus on moving away from our fossil fuels our fossil fuel assets globally, especially coal-based power. And we know that national policies and measures play a really crucial role in making sure that that these transitions can happen. So in like in India, we are at kind of a junction because we are also disproportionately dependent on coal for electricity compared to the rest of the world. As you can see, this is like the global dependence on coal, and we are like much higher than what it is. But at the same time, we have ambitious renewable energy targets, and we have made like tremendous progress amongst all countries globally in actually adding more capacity. So it kind of, we need to now know which way we are going to go to meet our net zero goals. The traditional energy transition studies in
Pooja, your slides are not moving. You are on the first slide only.
Oh, are they moving now? Oh gosh.
No, yeah, you're not in the slideshow mode. So yeah.
Oh, I am, according to me. Oy. Am I now?
Nope. Now there's nothing showing.
Is it? Can you see other slides moving now?
No,
No, we can't.
No, you can't see the slides at all?
Not at all.
Sorry, none.
Yeah.
Very sorry about that, but
Because it's telling me I'm sharing my application window.
I think you share the whole screen. That is better.
Now?
Yeah.
Yes, it is okay.
Okay. Okay. So most energy, I mean, yeah, I didn't miss much. It was just some introductory slides. So most energy transition studies in India have kind of focused on just transitions and impacts on coal communities and employment. There's been a lot of climate modeling and scenarios of how we're going to actually reach our renewable goals, and a lot of political economy and high level stakeholder analysis also when it comes to kind of social science. And of course, Dr. Sagar also works on innovation work. But the role of the public at large, or what the average consumer wants, is kind of missing from the literature. And actually, this is a quote which says that consumers don't really care whether they get renewables or not, but they're more bothered about the cost and reliability of electricity. And while this might be true when we are making an energy transition, there might actually be repercussions on the cost and reliability. So you might have politicians being afraid to put in aggressive energy policies if it's going to affect the consumer. And once you have energy policies in place, also the consumer might have to accept certain technological changes and market measures, like they might have to adopt more solar rooftop or an EV. So the role of the public is quite important, and we need to look at it. So as I said, they need to accept economic costs, need to accept technologies. They might also be concerned about India's domestic stance on these things and market reforms. And also they will engage on two levels: at the more abstract macro policy level, but they might also have direct household distribution company repercussions if we need to integrate more renewable energy into our system. As you can see, this is some implications where privatized companies have not gone down so well, and things of this sort. So I did something called a conjoint analysis, which is an experiment where we asked the public to choose between either. So as I told you, it was a 2-level study. So I studied their preferences for policies. And so if you were the person who took the survey, you would have to choose between these two policies, and they got like 5 choices in this way. And then they also had to choose between 2 companies that they wanted to. So some of the findings, it was a representative sample, but quite educated and high income individuals, as we had to do it online during COVID. So we had mainly people from the cities who were educated and high income. So what are the policy preferences? So we actually saw that people wanted coal at the policy, at the macro level, people wanted coal to phase out by 2030 to 2050. They definitely preferred renewable energy mechanisms to carbon capture and storage. They wanted to be a climate leader, so they didn't care whether Western countries were taking their own action or whether they were going to fund the transition, but they wanted the country to be a climate leader. And then they were willing to contribute around 10 to 20% of their annual taxes. But if the transition had to involve privatization, or like more market mechanisms, they were not on board. We see a similar trend with the utility level preferences. So at the household level, they want maximum renewable energy in the grid. They preferred more smart meters to time of day pricing or net metering. They were not willing to put up with any power cuts. And what's interesting is that while they were willing to pay 10 to 20% of taxes, they really weren't willing to deal with any extra tariffs, though. Like, they weren't willing to pay any extra tariffs. And again, they didn't want the DESCOMs to get privatized. So just some takeaways. So like in India, they definitely prefer deep and fast renewable energy transitions. But the policy goals do not necessarily align with public preferences. So the public wants to get rid of coal by 2030, 2050, but in India, the net zero target is 2070. They want the country to be a world leader in renewable energy. But if the success of the transition depends on privatization, then there might be some resistance. The public is willing to pay some extra amount of taxes for the transition, but they're not willing to pay extra on their electricity bills. So therefore, like in India, if you want maybe financial support, you would have more macro level mechanisms than something at the household level. Yeah, so I'm going to stop there, and sorry for all the screen sharing problems.
No, thank you very much, Pooja. You are actually pretty much on time despite all the hiccups, and thank you for powering your way through them. It was an interesting presentation indeed. So thank you very much. I think we have last is Rohit Gotra from, again, IRADE. So over to you, and same instructions. I'll let you know when 7 minutes are getting over, and hopefully you can wrap up soon after that. And then I'm sorry, I actually don't think we're going to have time for Q&A because we're already going to be bumping into the next session. But let's at least, Dr. Magotra, over to you.
Hello. Yes, thank you. So I'm not going to talk about energy transition. I'm going to talk about the climate resilience and disaster resilience, how to integrate them as a part of development plans in the country. So we all know with increasing urbanization and with increase in disasters, so there has to be a focus on granular and localized solutions to develop resilience. And this is one case which I am presenting today of a city in Indian Himalayan region, Sikkim, which is a progressive city and one of the I would say like one of the key state which is investing a lot in disaster resilience. So resilience, we all know, is a capacity of an individual and entity to actually to survive, adapt, and even grow in the face of these shocks. And urban resilience is quite important because a lot of investments go into the urban centers, and because of the high population density and poverty, so the vulnerability is also high when we look at the urban cities, urban centers. In case of Indian Himalayan region, it is also urbanizing very fast. And in terms of energy security, it's low. Energy excess is still low. While the investments happen in the region, it's important that we are investing in climate resilient technologies. We are investing in climate resilient infrastructure, and that's where the focus of our work has been in this city. So we looked at actually a city from the perspective of disaster management plans. So existing plans here, they are very broad based and at a broad city district level, and there are not many cities which have even plans at city level. So what we did is that we identified ward as a decentralized unit to assess the hazard vulnerability. And we also look into the socioeconomic assessments from the broader point of view of a ward and not a city. And we identified the socioeconomic vulnerability. And one of the key things which we did, that these were the first time that we developed this ward level critical infrastructure mapping, and that too was done at a level of 1:4,000. So in India, we generally have maps to the scale of 1:10,000 or so at city level, and largely at 1:50,000 level. For the first time, we actually developed these maps at 1:4,000, and hence the ward level resilience action plans have been developed. So the idea is, how do you proof the city from the future disasters? Because any disaster will take away the investments and the socioeconomic developments which have happened for last so many years. So with this purpose, we collaborated with Northeast Space Application Center, Institute of Environmental Studies, and SSDMA. So we have Vice Chairman of SSDMA also being here. We were supported throughout developing these plans. But I'm not going to talk much about the plan component, so I'll just directly talk about that, how we have looked at the city. So we looked at whole urban agglomeration areas and looking at the future scenarios of how cities developing over the period of years. So vulnerability assessment is core to this study, and we have done both rapid, looking into hazard, infrastructure governance of the city aspect. So covering service level benchmarks, what has been water supply, sewage. So all of these factors actually give you a broad understanding of the city vulnerability. Moving forward, we looked into the remote sensing, GIS, and also the socioeconomic surveys to develop the disaster and hazard maps for floods as well as the landslides. So we identified the specific wards where the vulnerability is high, so that's where a focused action can happen when you identify, that these are the areas which have a problem with respect to the hazards. So we look at the landslides, we look at the floods, and there's a much detailed scientific work on the digitization, and also then further working on identifying the issues with respect to the factors which are aggravating these hazards. So this has been done to achieve a hazard vulnerability maps at the ward level. And further, we have looked at the maps for earthquakes, and also we have done a multi-hazard susceptible wards, like putting all this together, which wards are the most vulnerable to. So I'm not going into details. What the core issue is that how do we actually, once we present this, how do we actually manage these disasters in the future? So that's where we have evolved this resilience action plans, identifying whether this critical infrastructure needs to be kind of move to another part of the city. So power generation, power distribution, this is all important part of the critical infrastructure. And so is the services, critical infrastructure services, which are being provisioned to the city, like electricity and the water. So this has been done in the detail. And on that basis, we have developed several intervention areas and also identified the key stakeholders who are responsible for the same. So for the first level, as a part of the disaster resilience work, work has been done, and a whole infrastructure implementation framework is available, which can be replicated across the other cities and states in the country. So the core point is that we need to have a localized action, and for localized action, we need to have an integrated approach using the tools of remote sensing, GIS, socioeconomic indicators, urban planning. So putting this together, only then we can achieve resilience and achieve our climate goals better. Thank you.
Thank you very much, Rohit. That was really, thank you very much for actually kind of really bringing it together in a nice way at the end and staying within your time. I really appreciate that. As I mentioned, we are kind of out of time, so we really don't have any time for Q&A, but I do want to just kind of reflect for a minute on these presentations, and I think it just highlights a few things. One is the complexity of the overall challenge that we have in front of you. You saw different people are engaging with different dimensions of that, but I think one can also take heart in the fact that there are a lot of thoughtful people who are very much picking apart different dimensions, whether it's thinking about resilience, whether it's thinking about how does the public think about this, and so on. So, of course, these studies are only a tip of the iceberg. There are hundreds of other people working on these kind of issues. But as I said, if one steps back, I hope it does help us appreciate the fact that we have a long, long road ahead of us, where we have to think about a whole range of issues, and not just us. Actually, other countries are also doing the same thing. And hopefully with this kind of work and these kind of groups within India and across different parts of the world engaging on these kind of questions, hopefully we will be able to, from my point of view, the capacity required to engage in these kind of challenges more effectively. So I think with that, I will thank all the participants, both in the room and online, for their patience in being able to sort through the various technical glitches and all of that, and of course the audience for being here right towards the end. I'm really sorry that there was no time for an engagement. I'm sure some of you are feeling shortchanged, but I hope that even if you couldn't get Q&A, at least the presentations were interesting enough that it was worth your while to stay in the room. Thank you very much again. And with that, let's bring this session to an end. Thanks, everybody.
Thank you, sir. I would request you to remain seated. I would once again like to thank each one of you for gracing us with your presence. Now, before we part ways, on behalf of TIFAC and IIASA, we would like to felicitate our speakers. And now, to present a little token of appreciation, I would request Professor Ambuj Sagar to hand over the token of appreciation to the speakers one by one. I invite Dr. Prabal Pratap Ghosh to please come up on the stage and receive the token of appreciation. Thank you, sir. Thank you, sir. Now I invite Ms. Shivangi Tiwari to please come up on the stage and receive the token of appreciation. Thank you, ma'am. Now invite Mr. Rohit Magotra to please come up on the stage and receive the token of appreciation. Now I request Ms. Sangeeta Bakshi to please come up on the stage and hand over the token of appreciation to our keynote speaker, Professor Ambuj Sagar. Thank you, sir. Thank you so much, sir. Thank you so much, everyone. It was a pleasure to have you with us. Now we will have a 10 minutes of short tea break. Good evening, everyone. I would request everybody to be seated, and we will be starting with the panel discussion in the next 5 minutes. Start. Good evening, everyone. For all those who are virtually connected, I just want to check if I'm audible to you. Welcome to our panel discussion round. The theme for our panel discussion is sustainable energy transition in Asian countries, with emphasis on solar, wind, and wave. For the panel discussion, we have our speakers, Dr. Ashok Dalwai. He's presently the CEO of National Rainfed Area Authority under the Department of Agriculture and Farmers Welfare. Dr. Dalwai had an illustrious career in developing administration, where he has implemented several reforms in the rural agrarian sector. Apart from holding several positions in his career at field and policy formulation levels, Dr. Dalwai has contributed immensely to effecting several reforms. I welcome you, sir. Dr. Edward Byers. He's a research scholar in the Energy, Climate and Environment program with research interests in infrastructure systems, water and climate change risk in the water energy nexus, and development economics and vulnerability. Dr. Byers' research at IIASA is on the climate change impacts to the energy and water sectors using global impact, hydrological and integrated assessment models. Next in our panel speaker list, we have Professor Amit Garg, who specializes in energy, climate change, and sustainable development. That focuses on carbon and climate finance, energy businesses, energy and environment modeling, water energy nexus, and preparing businesses for climate change challenges. Professor Garg is currently the co-chair of IPCC Emission Factor Database and also co-editor-in-chief of Carbon Management Journal. Professor Garg was felicitated by the Prime Minister of India in 2007 for his outstanding contributions to climate change research. Next we have Mrs. Ritu Mathur. It's fine, sir. Sorry for the technical glitch here. Ritu Mathur leads the integrated assessment and modeling work at the Energy and Resources Institute, TERI. She has been working in the fields of sustainable development, energy security, mitigation, and climate change for more than 2 decades. Next, we have Dr. A.K. Saxena. Dr. A.K. Saxena presently, he's working with NITI Aayog. He's a public policy professional working in the development sector with a keen interest in the areas of sustainable transport and climate change, focusing on electric vehicles. Dr. Akansha Tyagi. Dr. Akansha Tyagi is an interdisciplinary researcher with expertise in material and analytical chemistry. Dr. Tyagi is currently working as a program associate at the Council on Energy, Environment and Water and focuses on scaling distributed energy resources through technical and policy interventions, supporting a circular economy of minerals and assessing the socio-economic impact of RE technologies to support India's clean energy transition. Dr. Rashid Hassan is a senior advisor at the Society of Indian Automobile Manufacturers and has been a former advisor, MOAF and CC Government of India. Dr. Rashid has a demonstrated history of working in the non-profit organization management industry. Dr. Rashid is skilled in sustainable development, environmental compliance, environmental impact assessment, management, and climate. Now I request Dr. Ashok Dalwai, the keynote speaker, to kindly advance the panel discussion. So, yes. I would request Professor Amit Garg to kindly advance the session.
Thank you very much. All the speakers that are joining, the panelists that are joining online, Dr. Edward Byers, Dr. Saxena, Akanksha Tyagi, and of course, Ritu and I are sitting here and trying to take you forward. The time is a little late in the day and in the conference, but we have to finish by 5:30. So let us try to do a good job at that. So I would like to give maybe 5 to 6 minutes to each of the speakers for the initial comments, and then will we discuss some common questions. So maybe I'll go by the order. Edward, the floor is yours to begin with. 5 to 6 minutes, and I will not give any warning, nothing. Just you will maintain self-discipline. Thank you.
Sure, thanks. Can you hear me okay?
Yeah.
Okay, thanks for this opportunity, and nice to be in the auditorium and meet everyone again. Yeah, so very impressed actually today with the previous presentations that we had in the sessions also, and I also learned a lot on the water side of thing, which was interesting. And but focusing on energy, which was also the session that we had chaired by Dr. Mathur. I mean, kind of recap of both what I talked about and also what I found interesting, I think, in the context of Asia. I mean, there is overall 30% of Asia's electricity supply coming from clean power, and this is accelerating rapidly. And I found recently that actually Asia's share of global and wind and solar capacity has overtaken that of Europe. So Asia really accelerating in this change, and this is a very positive development in recent years that was also reported in the latest IPCC reports. And I highly recommend everyone to dive deep into the details of the latest Working Group 3 report, in particular Chapter 6, but amongst others also, because there's huge wealth of information on a rapidly changing energy sector and covering all aspects of the energy sector. But I think also, as I said in my presentation, Asia is also still dominating in terms of coal production and coal use. More than half of Asia's energy coming from coal. And although this needs to go down rapidly, close to zero by 2050, according to the IPCC, to have chance with 1.5 degrees, it is actually still slowly growing. And there are a number of reasons for why it's slowing, but it's not apparently due to mainly mitigation concerns. Lastly, and I think this overlapped, and there was a very interesting presentation in particular by Rohit Chandra about just transitions and the future of the energy sector within the session. And yeah, lots of different evidence, both from very much on the ground, but also global studies about employment opportunities in the green transition. And obviously this possibly green transition has huge economic opportunities for many people, but the reskilling challenges are immense, actually very difficult, because many of the people currently involved, for example, in coal production, are amongst the lower income and least skilled people within society. Also, the very apparent geographical distribution, which was also highlighted very nicely on the maps. And this applies also in other countries. We cannot just transport people away from coal areas and put them where the sun is shining and the wind is blowing. There are not easy solutions for this. Lastly, I would say, though, in the context of the wider mitigation and adaptation transition, providing decent living services and basic services, attaining the Sustainable Development Goals within Asia is incredibly important. Lots of progress recently, but also not only helps us mitigate for climate change, but provides or reduces vulnerability, provides resilience against the impacts of climate change. And so this is a win-win in my view, and energy is crucial for both mitigating but also providing reducing vulnerabilities to climate impacts. And I'll leave it there.
Thank you very much. I now request Dr. Ritu Mathur, who is not with Terry. She is in Niti Aayog and leading a lot of issues, lot of things there. So we are very I think privileged to have Ritu here. So Ritu, please, the floor is yours.
Thank you, Amit. I mean, I think we've heard a lot in the last 3 days on various issues. And in this panel, we are basically looking at sustainable energy transition in regard to the Asian countries as a whole, with emphasis on solar, wind, wave, etc. So I think when we look at Asia as a whole, the first thing is that about growing demand. This region is still one where demands need to grow. And Asia, comprising about 50% of the world's population and about 1/4 of global GDP, has seen per capita energy demand growing by almost 18% in the last decade. So this is one of the biggest challenges that the region faces in terms of going forward to try and decarbonize while it continues to grow.
In terms of looking at where coal gets positioned in this kind of a system, again, coal enjoys a dominant position in the energy mix when it comes to the Asian region. India and China are especially large users, accounting for about 64% of global coal consumption, with about 52% of this resting in China. And this dependency, while it has helped these countries to become strong economic power by pulling millions out of poverty, coal also happens to be responsible for much of the emissions. So again, a big challenge. In terms of energy security, a large part of Asia continues to depend on imports of fossil fuels as well. And due to recent geopolitical conflicts, such as the Russia-Ukraine conflict and also COVID-19, etc., the Bangladesh, Sri Lanka, Pakistan, etc., are again increasingly seeing huge energy deficits, which hamper the productivity of economies. Asia also has been lagging behind when we look at what has been possible when it comes to energy transition, and the Energy Transition Index published by the World Economic Forum assesses how different countries are moving ahead with regard to the adoption of renewable energy, with regard to different kind of parameters, including capital and investment, regulation and political commitment, institutions, governance, etc. And with regard to all of these, again, the performance of many of the Asian countries has been on the lower side. In terms of some success elements, again, energy transition in Asian countries hinges on meeting its growing energy requirements through clean energy sources and ensuring that the transition is also just and sustainable. So Asia does have a very huge green potential and also a need for having a high level of climate action. So as a region, it is extremely important that it moves forward quickly and in a big way to tap this green potential and take up the opportunities of moving ahead globally. Again, when we look at the share of renewable energy, the share of renewable energy in electricity has more than doubled from about 13% in 2000 to about 25% in current times in Asia. And largely this has been driven by solar and wind. And again, RE capacity has grown significantly with China leading and accounting for a large share. China has also been among the first countries in the world with about 1 terawatt of installed RE capacity. So these are huge numbers, and the capacity addition has largely been dominated by solar and wind due to significant cost declines in these technologies that we've seen in the last few years. So role of solar and wind can be quite high for this region. And according to IEA, these two alone could meet about 1/3 of global energy demand and about 2/3 of electricity demand in the 2050 net zero scenarios that IEA has projected. So again, there is much to be done and much potential that we do see in terms of solar, wind, and also wave, which can be taken up. Now, coming to where India stands with regard to this whole setup, India's fossil-based consumption in the entire energy mix is about 83% fossil-based, and the balance being non-fossil energy. But if India has to attain net zero by 2070, this 83% share has to be reversed to be taken up by non-fossil based 0.99 rupees per kilowatt hour by December 2020. But again, we need to be able to ramp up our capacities of solar very quickly to reach the 500 gigawatt targets that we are already talking about. So in the Indian context, we see that solar will need to account for about 1,200 to 1,500 gigawatt. Wind would have to be somewhere around 300 to 600 gigawatt of total installed capacity of the grid which is about 2,000 to 2,200 odd gigawatts by 2047, as per some of our estimates through the IESS tool at NITI. So almost about 3/4 of our capacity will therefore need to be dominated by solar and wind by that time. So there are several concerns also if we look at this kind of a transformation. The first is with regard to the need for a much higher pace of growth when it comes to renewable energy. And if renewables were to grow at the same pace as the last decade, then global RE capacity would reach about 4,091 gigawatt, or about 4,100 odd gigawatt, which is about 13% higher than the level expected through target implementation, but it is still very short of the 10,000 odd, 10,700 odd gigawatts required under the net zero scenarios. So we have to sort of ramp up the kind of capacity installations of RE much, much faster than what we have been doing so far. Also, we are heavily concentrated, we see there is heavy concentration of material and metal reserves when it comes to the spread of these resources. And while coal, oil and gas were more spread out in terms of the regional distribution, 75% of the lithium, cobalt and rare earth products come from just 3 countries. So 50% of the lithium is in Australia, South Africa and DRC account for about 70% of global platinum and cobalt production, and China accounts for about 60% of the rare earths. So again, you're looking at very large geopolitical shifts in the way the fuels may be used and where they are produced. Also, the lead time for the development of new mines is very long-ranging, from estimated to be about 16 to 20 years. So where do we see these products and minerals coming up is also a challenge which needs to be discussed. The manufacturing of RE components is also largely concentrated in China. And other challenges, of course, include the impacts that we've seen in terms of economic disruption in the last few years. COVID-19 has brought in the effects of induced lockdowns. The Russia-Ukraine conflict has been threatening the trends of cost declines that we have been seeing in clean energy technologies because of increasing prices of critical metals and minerals. And since 2020, the prices of cobalt and lithium have almost doubled. Copper, nickel, and aluminum have increased somewhere in the range of 25 to 40%. So again, there are trends which are emerging as challenges because of a variety of reasons. And availability of finance is another consideration that becomes very important, especially for emerging economies. With falling costs and supportive policies, RE investments have grown from about 70 billion in 2005 to 320 billion in 2020, with solar and wind attracting nearly 90% of the share. But despite such high growth, RE investments have largely been concentrated in just a handful of countries. India's investment in RE capacity stands at about 9.3 billion USD compared to 83.4 billion in China and 55.5 billion in the US. So again, there are big differences in what different countries have been able to do and how they're going forward. But there are also several opportunities going forward. First, if we look at the demand for EVs and the reduction in battery costs, this can help the growth of the green hydrogen industry. And that's something which again, is a great opportunity also for India, not only to reduce emissions and energy imports, but also to build export scale capabilities in high value green products such as green steel or green ammonia, etc. When we look at role of nuclear again, and looking at achieving net zero, we do not think that just solar and wind would be able to manage the kind of transformations that we would need to have. And we may have to build more than 7,000 gigawatts by 2070, which is a huge task. So the role of storage technologies would, of course, be critical, and large-scale penetration of energy storage systems, though imperative, would also need other elements to come in to help the baseload capacities. So nuclear as a technology can also play a role to assist the reliable transition of fossils to cleaner options. Energy efficiency is again another element which needs to play a critical role. We have been doing well with the PAT schemes, etc. in India, but again, this remains an important driver of growth and in meeting the net zero target. The government of India, apart from the PAT schemes, has the standards and labeling programs, the energy conservation building codes, and so on. And all of these measures have already led to mitigation of about 188 odd million tons of CO2 by 2020-21. But again, as I said, with the kind of growth that we are likely to see in the future, energy efficiency will continue to play a role to levelize the kind of rates of increase that we might have seen otherwise. So overall, I think while Asia has been lagging behind in terms of being able to control the growth-related emissions, there are many steps which are required on several fronts. One, in terms of enabling technology sharing, where technology sharing, especially in the latest clean energy technologies, would be crucial for achieving net zero. And India, under the G20 presidency, may want to target an agreement on technology development through collaborative implementation arrangements or transfer of IPR, etc. The second is with regard to scaling up green finance. About $130 trillion would be needed by 2050 to invest in technologies which are compatible with the 1.5 degree C kind of pathway. And in the absence of funding, many countries may fall short of their net zero targets. So a dedicated framework to enable access to green finance from multilateral banks at concessional rates to accelerate the adoption of clean energy would also be needed to leverage blended finance solutions to increase the uptake of green finance. And lastly, the diversification of the supply chain, I think, is again a very important element where energy security concerns, including the probability of disruption in supply chains and price volatility, become important to address. And in the era of clean energy transition, the focus would need to shift from securing the availability of fuels to securing critical minerals for energy storage as well. Supply chains dealing with critical minerals, polysilicon, electrolyzers, small modular reactors, high efficiency PV cells, etc., would all need to be diversified. And there would also be a need for having some kind of rule-based architecture in the trading of RE and RE-based products through harmonized green taxonomy standards. So there are many, many things to think about when we look at the transition for Asia and helping enable this to move forward. And with that, I'd like to end my remarks.
Thank you, Ritu. You have been you covered a lot of ground and maybe many issues and challenges and opportunities you touched up. So thank you very much. Now I request Dr. A.K. Saxena from TERI. Are you there, Dr. Saxena?
Yes, Dr. Amit, thank you so much. Am I audible?
Yeah, please. Yeah, you are audible. Please go ahead.
Thank you so much for the opportunity. At the outset, let me express that Dr. Ritu has covered it so extensively, there is hardly anything much to be added now. But I will touch upon a few points. First of all, I feel the energy transition to be sustainable, we need to take a holistic view in our country, keeping in view the resources we have, our development requirements which are there, the technologies available with us, and their cost effectiveness to produce affordable energy for economic and social development. Transfer of technology in a number of areas is extremely important. Dr. Ritu has touched upon and additional financial resources are extremely important to be made available by the developed countries to the developing countries as committed by them. However, pending transfer of technology and additional finances, the country needs to focus on energy efficiency. The fruits of energy efficiency, which has already been enumerated by Dr. Ritu, are well known, and I think they need to be expanded further. And that is what the updated NDCs also make a mention of that. Secondly, I feel the domestic manufacturing, it needs to be promoted quite extensively. The production-linked incentive scheme, which we have in regard to a few of the equipment, I think that needs to be sort of enlarged and enhanced. The economies, benefits of economies of scale need to be derived in various facets. The scheme needs to cover the full value chain of solar panels, the reversible turbines, pump storage, mirrors for solar thermal, and green hydrogen. I think only when we become Atmanirbhar and globally competitive renewable energy manufacturing hub, then we can say that the energy transition is sustainable in the real sense. Next, I feel the key stakeholders need to be at the center stage. I think the ground-mounted solar has seen a good progress. Similar progress needs to be sort of propelled in regard to the decentralized solar, and that is an area of focus importance where it should be. And the distribution companies needs to come on board to take this forward appropriately. Next, I feel is the consumer involvement extremely important, and from the point of view of energy efficiency, peak shaving and peak shifting, the time of use tariffs are extremely important in the electricity sector. The differential between the peak tariffs and the off-peak tariffs needs to be substantial so as to incentivize flattening of demand curve, and the distribution companies can also reduce the peaking power procurement requirements. The distribution companies also need to give a choice to commercial and industrial consumers to buy carbon-free electricity. That will really take this movement forward. Next challenge what we feel about is the implementation. The scale of implementation is certainly what is required to be sort of contended with, and we have to be fully prepared for that. And in the implementation, I think it is a coordinated implementation at the state and the central level, which is extremely important, and because the action lies at the state level. Next, I feel the policy certainty and sanctity of contracts is extremely important for making the energy transition sustainable. Just transition is we have heard about during the course of this conference, and I think this needs no further emphasis. We have to look beyond our boundaries in order to become sort of aggressively taking forward the clean energy transition. India is already having cross-border electricity trade in South Asia, and I think the One Sun, One World, One Grid initiative needs to be further sort of accelerated once the studies are completed. I think with this, I feel the energy transition in India can be sustainable. Thank you so much.
Thank you, Dr. Saxena. Now I'd look up to Dr. Akanksha Tyagi for your inputs, please. Akanksha.
Thank you. Good evening, everyone. Hope I'm audible. Yeah. Thank you for this platform. It's a privilege to be along such illuminous dignitaries on the panel. I'll touch upon two aspects of sustainable energy transition, among several other research verticals that are pursued at CEW. To enable a sustainable energy transition, one of the areas that we focus on is to ensure that the transition is responsible and inclusive. An inclusive transition would require an understanding of the socio-economic impact of transition. Where are the employment opportunities coming up? What are the skilling requirements to tap these opportunities? Basically, providing the granular data that supports the political narrative towards a transition. An inclusive transition also requires equitable sharing of co-benefits among all the stakeholders. And lastly, the inclusive transition requires the representation and participation of communities in the decision-making process. So one of the research that we have undertaken to understand how the large-scale RE projects are impacting communities. Because of late we have been hearing several concerns about the inclusiveness and impact of these projects on the communities. So large-scale renewable energy projects, they are spearheading India's clean energy transition. As of the current capacity that's installed, just talking about solar, about 82% of that capacity is coming from ground-mounted utility scale projects. And the distributed solar portion, that as it was also highlighted by Dr. Saxena, it remains more or less neglected. And of late, we are hearing several concerns about the inclusivity of these large-scale projects, be it Andhra Pradesh, Kurnool district, Karnataka's Pavagada district, Gujarat's Jharkhand. Communities across are expressing concerns about the impact these large-scale projects have had on them. And that is leading to several conflicts with the RE industry. So it is important to understand their concerns and then collectively develop solutions to ensure that the RE capacity expansion we are envisioning and the clean energy transition that's underway is conflict-free and just. It's also important to acknowledge the environmental impact of clean energy technologies. And that's the other aspect of making the energy transition responsible while making it sustainable. So at CW, we have been looking at how do we ensure a responsible waste management of the clean energy technology? How do we ensure that the materials that go into these technologies do not adversely impact the environment? The materials are recovered so as to maintain the self-sufficiency of our domestic manufacturing industries and achieve the large energy security goal. And lastly, the new employment opportunities that are created, how do we tap on them and ensure that they are largely formal and whatever workforce is involved has access to different social benefits? And unlike the informal sector that's largely, taking responsibilities of managing such waste currently. But a difficult task due to the absence of policy framework, technologies, and the market mechanism. And I hope as we go further into the panel discussion, your opinion and solutions on each of these aspects. With that, I'll just pause my remarks and give way for the next speaker. Thank you.
Thank you very much, Akanksha and all the panelists. So I understand that Dr. Rashid Hassan is not there. Dr. Ashok Dalwai could not join. So that is the panel we have now. So some very interesting remarks had come. The first thing is the countries in Asia, what we're talking about are at different levels of development. So we cannot have a broad paintbrush to say everybody should follow this. Not possible. I am having with me the IRENA Renewable Energy Statistics 2020, and I've counted solar and wind electricity generation, not the capacity, how much electricity has been generated. 2020, word is 9.02. So whatever we say, how much capacity has been there, but the generation of energy is 9.02%. And no country except Germany is above 10. And Australia, that is 13.6. Germany is 26%, 28%. So I think this is a very stark reality that we may be keeping a lot of capacity, but energy generation is not happening. So if we also see, second positive point, that in G20, 6 countries are from Asia. And I name them China, India, Indonesia, Japan, South Korea, and Saudi Arabia. These are large countries, huge countries. And these countries have different perspective on what they mean by energy security and sustainable energy. If you say that Saudi Arabia, more for oil and gas. If you see for China, India, maybe even Indonesia to a certain extent, more of coal. If you see Japan and Korea, they have different perspective. So that is one point. Second point is that there are certain, maybe if you see comprehensive or points which are integrating them. So one is their movement towards net zero. That is toward climate security for the world. So they're all contributing. They all have very strong climate action despite there may not be having the sufficient resources to meet that, like our country, India, where we are sitting and having this discussion, may not be so high in our resources on maybe critical minerals, as Ritu was saying, but even then we are going strongly ahead with our EV program. We are going strongly ahead with our solar program, with our wind program. We are strongly going ahead. Similarly, China, of course, China is way ahead. So if we see that Japan is going for green hydrogen, big way, moving technology, and China is also moving technology. India has also declared, many big industrial houses in India have committed over $150 billion by 2030 into green hydrogen and solar parks. So this is something which is a future thing. And I'm thankful to Ritu for pointing out that nuclear cannot be left behind. And maybe just to inform, in early part of July, EU has voted to have nuclear and gas in their sustainable taxonomy. So nuclear is there. India also has nuclear, of course, a strong nuclear program, but of course, it is very capital intensive. If we see at China, they also have very strong, but I think there could be, once there is a agreement to have certain technologies in the basket, we can find out ways to see how those technologies can be in the basket. Then I think challenges, we have seen that energy security versus climate security. Any energy is better than no energy. We have seen the recent incidents Ritu was also talking about, the war between the unfortunate incidents happening in Russia and Ukraine, which have destabilized the whole world energy systems. So those systems have pointed out that many countries who were committed against coal had to move back to coal. The committed countries which were stated against nuclear, they are going back to nuclear. So any energy is better than no energy. We want energy. That is very much required. And then, of course, grid stability comes along with having huge solar and these issues. So I think I'll stop talking. Maybe we'll open the discussion with the panel on two questions. That is, where do you see the solution space emerging in Asia on sustainable energy? Of course, we have raised many issues. Solution space, is it going to be renewable? Is it going to be something else? Where do you see some solution space coming in the next 10 years? Of course, in the long run, we are all dead, and we all know that net zero will be achieved for the world. But in the short space until 2030 NDCs, where do you see the solution base? And I look up to Ritu, my colleague sitting here, and then I will go to panelists one by one.
So thank you for that, Amit. I think when I look at the long term, of course, we've pledged net zero and the countries would be moving along that direction. But it's really the short term which needs, to be carefully planned. And when I say carefully, I think that is where, painting with a simple paintbrush, like you said, can't be done, especially in a country like India. We'll have to manage the transition, taking into account many, many considerations, including those of regional locations of different fuel forms, of the infrastructure that has already been put in place so that we don't, have stranded assets or we have sunk costs which we do not recover. There are issues of affordability when it comes to what it will mean to the costs that consumers have to pay. So also what happens to our fuel prices as we do the transitions, and what kind of subsidies the government would have to bear if it tries to transition in certain ways towards certain cleaner energy forms. So I think the multiplicity of challenges are very many, and there is no single silver bullet. Yes. So we will have to go with a mix of different kind of fuels in our energy basket. While we have very strong push and a desire to ramp up electrification and the amount of renewables, and even in the short term, and probably the grid could handle a certain amount of RE without adequate ramping up of storage, which is still very costly. But beyond certain levels, I think we would need for more stable measures. Yes. And therefore nuclear, gas, coal, I think these need to remain in our phasing in and phasing out strategy for some time to come.
Okay.
So that is what I see in the short term in terms of our energy.
That is precisely, you see very sharply, Ritu, I must say. Edward?
Yeah, I mean, picking up on the points, I think, which as you started, and I'd also meant to mention previously, is that obviously there's huge regional diversity across Asia, and we see this also in the not just wind solar wave that is theme of discussion, and those are increasing, and then those major economies, Japan, China, Korea, etc., have recognized, I guess, the value of clean energy as important parts of their economy. I think most critical, though, and lastly, on the regional part, I mean, I think then obviously there's a lot of regional skill share that can be done, and opportunities for the first mover countries to then help other countries upscale, let's say, clean energy systems. On the very short term, 10 to 20 years, I mean, I think there's great opportunities, particularly on development perspective also. Yeah, so increasing levels of rural electrification, which can be very nicely done with distributed and renewable energy systems, can be coupled, for example, with solar irrigation, can provide more stable electricity systems for people that have never had electricity access, and enable more mechanization of agricultural systems. This is important to ensure that people in very more remote rural communities are not being left behind, and providing them with access to basic services, including other things like telecommunications and fridges, you know, and medicine. So I think that, and also coupled lastly with improved storage and possibilities for electric mobility, electric bikes, electric motorbikes, really can bring a important and rapid transformation across rural Asia, which I think will be particularly important in the next 10 to 20 years.
Thanks. Akanksha?
Yeah, thank you. Mostly on the same lines what Dr. Mathur and Edward said, but it's also about making right choices, be it whatever technology you want to pursue. For example, if you were to promote storage, be it in short term or long term, identify what applications do you need storage for? What technology options do you have? Not following what the global trends are indicating, understanding our capacities, be it around mineral resource, be it around the skill set of the workforce, be it around the requirements of the sector. We have been talking about electrification of the mobility, like the transport sector. But do we want to do that via private transport or via shared mobility? So that's also a choice that the policy decisions have to factor in. And again, if we were to focus on the regional discrepancies, we can go solar, but should it be on land? Can it then be on water, floating solar? Utilize your dam reservoirs, utilize your artificial lakes, ponds. Do it on roof. Promote open access. Leverage on market participation and better utilization of the grid infrastructure. I think these are also some very important policy decisions that have to be taken in short term just to achieve the long-term goals.
Yeah. Thank you. Dr. Saxena, any last words from you on this?
I think a lot of points have already been covered, but yes, every country will have to develop the strategy depending on the resources which they have and the way forward they see about. I think in India, I think coal continues to remain the mainstay, but the economics of the renewable plus storage is driving the transition, and that will continue to drive the transition. And we should see that when do we feel the inflection point is about to come, and we should be on guard keeping that in mind. Until that time that happens, about energy efficiency and demand side management should be promoted with full sort of a acceleration or whatever we can say about it. In the shorter time span, I think the gas will continue to remain as an intermediate or a transition fuel, but the only problem with gas we have is about the domestic availability of gas, and the imported gas doesn't make it very cost effective for the power generation, at least. On the solar side, I think decentralized solar needs to be given more push, and apart from that, the floating solar, of course. The offshore wind will remain an important element, and all these need to be put together. Of course, as Akansha said very clearly about the storage, I think storage is an integral part, and we have to see the end use application. We need the storage for daily balancing, the weekly balancing, and the seasonal balancing, and different types of storage are required for this. And starting with the pump storage plants, which should be the first priority for the long-term storage because of the mature technology. It is not only the reservoir-based pump storage plant, but also the offshore pump storage plants. Off-river pump storage plants are also very attractive, which we are finding about. Solar thermal technology with storage is another option which needs to be pursued with. I think the pilot plants needs to be pursued, and then see that how best we can bring down the prices. The battery energy storage systems for different applications, the hydrogen storage, etc. They will all make a suite of technologies which will be useful for a country like India. Thank you so much.
Yeah, I think one point which I see that we have not discussed was neither pointed out bioenergy. India has gone for second generation bio, that is ethanol technology, and the Honorable Prime Minister inaugurated the big plant from Indian Oil. Now, maybe I would like to request Edward, what do you think is happening in Europe on second generation?
Yeah, I think moving slowly, and definitely a preference for more forestry-based biomass. There's been a lot of concern, I think even since the 2000s, about basically first and second generation biomass products and competition with foods, and if whether these were produced within the EU or being imported into the EU, kind of hidden within biofuels, and this seems to, I think, have slowed down. And electrification, I mean, I think much of the demand was primarily at the time, or the interest at the time was primarily as a substitute for transport fuel, and now electrified transport has, let's say, accelerated on that aspect. And so the only, or the majority use of biofuel or biomass now is primarily for heating purposes and combined heat and power. So yeah, different here, but I think less controversial than it was about a decade ago at the moment.
Okay, because that is good to hear. And as we move forward in using more of second generation, because to avoid food conflicts, I think we need to look into it more closely as a science and technology challenge, as a supply chain challenge, because here bioenergy gives the money directly to farmers. And that is a very important thing which a country like India should look at. Rather than, of course, I'm not against any other renewable, that is solar, wind, I'm not against. But this directly gives the money to the farmer, and farmer is the only community that deals with human and nature. Otherwise, we all do business with humans and humans. It does the only thing which does business with nature. So they understand nature very well. I think we should, I thank the panel for very interesting points raised. And I understand that we may have to close the session very quickly. So I thank everybody for being here or being online and giving your time, efforts, and brilliant ideas. Thank you very much.
Now, I would request Professor Amit Garg and Ritu Mathur to please be seated. So on behalf of TIFAC and IIASA, we would like to felicitate you for being our honorable speakers for the day. And to the speakers joined virtually, I thank each one of you for your valuable contribution to our conference. To present a little token of appreciation, I would like to invite Mrs. Sangeeta Bakshi to hand over the token of appreciation to the speaker.
I'm sorry, Dr. Saxena is not heard completely. He has raised his hand.
No.
Okay. Thank you very much. Maybe previous. Sorry, please go ahead.
Yes, so I would request Professor Amit Garg to kindly receive the token of appreciation. Now I request Ms. Ritu Mathur. Now I would request Mrs. Ritu Mathur, Senior Energy Consultant, Niti Aayog, to kindly receive the token of appreciation.
Maybe I'm not sure whether online speakers will also be provided this gift. I don't know whether you will send it or something. You should send. They have really put in effort. Thank you very much.
Thank you, sir.
So we are now concluding our 3 days of hard work, 3 days of deliberations, 3 days of lots of efforts and interesting and a very excellent presentations. So we have to conclude and we have to take forward something now from today onwards. So now we are just starting with our closing session, and I'm requesting our all delegates here and dignitaries to please come onto the dais. I'm requesting Dr. Akhilesh Gupta ji to please come on the dais. Dr. Amit Garg, Dr. V.M. Sharma ji. Now I use the other microphone now. So now we have gathered quite a few recommendations, the keynotes. We've also gathered a lot of suggestions, the technology gaps which we have learned over the 3 days. I think our coverage on all the socioeconomic sectors, basically focusing most on the sustainable development goals, have been addressed very, very efficiently. And it's I think we have done a lot of justice to all the sessions very well. And I'm really, really thankful to all the scientific fraternity here, all the speakers, all the panelists, all our keynotes. Really, really thankful for your valuable time to have come here, joined virtually or in person, and done this justice to this 3 days of conference. Now the thing is, Now, we were all here, like I mentioned about in the beginning, like we are actually having this program of India-IASA's collaboration program. Now we have to see, like, when we have done this conference, we are looking forward to how we can strengthen this relationship. We have deliberated on lots of themes, but all the sustainable approach we have to have some roadmap for its implementation. So we are all here to basically conclude, to basically deliberate, recommend, and also take forward some draft agenda, how to strengthen this whole India-IASA's initiatives. And TIFAC has been the member of this IASA since 2007. We have been like on this, like getting a lot of capacity building, a lot of modeling support from IASA. We have developed some India-specific models based on their the huge modeling exercise which they have done it, I think maybe a couple of years, like 20, 30 years of models which they have developed, and we have come up with some India-specific models. And we are trying to see how we can really build this capacity in-house. That means our India has to become really very good on modeling as well as system analysis. So this conference is also we have to see, I mean, how, and like we have, like IASA has some strategic initiatives which they have planned. From this year onwards, they are working on some strategic initiatives. And initially, like we were doing on one-to-one cases, but now we have to work on the strategic initiatives wherein we are clubbing like 2 or 3 NMOs. NMOs means national member organizations. And these national member organization, India is one of them. And there are 22 countries who are member of IASA Council. So now when it comes to strategic initiatives, we have to think about like maybe, 2, 3 countries who are the members of IASA. We work on these strategic platforms on some of the issues which have some commonalities among all the 3 countries or 4 countries. And IASA has been doing this strategic initiatives with India as a case study since almost 2 years now. We have taken up a few projects initially. One is on the FAIR stream, which is actually a food, water, energy nexus. This we started actually at the Bhima Resin in Pune. And then we are now going to start on the disaster management as well. This we have the partners from IIT Roorkee and also from Pune. Now this is just 1 or 2 case studies, but yes, of course we have to see, I mean, we need to have much more beyond this because there are a lot of issues, there are a lot of gaps, there are a lot of technology scenarios which we need to build up. We have to come up with some quantitative data. We are very good on data, but we don't know how to do this and actually get into this system modeling approach to actually come up with the proper roadmaps for India. So now I'm also requesting all the delegates here, all the experts here, to let's see, I mean, how, and like we have to give us some recommendation. We'll take forward some suggestions from our audience here, exactly like how we can strengthen and how can we move forward with this India-IASA's initiatives, collaborations. Yeah. I now request Dr. Akhilesh Gupta to kindly chair this session.
Thank you very much first of all, thanks you for inviting me to this concluding session. And I welcome all the panelists here, Professor Sharma and Jensen Pillai and Amit Garg, along with Sangeeta for this concluding kind of summary of what has been discussed, deliberated in last 3 days. Well, it's always in like concluding is, I always in fact hate to attend any concluding session because by the time you have concluding, you are left with hardly anybody. So, so nobody here to listen to what you conclude. But the good thing is that, this is called record. So I always say this is called record, that you need to sit and conclude. So since I have not been witness to what has been discussed in last 3 days, I would suggest that, it's somebody who has done this job maybe suitable for summarizing. So what I do is let me invite the panelists one by one. And before that, Sangeeta, do you have any summary of recommendations on the session? Anything that can be, kind of presented or at least given some highlight?
Actually, we had these parallel sessions on all 3 days. And we have taken quite a few notes, but we haven't done summarizing anything right now. Yes, it will take some time and we'll post it, I think, by the coming week. Yes, but actually, if you have this program guide, you would see most of the sessions and also the titles of the presentation from the speakers. So I guess you will have a fair good idea. Yes.
I'm just trying to understand whether any exercise has been done or not. So I think we will do that kind of concluding as a kind of good summary towards. And let me invite the panelists one by one so that they give idea. I see the entire discussion has been very lively, I understand, because seeing the program looks like a range of issues has been included as part of the discussion. So instead of I going into the details of those things, let me invite comments. So let me start with Professor Vinod Sharma ji, and he has been kind of doyens of disaster management. Recently he has been awarded by the Prime Minister himself on Subhash Chandra Bose Award on disaster maintenance. It's a very coveted and very prestigious award that he has received. So I would request Professor Sharma to give his views on the scene.
Sir, and in fact, it was a very fruitful day for me. And I'm here since morning and attended, most of the session. But as you rightly said, that it was a, range of topics. And in case you see the, brochure of the conference, you will be impressed that more than dozen, sessions on different topic, and the speakers. I think that selection was very good. And I think it was many issues, which they discuss in 3 days. Then international conference, I think there is one advantage that you get many best practices, from different places. And because our issues are same. I was seeing that South Asia, for example, we have similar issues. We have, more population, we have more poverty, we have, vulnerability for natural disasters. So I think in case you see the similarities, and then there are different, things which are going on in these countries. So in this kind of forum, this is one good advantage that you get the best practices in energy conservation, start with energy conservation up to the, risk reduction, involvement of the communities. Then second thing which was very important here is that they included almost every, stakeholder. Start with the government, then the non-governmental organization. I could see many presentations from IRADE and, similar non-governmental organization, academic institutions like IITs, IIMs, and different universities, they were participating and there. So I think in these issues, when we are talking about data, when we are talking about modeling, when we are talking that, this thing, in the integration, in the policy, I think these are the pillars. I remember that myself and Akhilesh ji, we were involved in the science, technology and innovation policy. And we included, I think, each and every, pillar of the, academia, not only academia, but the different kind of institutions, different organization. And same way I was seeing here that the experiences, the practical experiences of the NGOs, research organizations, small, big units, academic institutions. So I think this was another very important thing, which was there. I'm thankful to you that you have added disaster risk reduction this time. Climate change, disaster, and when we are discussing climate change, disaster risk will have to come. And you cannot, ignore that. But I think you have given main emphasis. So that was a very important thing. And, a special session on some important topics like our natural resources, stress on agriculture, water, etc. We got, the difference, the basic difference between West and East, and we realized that, yes, how much investment, West is doing on innovation. We talk a lot about innovation, etc., but how much is investment? I think that point was very clearly mentioned by some of the presenters. And yes, now, definitely in case I compare from last 20 years, then I think, yes, we have increased funding and for science and technology, for innovation. Now we are thinking that, yes, it will give dividends, in future. But I think this is, then the cooperation, different kind of cooperation actually. Academic cooperation from these institutions, non-governmental organization, community participation, gender issues, I think all social issues, everything was, included. And this inclusiveness, in case you, for example, agriculture, water, you don't include the women organization, water users association, I think then you cannot achieve much. So this kind of thing. Then, in my opinion, because ultimately, all these things which we discuss, science, different experimentation, what we are doing at different institutions, ultimately, it should go to the policy. And, there are many presentations, n number of presentations which were leading and giving some recommendations to us, which can be utilized. In my opinion, as I am saying again, that climate change nowadays, and I belong to Indian Institute of Public Administration, I am saying that I think climate change, adaptation, mitigation, this will be the base of administration in future. I was addressing, 2020 IAS officers who are here for 3 months, and I was mentioning this thing that, in the agriculture, in water, and climate change, I think this will be the base actually of the administration. It may be district administration, it may be state administration, it may be local administration. For example, in Sikkim, I can tell you that we are having upper hand because we have involved, the local, administration, Panchayati Raj in these issues. And I gave one example this morning that many villages where the source of water is a spring, all spring were dried, and we revived the spring. There is a program, Dhara Vikas program, which got, Prime Minister's award. And in that, with the help of villagers, with the help of local communities, we revived more than 4,000 springs, and now these villages are getting fresh water again. So I think that's that kind of, and that I am giving emphasis in Mussoorie or wherever we give training in public administration, that climate change, disaster risk, I think we will have to see the vulnerability of the place, and then the whole administration will depend on that. So for me, it was a very useful day actually, and I really enjoyed, but I'm sorry that I couldn't attend the whole, conference. So I stop here.
Thank you, Professor Sharma, for your very insightful comments and suggestions. Now I request Dr. Pillai and Sagak 5 minutes if you can just say your concluding remarks from whatever takeaway from this conference. Start with Dr. Pillai.
Thank you very much. Ladies and gentlemen, congratulations. You are what I call the survivors, the ones that wait right till the end of the conference. It takes a lot to be with us right now. Firstly, let me say thank you to TIFAC, to the Indian government, and to all of you for hosting us as IIASA as part of our 50th anniversary celebrations. This is one of many events that are taking place around the world. We still have events that are to take place in Korea, in South Africa, in Austria, in Israel, in Iran, etc. And we've already had events in Finland, etc. So this is one of many events. The idea was to bring the research closer to people. So given that these are closing remarks, I'm not going to dwell on any subject matter, but rather make a few anecdotal observations that I think are important. Let me firstly thank the people behind the scenes. There are a lot of people like the persons from audiovisual, the ladies at the front who handle registration, the caterers, the organizers in TIFAC and in other places that have worked incredibly hard to try to deliver an event. They worked in collaboration with our team in communications and external relations at IIASA in Vienna, and they worked against the tide in many ways. Planning a conference of this nature that is a hybrid is quite challenging, because while you're having an event here and you are starting 10 minutes late, you're keeping a whole lot of people across the world waiting. And so we're at risk as to how we present ourselves, and our job is to protect each other. So that was an important learning and takeaway, that when we do organize events that are hybrids, that we have to take this into consideration. Another observation that I made is that less is more. For example, the last session that we had now, we could have easily had a wonderful, stimulating 2 to 3 hour discussion with some real takeaways where we've all applied our minds and we've interacted. So sometimes we become our own enemies because we set up something and then we don't extract full value for it. So I think that's another takeaway that I would like to share with you as we go forward and as we organize events of this nature. Now, one of the things that I noticed was that, in a way, I'm a cricket follower and I'm a cricket fan, and I know India's cricket crazy. But in many ways, when I saw young people together with established researchers on the same platform, it's almost an analogy to the IPL, whereby one of the unintended consequences is boosting the confidence and morale of young researchers, where they sit with the same platform as established researchers, are able to interface, interact, question, comment without fear or favor. And to me, that's part of the education. And I think it's something that we should encourage as far as possible. Then again, I've also noticed over time that there has to be an approach that's not normal, and I saw it evident in this meeting here. Academia can't do this alone. Government cannot do this alone. Civil society cannot do this alone. Business cannot do this alone. So if we want to solve any challenge, whatever the nature of the challenge is, we need a quadruple helix approach that involves business and industry, that involves government, that involves civil society, and that involves academia and the intellectual community. So I think that kind of approach will augur well for the future if we're able to take that. I also mentioned the other day in my opening remarks about the Vienna Statement on Science Diplomacy. I urge you to access that site. There were cards that were available, and I urge you to sign it, because that is basically, by signing it, you are saying to the world, we encourage research collaboration across boundaries, across borders, across cultures for the benefit of society. And I think that is the important message. Lastly, I want to just say, from the side of IIASA, I would like to thank our conference collaborators, our knowledge partners and sponsors, and I want to thank especially Sangeeta Bakshi, who's worked very quietly behind the scenes here. She's had sleepless nights. She will try and catch up this weekend, and I want to thank you for that, Sangeeta. And finally, on behalf of IIASA, I'd just like to wish India well in its celebration of its 75th year of independence. Thank you, ladies and gentlemen.
Thank you, Dr. Pillai. And now may I request Dr. Amit Gar to say a few words.
I think I came today only, so I have not attended all the beautiful sessions as people are telling. But I think I will just give one suggestions. Whatever is being done, we cannot do everything. Of course, there are a lot of coverage. The program was excellently put by Sangeeta. I think what we should pick up, in my opinion, is initiatives which can help majority of people, masses. I think that is what is important for a institution like TIFAC, a system where more CSIR institutions can take part, where more IERI institutions can take part, where more other things can take part. I think I would suggest do not pick more than 5 initiatives which you take. Otherwise, it will become too heavy for everyone. So pick up 5 based on whatever your notes would be there, and prioritize those where majority of people of this country and other countries could be helped. And then let us take it forward. Science is very important, definitely, and I must thank IIASA. I have many friends at IIASA. I have been visiting IIASA, but of late I have not gone. Kevan is my very good friend. So I have not been able to go there, but I have deep respect for IIASA. One of my students is now at IIASA. He is doing a postdoc presently. So this is a tremendous event, I would say. I will not say anything further because a lot of things have been said. Thank you very much.
Thank you, Dr. Ambedkar. As I glance through this 3-day program, primarily the focus was on sustainable development and climate change, and also impact of climate change in energy, water, agriculture, and all those areas. And of course, today's program focused on disaster management. Now, you see, India has, it's a unique challenge that India gets from both sustainability point of view and also from the climate change point of view. See, India is on the path of, attaining high economic growth and high economic development. Our HDI is not as good as the Western world. So we can say that is why we say we are developing and we are yet to reach a peak. And then we are, to get these challenges of maintaining sustainable development and the climate change, both adaptation challenges and mitigation challenges. It is like something you are undergoing a course, and suddenly in the middle of the course, the syllabus has been changed. So you have to cope up with the new syllabus. So for India, it is new syllabus that has been introduced. We were already struggling with our various challenges. We have high poverty, we have high population density, our large diversity, and therefore these the SDG 2030 challenges that we are all 17 of them here. India is working, and we have been kind of working on each and every these 17 of these, and then we have done some work. Some good work, but still next 8 years is going to be tough for us because we have to meet all those challenges. And then comes the new challenges, which is much more formidable in terms of its impact on the country, is climate change. This new the IPCC report, the 6th IPCC report, has really brought out some very striking evidences for India and also the future impact on India. One issue that in fact going to impact India very badly is the extreme weather events. So first and foremost is the extreme heat, which is going to impact human health. It is going to impact the general livelihood, and more so to the poor people, and it will bring so much of, as Professor Sharma mentioned, that the governance will get impacted, how to manage extreme events. So especially the two parts, the extreme heat, which is direct impact of global warming, and the extreme rainfall, that is heavy rainfall, which is going to disrupt the cities and even the rural population. Now, this challenge of kind of going for how do we meet is also going to impact the weather forecasting, and the what is called the early warning system. Because then the challenge will be you predict more severe event, more frequent severe event, and more longer duration of severe event. That's a big challenge. And already there is a clear evidence. Last 40 years, evidence is that there is already a 20% increase in the number of extreme events in the country, in terms of intensity, in frequency, and duration. So that is a big challenge that we are going to have, and in future is going to have more and more such challenges. So, the other challenge is our mitigation challenge. What we have done well, as part of the India's NDC, all that emission intensity, or the renewable energy that we wanted to achieve, in fact, we have done better than what we have targeted for. So, for example, we targeted that we will achieve 40% of cumulative electric power installed capacity renewable by 2030. We already have achieved 38% by now. So there is a good, and similarly, the solar power, we targeted that we will achieve 20 gigawatt by 2022. We achieved, in fact, this 4 years in advance by 2018 itself, and now we are targeting 175 gigawatt for 2030 and to 450 gigawatt by 2040. Now, the real challenge that we are going to, now that our Honorable Chinese Panchamrit, in that last COP, all target, those 5 of them, are challenge for India. But the biggest challenge that, the target that's going to pose to us is the, carbon neutral, by 2070. Now, many of us know what we do not have a clear roadmap as of now, a clear understanding as to what is to be done to achieve carbon neutral by 2070. So, as per a rough estimate, the renewable energy that we will need by 2070 to achieve carbon neutrality should be the tune of 5,000 gigawatt of energy, which is nearly 10 times of, or more than that of today. This is a very high. But renewable energy alone cannot solve this issue if you need carbon neutral situation. And also remember that renewable energy has a limit. You can't have solar energy unlimited, because India has very kind of 4 months of monsoon, and during monsoon you have limitation on putting the solar panel and getting the energy. So therefore, with all, and similarly wind energy is very limited mostly on the western coast and central India. So renewable energy has a limit. Whether 5,000 gigawatt energy will be achievable or not, that we need to estimate. But more than that, as I said, there are 2 areas that India need to work. One is the coal side. So we need to work on the coal side, reduce the use of coal or have more liquid purified, the green coal by 2040 and have more introduction of those things, then we can have something, but that need to reduce the use of coal by 90%. Similarly, the use of crude oil by 90% by 2060. And introduce green hydrogen, introduce EV, all these areas need to be worked. So therefore, there is a multi-challenge for the country that bring renewable energy, reduce coal use, reduce crude oil use, and increase green hydrogen and increase the EV. So all that mix of that only can achieve the thing. So in fact, I just want to say that why I'm talking this thing, our context is that we in fact are contemplating that the TIFAC, along with the other agencies, in fact, interdepartmental and interministerial group, will work on creating a technology vision 2047, although 2030 is already there, 2035, but we need a technology vision 2047 because, we have to have 25 years vision from now. And so we are in fact planning to have that responsibility given to the thing. Also, several ministries put together working in the climate change research are in fact planning to bring or prepare a national research agenda on climate change, because that will in fact required, because in the kind of challenge that we have in both climate change adaptation and mitigation and science, we need a research agenda for going forward, at least for a decade from now. I'm very happy that this conference was in fact organized at a very right opportune time when these challenges are being posed to a country, and there is a need for scientists to come together. And I'm sure the TIFAC will be able to take this agenda forward, not just leave it to this conference. And so whatever deliberation has taken place, if we can have some kind of document summary of those things as a part of proceeding, will be very useful to all researchers and participants, and who can look at it. And also those proceedings and recommendations should be in fact sent to all departments and ministries for the thing, and we can have a interministerial discussion for implementing those recommendations. I'm sure Sangeeta is going to prepare those recommendations in detail. And so, we are happy that IIASA is in fact working very closely with TIFAC, and they can be a good knowledge partner with us to help us going forward in this thing. From GST side, full support to TIFAC and also the agencies who are involved in this exercise. So thank you very much, and I'm thanks to all the panelists for being part of this discussion. And I'm sorry we actually exceeded our time, and so sorry for that. But whereas these concluding will be useful for going forward. Thank you so much.
Thank you so much, Dr. Gupta. I really appreciate. I think we have taken lots of points now. I've jotted down lots of points which have come up from our panelists. And yes, we have a big challenge now how to move forward from this conference. Actually, definitely we would need a lot of support from IIASA also in terms of the modeling, and then we have to quantize that rather than just have the quality data. So I think these are very, very pertinent issues which we have discussed. And in case if there is some comments or something suggestions which have to come from my audience, so I would really appreciate if there is something like they would like to. Okay, there's one person, gentleman, Dr. Ghosh.
I think I just disagree with the first comment that you said that Indians are not good at modeling. I think we just don't know the direction in which we are trying to go. So I think we just need a direction, and there we have a lot of potential PhD candidates. I'm myself. So I think that would be something we should be looking at. So,
actually, I remember that you work for Celestial Earth, and Celestial Earth is Anindya Bhattacharya as well.
yes, yes.
And Anindya Bhattacharya was working as a consultant in NITI Aayog when this model on Messagex was being done, and this was IIASA's model. So yes, there's a capacity building which is happening. So we are becoming a good modelist. But again, this capacity building has happened. You worked on the same model which IIASA has developed. So we have to appreciate that also. Yeah. Thank you.
We did it better then.
Okay, that's good. That's why there's a capacity building. You have to learn and you have to pick up more. Yes. Anybody else? Yes, if you want to also, give some suggestions on email, we'll be happy to take it forward. And if we have something like, we have a few participants who have joined online also. And are there any comments? Any, no? Okay. So if there are no further comments, then okay. Yes, Dr. Naresh wants to say something. Yes.
Just to make a plea that we strengthen the partnership between the people who do the science part of systems analysis, together with the people who seek to do integrated public policy. So the plea is, and the recommendation is, that we seek a stronger partnership in India and set a stage for the world to see how government, public policy people outside of government as well might engage in a stronger way with the modelers and all the others who are working on systems.
Actually, yes.
And to make that concrete, I would suggest that the public policy schools in India might partner directly with several of the modelers and the systems analysts and so on.
Yeah, that's exactly has been our approach in this India IIASA initiatives. Like, when we have picked up any of the initiatives, any of the studies, we make sure that our policymakers, our stakeholders are also in loop, and then we get these things implemented and we try to see how we can bring it into the system. So that's exactly, because these are like, all these initiatives are not for publication, but yes, how to make this policy more relevant from the perspective of modeling exercises. So yes, we wrap up now. I think if there are no further questions. So though we are ending this session, but the journey has just begun. So this is a journey for change, how we can change our system, our resource planning, and our recommendation considering the entire ecosystem at large. So we are really motivated, the whole scientific fraternity who have come and who have participated, who have done so many deliberations in different sectors, which over the 3 days. And we look forward for all the sessions and every support in near future as well. And I just want to also tell you that all the PPTs and the pictures will be uploaded in the website. And we will also try to see if we can give you the link of those PPT session-wise so that you can make use of that. It would have, I think, these designations and also the email IDs of the respective speakers. Thank you very much for your support. And then we conclude. Thank you.